Python is one of the most emerging programming languages. According to the most recent figures, Python is the most used coding language for about 80% of developers. The syntax of this high-level programming language is simple to understand. Python's large library system makes it a best choice for data science, machine learning, and artificial intelligence projects. Now, considering the job opportunities in Python, tech giants like Google, Meta, Bosch, and many others hire Python developers with handsome salaries, with salary in India starting from Rs 5.1 lakhs per annum and may get as high as Rs 10 lakhs per annum, whereas the average base salary of Python developers in US is $105K and may get as high as $170K annually. So this definitely makes the point of interest for you to brush up your knowledge in Python, improve your coding skills, and get your dream job. So hello learners, welcome to Simplilearn's YouTube channel, and today we have come up with some amazing Python projects that will help you improve your Python skills. In this video, we will be covering all the basic to advanced level projects. Don't worry if you are a newbie or an advanced level developer. This video will help you in different aspects. Before we begin, let me tell you guys that we have regular updates on multiple technology videos. So if you are a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss an update from Simplilearn. Let's go through the agenda for this tutorial. We will start this video with IPL data analysis using Python, where we will see how the basic function works and helps in data analysis. We will also learn how to download images from website using Python. Following that, we will cover Python projects like automating Excel with Python, Instagram profile analysis, Spotify data analysis, and we will also create a QR code scanner and a music player using Python. Once we are done with the basic topics, we will move ahead and cover intermediate level Python projects like converting text to speech, creating a speech recognition system, sentiment analysis of Amazon customer reviews, OTP verification system, and World Happiness Report data analysis using Python. Moving on to advanced projects, we have movie recommendation system, face detection with a webcam using OpenCV Python, creating Instagram bots, Parkinson's disease detection using Python, and we will also learn how to create our own virtual assistant using Python. It is rightly said that you can master a programming language just by programming in it. I hope you guys are ready to learn something new. So without any further delay, let's start with the first topic for the day.
You must be aware that Indian Premier League, commonly known as IPL, is one of the most watched and popular events in cricket. It is held every year for a period of 2 months, usually between April and May. Only last year, that is in 2020, it was held a bit late because of the pandemic. So in this video, we will perform a exploratory data analysis and answer specific questions. But before we begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. Also, if you want to get the source code files and the datasets used in this video, then please put your email address in the comment section of the video. We will send you the files over email. So in this video, we will be using 2 datasets to perform our analysis. Now let me show you the CSV files. So this is my IPL dataset folder which is on my desktop, and these are the 2 files that we are going to use. The first dataset has information about matches played between 2008 and 2020. Let me open this dataset. Alright, you can see here there are total, let me just go to the top and I'll show you the number of rows we have. We have around 817 rows of information. Alright, you can see this is the match ID. So these are all unique IDs of the matches held between 2008 and 2020. Then we have the city in which the match was held. We have the date on which the match was played. We have the player of the match, which is man of the match basically. Then we have the venue column, that is the name of the stadium where the match was conducted. We have a column called neutral venue, whether the venue is neutral or not. Then we have the teams, team 1 and team 2. We have information about who won the toss. Then after winning the toss, whether they decided to field first or bat first. Then we have the winner who won the match. We have the results, whether it was won by runs or by wickets. Then we have the margin. So these big numbers are basically runs, 140, 33, all these are runs. If you see here, one of the match was a very close contest where the winning team won by just 6 runs. We have information about whether the match was an eliminator or a league match. We have a method, whether there was any DL method applied for deciding the result, and we have information about the 2 umpires. These are basically field umpires. Next, coming to the second data set. Now in the second data set, let me open it. Alright, so this dataset has all the information for each ball bowled since 2008 till 2020. You see you have the match ID, then we have the information about innings, whether it was a first inning or a second innings. We have which over it was, then we have which ball it was, basically the number of ball in an over. Then we have the batsman who faced the delivery, then we have the batsman who was at the non-striker end, or the player who was at the non-striker end. Then we have information about who the bowler was and how many runs were scored of that ball, whether there were any extra runs, and the total runs that were scored in each ball. We have whether it was a boundary or a non-boundary. Then we have whether there was a wicket taken in that delivery. Now we have information about player dismissed. Let me apply a filter and show you the values that we have. You can see here these are the players who have been dismissed. Now similarly, let's see for extra types. You have byes, leg byes, no balls, penalty, wide deliveries. Then we have the batting team and the bowling team. Alright. So we will be using these 2 data sets to perform exploratory data analysis and answer particular questions like the total number of matches played in each season, the total number of runs scored in each season. We'll also look at the number of tosses won by each team, the toss decision for each season. Then we'll see whether the team opted to bat or to field first after winning the toss. We'll also understand how a certain player has performed so far in IPL, the player who has scored the most number of runs, and who has won the most number of Man of the Match awards. Alright, so let me take you to my Jupyter notebook. So this is the Jupyter notebook we'll be using for our demo. I have already written a few lines of code. You can see it here. Alright, so let's begin with the first step, which is to import the necessary libraries. These are libraries matplotlib and seaborn. The next step is to load the dataset. So here I am loading 2 of my datasets, which is match_data and the balls dataset. So to load the dataset, I'm using pandas library and the read_csv function, and within this parenthesis I'll pass in my file location followed by the file name and the extension of the file. So here I have my dataset. Now let me copy this location and I'll paste the location here. We'll convert all the backslash to /, and finally I'll give my dataset file name. Let me just copy it and I'll paste it there. Okay, followed by the file name extension, which is .csv. Now I will just copy this, and similarly I'll paste for my second dataset. We'll replace the file name. I'll copy this file name and I'll paste it here. Okay, now let me go ahead and first run the first cell to import all the necessary libraries. You can see we have successfully imported all the libraries. Then let's run the second cell, which is to load the datasets. So the first dataset, which is IPL matches, I'm storing in a variable called match_data. This will be stored in the form of a data frame. And the second dataset, which is IPL ball by ball, I'm storing in a variable called ball_data. Let's run it. Okay, there is some error. Alright, we need to put these within double quotes. Don't forget to put the location within double quotes, otherwise it will throw an error. Now let's run it again. There you go. So I have successfully imported my datasets. Now let's print the top 5 rows from both the data frames. Now to print the top 5 rows, I'll use the head function. First I'll write match underscore data, which is my variable name for the first data frame, followed by the head function. If I run this, you can see I have the 5 rows from my matches data set. You see here we have the ID, the city, date, player of the match. If I scroll to the right, you can see winner, result, result margin, eliminator, method, and the 2 umpires. Similarly, let's see the top 5 rows from the ball dataset. So I'll write ball underscore data, which is my variable name, followed by the head function. Let's run it using shift enter. There you go. So we have the top 5 rows from the ball by ball dataset as well. Next, let's check if there are any null values in both the datasets. Now to check for null values, you can use the isNull function, and to find the total number of null values, you can use the sum function. So I'll write match underscore data dot. I'll use the isNull function to see if there are any null values, and to find the sum, I'll use the sum function. There you go. If I scroll down, you see here there are 13 null values or missing values in the city column. Then you have 4 null values in the player of the match column. Method, you have 797 null values. Similarly, you have some null values for eliminator and result margin as well. Let me just copy this. Now we'll check for null values present in our ball dataset. I'll replace this by ball. Let's run it. There you go. If I scroll down, here you can see for dismissal underscore kind, then you have player underscore dismissed, fielder, extra types. These all have a lot of null values. Okay. Now you can print the shape of the data frame and also all the columns present in it. For that, I'll use the shape method. I'll write match underscore data dot shape. You see here in our match dataset we have 816 rows of information and 17 columns. Similarly, if you want, you can check for the ball dataset. There you go. So the first value represents the number of rows, and then we have the number of columns. Now if you want to print all the columns present in a dataset, you can use the columns attribute. You can see it here in the result. We have all the columns printed that are present in the match dataset. Now let's look at the total number of matches played so far, the cities where the matches have been played, and the team which have participated. So for this I will be using 3 print statement. So I'll write print match played so far. I'll give a colon, and then with a comma I'll write my variable name, which is match underscore data, and I'll give shape as 0. Let's print this. You can see matches played so far is 816. Write another print statement. This is to check the cities in which the matches have been played, and I'll only print the unique cities. So I'll give a \n. I'll write cities played at. Let's give a colon now, and I'll use my variable, which is match underscore data, and within square brackets I'll give column name, that is city, so that it will extract only the city values, and I'll give my function as unique since I want to know only the unique cities in which the matches have been played. If I run this, there you go. So these are the cities in which the matches have been played from 2008 till 2020. You have Bangalore, Chandigarh, Delhi, you have Durban, Port Elizabeth, you have Centurion, there's Ahmedabad, Cuttack, Nagpur, Kochi, Kanpur, Bangalore, Dubai, and other cities as well. Okay, now we'll print one more result, that is the total number of teams that have participated so far. So I'll write print within single quotes I'll give \n so that there's a space. I'll write teams participated, give a colon, and then I'll give a comma. I'll pass in my variable name, which is match underscore data. Then within square brackets I'll give team1, and again I'll use the unique function. If I run this, in the result you can see these are the teams that have participated so far. You have RCB, the Kings 11 Punjab, Delhi Daredevils. Last year there was Delhi Capitals. You have the Rising Pune Super Giants, Chennai Super Kings, Kochi Tuskers, Deccan Chargers, and other teams as well. Alright. Now we will add a new column to our table that will have the year value extracted from the date column of the matches data frame. Now if I go to the top, I'll show you what I want to do. So in this matches data frame, you have a column called date, which has all the date values in which the matches were played. From this date value, I want to extract only the year. So let me show you how to do it. Now to extract the year value from the date column, I'll use a function which is datetime index. Now let me show you how to use it. I'll write my variable name, which is match underscore data, and I'll create a new column called season. Now this season column will have only the year values. I'll give pd dot, and I'll use my function date time index, and within this function I'll pass in my variable which is match underscore data, and within square brackets I'll give my date column. I'll come out and I'll give my attribute which is year. Now in the next line, let me print the head of the data frame. Now I'll write match underscore data dot head. If I run this, scroll down a bit, and I'll go to the right, you see the last column we have added a new column called season, which has only the year values. Now we will use this column, which is the season column, to perform multiple operations. Okay. Now let's look at the total number of matches that have been played or held each season from 2008 to 2020. So I'll give my variable name, which is match per season, equal to, I'll write match underscore data dot, here I'm going to use group by function which is present inside my pandas data frame. So I'm going to group all the season values. So basically I'm going to group all the year values so that I can know how many matches have been played each season. Now I'm going to count all the match IDs for each season. So I'll pass in my ID column dot, and I'll use my count function. Then I'll reset my index using the reset underscore index function, and then I'll rename my column. So I'll write rename, within brackets I'll give columns equal to, I'll pass in a dictionary. So I want to convert the ID column to matches. Alright, let me just see it again if everything is fine, and I'm going to print my new variable that I have created, which is matches per season. Let's run this. Some error has occurred. Let me check. It says match per season not defined. There's a small typo here. I have missed a S. So I'll run this again. There you go. You can see in the result we have all the seasons starting from 2008 till 2020, and Here we have all the matches that were played in each season. So you can see here in season 2013 there were the highest number of matches that were played, which was 76. Then in 2012 there were 74 matches. Similarly in 2011 we have 73. And if you see this result, in 2008 less number of matches were played overall, which was 58. Oh no, it's actually 2009 where 57 matches were played. Okay. Now we will visualize the above result by creating a bar graph that will show the number of matches held each year. So I am going to make use of this table, and using this table we'll create a bar graph. Now to create a bar graph, I'll use my Seaborn library which I had imported as SNS. I'll write sns.countPlot, which is to count the number of matches. So I'll pass in my data frame, which is match_data, and I'll give my variable as season, or the column name as season. Next, we'll use our matplotlib library. I'll write plt.xticks, which is an attribute to edit our x labels. I'll give the parameters rotation equal to 45, and I'll give my font size as, let's say, 10. Similarly, I'll use plt.yticks, and I'll give my font size as 10. Now I'll edit my x labels. I'll write plt.xlabel. In the x label we'll have the season values. I'll give my font size as 10. Then let me just copy this. We'll have our plt.ylabel, and our y axis would have the count. Font size, let it be 10. Then we'll give the title to our bar graph. So I'll write plt.title, and within single quotes I'll give a title to my plot, which is total matches played in each season. We'll also give a font size of, let's say, 10 again, and I'll use font weight as bold. Alright, let me now run this and show you how our graph looks like. There you go. So we have a nice bar graph. On the top you can see the title of the graph, which says total matches played in each season. On the y-axis we have the label as count. On the x-axis we have the label as season. And now let me show you what I meant by x-ticks and y-ticks. So I had rotated my x values by 45. So you can see the year values have been tilted and printed with 45 degrees. And then I had set my font size to be 10. So this is font size 10, and similarly count also we have font size 10. Now let's say if I want to rotate this by 90 and I print it, you see here the year values are now rotated in 90 degrees. Now what happens if I just remove this parameter and we'll only have font size? If I print it, you see this has been printed in horizontal order like we have it in the count column. I'll just paste it here again. Okay, now let's run it. So I have my year values. Okay, we'll move ahead and perform some more analysis. So in my current cell, which you see here, I am merging two columns from the matches data frame to balls data frame using a left join. So here I am adding the ID column and the season column present in my match_data frame, with the ball data frame, and I'm using a left join, and I'm joining using the common column which is ID, which is present in both the tables or both the data frames, and then I'm dropping my ID column. Let's go ahead and run this. Okay, you see here I've added my season column to my ball underscore data frame. Now we'll use this data frame now to perform some analysis. Now in the current cell which I have selected, let's visualize the total runs scored in each season. So what I have done is I have grouped my season values and applied a sum function to the total runs column, and then I have reset my index, and I'm plotting a line graph. You see here I've used sns.line-plot, which means I'm plotting a line graph to see the trend of runs scored each season. I have set my face color as black. We have a title called total runs in each season. I've given a font size, a font weight. Now before I run this cell, let me change my face color from black to gray so that my plot is clearly visible. Again, this palette you can choose whatever you want. Let me show you how you can select the Seaborn palette. If I search for SNS palette, there's a nice blog or an article from Seaborn, and here you can see we have all the palettes here. Whichever you want you can choose. There is hustle, we have set to, paired. There are so many. You can use whatever you like. Now let me go back. Let's run this cell. There you go. So here we have a nice line graph. Now if you see this line graph, in year 2009, least number of scores or minimum number of runs were scored compared to other seasons. We had the highest number of runs scored in 2013, which responds to this. So more than 22,000 runs were scored in 2013. Similarly, we had a drop in 2014, which was around 19,000 or less than 19,000 runs were scored in 2014. And if you see for 2020, which was last season, more than 19,000 runs or nearly 19,500 runs were scored in 2020. Okay, now moving ahead, let's see our next operation that we want to perform. I'll scroll down. Now I want to find the runs scored per match in each season. To do this, I'm concatenating the match per season data frame with the second column season data frame. So I am dividing the total runs scored each season. You can see it here. So I have divided the total runs by the matches played per season. Now I have set my index to season and I am printing runs per season. The result I am storing it in a variable which is runs scored per match. Let's just run this. There you go. If I scroll down, you see we have the seasons, the different seasons from 2008 till 2020, and you have the total matches that were played in each season. You have the total number of runs that were scored in each season, and then we have our last column which is runs scored per match. So here you have the total number of runs or the average runs scored in each match. Okay. Now we'll look at the number of tosses won by each team. For this, I'm finding the count of toss winners and then I'm creating a horizontal bar graph. So I'm using the value underscore counts function and I'm counting the toss winners for each of the teams. And here I have used my face color as gray, and then you can see I have set my title to number of tosses won each season. My X label is number of tosses won. On the Y label I have the teams. Let's just run this. Okay, if you see here on the Y axis I have the different teams, and on the X axis I have the number of tosses won by each team. You see Mumbai Indians so far have won the highest number of tosses, followed by Kolkata Knight Riders, then we have Chennai Super Kings, then we have Royal Challengers Bangalore, and if you see at the bottom we have Kochi Tuskers and Rising Pune Supergiants. Alright, the next cell of code will help us analyze the toss decision across different seasons. So if you want to find out whether the teams decided to bat or bowl first, I'm using a count plot or a frequency plot. Let me just run this and show you the results. So this is how the distribution looks like of the toss decisions across seasons. The purple color represents field and the red or the orange color represents batting, which means after winning the toss the team decided to bat first, and the purple color represents after winning the toss the team decided to bowl first. Now let me explain you what this graph tells us. In most of the seasons, the team that won the toss decided to field first. Only in certain cases, for example in 2009, the toss winning team decided to bat first. Similarly, if you see for season 2013, most of the teams preferred to bat first. And do we have anything else? No. If you see the other season, even in 2010, if you see, most of the teams preferred to bat first after winning the toss, but the rest of the seasons, be it 2008 or be it 2011, be it 2016, 17, 18, 19 and even 2020, most of the teams preferred to field first after winning the toss. Okay. Now we will look at the match results to analyze how many matches have been won in terms of wickets, meaning that the chasing team won the match. We will see how many matches have been won by runs, meaning that the team batting second could not chase the target. We will understand how many matches have been a tie so far. Now to get that result, I'll just write one line of code. I'll give my data frame name, which is match_data, and I'll use my result column, and then I am going to use my value_counts function. If I run this, okay, there is some error here. This should be value_counts and not count. There you go. If you see, most number of matches have been won by wickets, which means the team batting second won the highest number of matches, and there are less number of matches that have been won by runs, which means the team bowling second won the match, and then we had 13 ties so far from 2008 to 2020. Alright, now let's address some more questions. For example, if you want to know which stadium is best for winning by wickets, so I'll write match_data dot, I'll use the venue column which is present in my match_data frame, and then I'm going to use my condition as result not equal to runs, and then I'll use the mod function. If I run this, you see here Eden Gardens is the best stadium for winning by wickets. So you have higher chances if you bat second at Eden Gardens, you will win the match. Now see, you want to know which stadium is best for winning by runs. To do that, I'll just copy my above line of code, and instead of not equal to runs, I'll write not equal to wickets. If I run this, it says Firozshah Kotla. So Firozshah Kotla is the best stadium for winning the match by runs. So you have higher chances if you choose to bat first. Alright, now we want to know for any given IPL team which stadium is best when they win the toss. So to answer that question, I'll use my data frame which is match_data. Again, I'm going to use my column that is venue, and then I'll write match underscore data dot toss underscore winner. Let's say I'll write equal to my team I'll select is, let's say, Kings 11 Punjab, and then I'm going to use another square brackets and give match underscore data dot winner equal to I'll write again Kings 11 Punjab. Let me copy this, I'll paste it here, and then I'm going to use the mod function. If I run this, you see here the result is Punjab Cricket Association Stadium, Mohali, which is the home ground for Kings 11 Punjab. So for any given IPL team, if you want to know which stadium is best when they win the toss, most of the times you will find it is going to be their home stadium or the home ground. Now let's verify this with another team. Let's say I want to know in which stadium Mumbai Indians have won the maximum number of matches. So I'll choose my team as Mumbai Indians this time, and let's see which stadium it returns. If I run this, there you go. It says Wankhede Stadium, which is again the home ground for Mumbai Indians. Let's see for one more. Now I want for Kolkata Knight Riders. I'll copy this and I'll paste it here as well. If I run this, again it says Eden Gardens, which is the home ground for Kolkata Knight Riders. Okay. The next question I want to answer is, which is the best chasing team? That is the team that has won the maximum number of matches batting second. So for that, I'll write match underscore data dot, I'll use my winner column, and within square brackets I'll write match underscore data dot result not equal to runs, and then I want to use the mod function. If I run this, the result says Kolkata Knight Riders and Mumbai Indians are the best chasing team, which means they have won the maximum number of matches batting second. Now if you want to know the best defending team, that is the team that has won the maximum number of matches batting first, I'll just copy this line of code. Let me scroll down, I'll paste it here, and instead of result not equal to runs, this time I'm going to use result not equal to wickets. If I run this, it returns me the result Mumbai Indians, which means Mumbai Indians is the best defending team, that is the team that has won the maximum number of matches batting first. Now this one typical question that I want to answer now is, does winning the toss mean winning the match? To answer that, I'll create a variable called toss equal to, I'll write match underscore data, I use my column that is toss winner, then I'm going to compare it with equal to match underscore data, and then I'll see the winner. So here I'm choosing who won the toss and whether the same team was the winner. I'll create a plot here. I'll write plt.figure. I'm going to give a figure size. I'll write fig size, which is my attribute present inside the matplotlib function, and I'll give my figure size as 10,5. I'll use my count plot function present in the Seaborn library, and I am going to count the toss, and I'll display it using plt.show. Let's run this. Okay, we have a nice bar graph which says winning the toss doesn't necessarily mean winning the match. You can see we have a lot of false values here, which means after winning the toss, the team did not win the match. But there are a lot of true values as well. Now I want to answer one more question, which is, does choosing batting or bowling first help in winning matches? So for that I'll create another bar plot. I'll write PLT figure. I'll give my figure size equal to, let's say, 12,4. Then I'll write SNS dot count plot. I'll write match underscore data dot toss underscore decision, which is my column. Then I'll write match underscore data dot toss underscore winner equal to match underscore data dot winner. Then I'll just plot it or display it using plt.show. Let's run this. If I scroll down, you can visualize the result. We can say that choosing to field first for the toss winner helped in winning the match than batting first in IPL from 2008 to 2020. So there are higher chances if you choose to field first, you will win the match. Okay. Now we will use our ball by ball data set to see how a player has performed throughout IPL. Now for all these visualizations that we have created and we have seen so far, we were using the match dataset, which had information about the matches played from 2008 to 2020. From now on, we are going to use our ball by ball dataset. So the first thing I want to do is we'll analyze a performance of a player throughout IPL. So I'm going to take one of the popular players in IPL, that is Suresh Raina. So I'm going to create a variable called player equal to, I'll use my data frame name, that is ball underscore data, and then within square brackets I'll write batsman equal to I'll give SK Raina, because that is the name present in our dataset for Suresh Raina. Then I'll write data frame underscore Raina equal to ball underscore data. Within square brackets I'll write player. Then let me print the head of the data frame. I'll write df underscore Rana dot head. There is an issue here. Let me debug the issue. Instead of dot, this should be an underscore. Let's run it. Now the key here should be capital and not small. Let's run it again. There you go. If you see here, we have created a data frame only for the player name, that is Suresh Raina. You can see here SK Raina. Cool. Now moving ahead. Now in the current cell of code tells us how Suresh Raina has been dismissed throughout the IPL in all the seasons. So here I'm using the value counts for dismissal kind, and I'm going to use a pie chart. So let me run this. If you see here, okay, we have the dismissal kind and there is a nice pie chart. Now this pie chart tells us that Suresh Raina has been caught for 68.8% of the times, and then he has been bowled for 10% time. He has got run out 7.5% of the times, been caught and bowled for 5%, he has been stumped for 5%, and he has been given leg before wicket for 3.8% of the times. Alright, now moving ahead. In the next cell of code, we are trying to find the runs scored by Suresh Raina in ones, twos, threes, and in boundaries, that is 4s and 6s. So for that I am creating a user defined function called count, which will count the runs scored by Raina. I'll just run this so that you get an idea. Alright, if you see the results, Raina has scored the maximum number of runs by a boundary which is 4. Then he has scored the second highest number of runs by taking singles. Then he has scored the third highest number of runs by hitting sixes, and has scored the least number of runs by running a triple. Okay. Now if you want to know the details of the match that had the biggest win in terms of run margin, let me show you. If you want to analyze the match that had the biggest win in terms of margin, so you can use match underscore data, and then within square brackets I'll write my variable name again, match underscore data. Again I'll give a square bracket, I'll say result underscore margin. I'll give a condition equal to match underscore data. Then I'll say result underscore margin. I'll use my function that is maximum. If I run this, okay, so we have the details of that match. So this match was played in 2017 in the city Delhi. So I'm assuming this match was played at Firozshah Kotla, which is the home ground for Delhi Daredevils, which is currently known as Delhi Capitals. The player of the match was Simmons, who is from West Indies. You see here we have the venue, which is Firozshah Kotla. It was played between Delhi Daredevils and Mumbai Indians. The toss was won by Delhi Daredevils, but they lost the match, and the match was won by Mumbai Indians by runs, and the result margin was 146 runs, which is a huge number when it comes to T20 cricket. And you can see the season as 2017. Okay. Now let's find the players who have scored the maximum number of runs so far in IPL. To do that, I'll create a variable called runs equal to, I'll use my ball underscore data, and I'm going to use my group by function. So here I'm going to group the batsmen. So within single quotes I'll use my column which is batsman, and then I'm going to use the sum function over the column that is batsman runs. I'll write batsman underscore runs, and I'll give a dot and use my sum function, and I'll reset the index. Okay. Now in the next line I'll write runs dot columns. I'm going to create two new variables, which is batsman, and the second column would be runs. Next I'm going to give a variable called y, which is runs dot, I'm going to sort it. I'll write sort underscore values in terms of runs. So I'll write by my new column that is runs, comma, I'll give ascending equal to false, which means it will order my result in descending order. I'm going to find the top 10 batsmen in IPL who have scored the maximum number of runs. I'll write reset dot index, and then I'm going to drop my index, and I'll give axis equal to 1, which means I'm going to drop it in terms of columns. Let's print y. So what I'm doing here is, first I'm grouping all the batsmen, and then I'm going to find the total runs that they have scored. So I'm using the sum function. Then I'm creating two new variables or columns called batsmen and runs. I'm sorting the runs scored by the top 10 batsmen in terms of runs. Let's run this. Okay, let me check what is the error. It says column not found, batsman underscore run. This should be batsman underscore runs. Let's run it again. There you go. So we have Virat Kohli, there's Suresh Raina, David Warner, Rohit Sharma, Shikhar Dhawan, then we have Grayscale, De Villiers, Dhoni, Uthappa and Gambhir, who are the top 10 batsmen in IPL that have scored the highest number of runs. Okay. Now we will visualize the top 10 players who have scored the highest number of runs. So this is the code I have written already. Now you can use whichever palette you want. I have used face color as gray. Let's just run this and visualize the result. There you go. You have a nice bar plot, and on the top it says top 10 runs scorers in IPL. On the y-axis you have the total number of runs they have scored. On the x-axis you have the player names. So the first player who has scored the maximum number of runs is Virat Kohli. If you see the runs he has scored is close to 6,000 runs. Next we have is Suresh Raina. The second graph or the second bar is for Suresh Raina, followed by Warner, Sharma. We have MS Dhoni, Uthappa, Gambhir and other players. Cool. Now coming to our final visualization, where we'll see the players who have won the Man of the Match award maximum number of times. For that I'm using my column, that is player of the match column. Let's run it. If I scroll down, you see here AB de Villiers from South Africa, who currently plays for RCB, has won the highest number of Man of the Match awards, which is actually more than 25, I believe. Next we have Grayscale, Rohit Sharma, David Warner. You have Yusuf Pathan, Suresh Raina, Virat Kohli and Gautam Gambhir, who have won the highest number of Man of the Match awards. Okay, so let me go to the top and just give you a brief on what we did in this IPL data analysis demo. So first we imported our two datasets, match underscore data and our ball by ball dataset. Then we checked using the isNull function to see whether there are any null values present in any columns of the datasets. We used the shape function to display the shape of the dataset. We printed the total number of columns that are present in one of the datasets. We saw how you could extract the season or the year value from a date column. Then we printed the total number of matches played in each season. Then we converted that same result into a nice bar graph. Then we merged two columns from one of the datasets to another dataset, which was ball data. Then we saw the total number of runs in each season. We also saw the runs scored per match in different seasons. Now we visualized the number of tosses won by each season. We saw the toss decision across all the seasons, where we found out that most of the teams preferred to field first. Then if I scroll further, you saw how to answer different kinds of questions. Then we also learned how you can analyze a particular player and their performance throughout IPL. We saw for Suresh Raina and the dismissal kind. We also checked the pattern in which he has scored the runs. Finally, we found out the top 10 run scorers in IPL and saw who has won the highest number of Man of the Match awards. So if you want to get the source code files and the datasets we have used in this demo, then please put your email IDs in the comment section. We will share the files over email. Indian Premier League, that is IPL, is one of the most popular and exciting events in world cricket. IPL 2022 will begin on 26th of March, so it's the best time for us and our viewers to learn about how to perform exploratory data analysis using the recently held IPL auction dataset. So in this video, all the results and insights that you will see are totally based on the data we have collected from Kaggle, We will leave a link to the dataset in the description of the video. You can go ahead and download it. For this demo, we'll be using Python and Jupyter Notebook to answer specific questions. So let's get started. We'll move over to our Jupyter Notebook. Okay, so I'm on my Jupyter Notebook and this is the file that we are going to use. So here you can see I have some of the cells already filled in. So this will save us some time and we can explore this data set in depth. So this is the file that I'll be using, or the IPython notebook. Cool. So first let's go ahead and import all the crucial libraries that will be needed for our analysis. So here you can see I am importing the pandas library, the numpy library. These are for data manipulation and numerical computation. Then we have seaborn and matplotlib for data visualization. Then I have imported this warnings module so that we do not get any warnings while running the code. Cool. So let me just hit Shift Enter to run the first cell. So here we will import all the libraries. Okay, it's done. Now the next step is I'm going to create a data frame in the name of IPL, and here I'm importing the dataset using the read_csv function, which is part of the pandas library. So PD here has been imported as pandas. I'm giving the dataset location followed by the name of the dataset. So here the name is IPL_2022_dataset.csv is the extension of the file. So let me go ahead and run this as well. Alright, so now we have successfully imported or loaded our dataset. Now the next step, let's go ahead and explore our dataset. So I'll use the head function for this, IPL.head. Okay, so here you can see the different columns. We have an unnamed column which is actually unnecessary for our analysis, so we'll see how to drop this column. Apart from that, we have the name of the players, the base price at which the player was sold, or whether the player was a draft pick. So here Rashid Khan from Afghanistan, Hardik Pandya, then we have Subman Gill. These are all draft pick, and then we have the price at which the players were listed in the IPL auction. Then we have the type of player, whether the player is a bowler, an all-rounder, a batsman, or a wicketkeeper. Then we have the cost in rupees. This is in crores. So basically this column tells us the price at which the player was sold in the auction. Then we have the price or the cost in dollars. After that we have 2021 squad. Basically this means in last year's IPL, where was the player? So here you can see Rashid Khan was playing for SRH, the Sunrisers Hyderabad, in 2021, but this year in 2022 he'll be playing for Gujarat Titans. Similarly, Hardik Pandya was playing for Mumbai Indians for past few seasons, including 2021, but this season is going to play for Gujarat Titans. So on and so forth. Now let's see the total number of players that are present in the dataset and the total columns that are there. For this, I'm going to use the shape attribute. So I'll write IPL.shape. You can see here there are total 633 players that were part of the auction, and this includes the players who were draft pick also. And there are total 8 columns in my data frame IPL. Next, let's use the info function to check the columns, the data types, and the total non-null objects. So I'll say IPL.info, which is a function, so I have to use brackets. There you go. So here you can see it says total 633 entries from 0 to 632. Data columns, we have total 8 columns, and then these are the different column names, and here you can see the total non-null objects present in the column, and here you can see the data types, and at the bottom you can see the memory usage as well. Cool. Now the dot columns attribute will return the name of the columns in the data set. So if I say IPL.columns and run it, it will give me all the different column names that are present in the data frame. Now as I said, the first column, which is unnamed :0, is actually unnecessary. So we are going to drop it. For that, we are going to use the dot drop function, and then I have passed in my column name followed by the axis, on which axis is it there, and then I say in place equal to true, which means it will replace and permanently remove the unnamed column from the data frame. So let's run it, and now we'll again check the head of the data frame. You can see before we had the unnamed column, which was the first column in the data frame, and now we have successfully removed it. So player becomes the first column in the data frame. Alright, now moving ahead, let's see the total number of null values that are present in each column of the dataset. So I'll say IPL dot, I'm going to use the isNull function followed by the sum function. If I run this, you can see here the player column doesn't have any null values. Similarly, base price and type column also don't have any null values, but you can see cost in rupees and cost in dollars have nearly 396 missing or null values. The reason being those players were not picked in the IPL auction, and hence there was no price associated. And then you can see there were a few players who were not part of the IPL squad in 2021, so those are being reflected as null as well. Now we'll check the rows that have cost in dollar as null or NaN. So here I have used IPL, and after that I'm passing in the column name, which is cost in dollars, and then I've used the isNull function. If I run this, you can notice the cost in dollars column, all these values are NaN or null, and even the same rows have NaN for cost in rupees as well. Cool. Now the next task is to fill these null values or NaN values with zeros. So for that, I'm going to use the fill NA function, and here I have passed in 0. So all the null values in the dataset will be replaced with 0 for cost in rupees column and cost in dollars column. Let me just run it. Alright. Okay. Now we will see the players who were unsold in the 2021 auction, which means we will check the rows that have null values for the 2021 squad column. So what I'll do is I'll say IPL, within square brackets I'll say IPL, and then I'll pass in my column name, which is 2021 squad, and then after this I'll say dot isNull. So this cell will give us the unsold players in the 2021 auction. If I run this, you see here, you mark the 2021 squad column, all these players were unsold or did not participate, so hence it has NaN values. Alright. Now what we are going to do is we will replace all the null values that are present in the 2021 squad column with not participated. Like how we did in the previous example, we replaced all the null values with 0. Here we'll replace with a text value called not participated. So I'll say IPL, I'll pass in my column name, which is 2021 squad, equal to, I'll say IPL 2021 squad dot fill NA, which is the function, and here I'll pass in a text or a string saying not participated. Alright, let's run it. Before that, let me just scroll it down. Now I'll run it. Cool. Now that we have treated the null values successfully, let's verify it again. So I'll just say IPL dot is null, and then I'm going to use the sum function. If I run this, okay, this is also a function. Cool. Now if you see, we have successfully removed all the null values and replaced with either zeros or not participated, and hence now you can see none of the columns in the IPL data frame have null values, so it shows 0. Great. Now moving ahead, now we are going to add another column called status, which will hold two values, sold and unsold. But before that, we are going to slice our data frame. So here I am looking for all the rows where cost in rupees is greater than 0, and those should be unique, and I'm storing the value in a variable called teams. So here you can see we have the different teams where the cost in rupees is greater than 0. Now I'm going to create another column called status. So I have written IPL within square brackets. I'm passing in the column name, which is status, and that will be equal to the team replaced by sold value. Let me just run it and show you the result. There you go. So here you can see we have added a new column called status, and it has values sold and unsold. If I just say IPL, at the bottom you can see the unsold values as well. Cool. Now in the next cell, we are going to check for duplicated players. So there are duplicate rows in the data frame, but here the names of the players are same, but in reality the players are different. So it is quite understood that different players can have the same name. So to get those names, I am using the duplicated function, and I'll say keep equal to false, which means I don't want to keep those players. Now let's run it. There you go. So here you can see Lalit Yadav, we have two entries. So Lalit Yadav here is an all-rounder whose base price was 20 lakh for 2022 IPL, and last year he was playing for the Delhi Capitals, and this year also he is sold to Delhi Capitals. Next we have Lalit Yadav, who happens to be a bowler. So this is again different Lalit Yadav. So last year he was unsold, and even this year he remains unsold. Similarly, we have Amit Mishra, who earlier used to play with the Delhi Capitals, but this time he remains unsold, so on and so forth. So you can see two entries for Subham Singh as well and Shivam Mishra. Alright. Now let's answer a very basic question. We are going to find out how many players have participated in the 2022 IPL auction. For that, we have already seen the total number of rows that were present, but again I'm going to use the shape function, and within square brackets I'm going to say 0, which means it will give me the total number of rows, and you can see 633 players were part of the auction. This is as per our data that we have collected from Kaggle. Up next, we are going to find how many types of players have participated. So I'm going to say types equal to, say IPL, I'll use the column name which is type, and I'm going to find the count of each type of players that are present in the data frame. I'm going to use the values underscore counts function, and then I'll say type dot reset underscore index. If I run it, okay, there is an error here. Let me debug the error. Okay, so this should be value underscore counts, and the variable name is types and not type. So let's run it. You can see here we have the different types of players. So all-rounders, there are total 242 all-rounders who are part of the auction. Then we have 215 bowlers, 112 batsmen and 64 wicket keepers. Now using the above table that we just created, I'm going to plot my first pie chart. So for that I'm going to use the matplotlib pie function. So plt.pie, I'm using types.values since I want only the values from this table, and then I'm saying labels equal to types.index. I've used a label distance of 1.2 to maintain some space, and then this is my format in which I want to print or show or display the percentage of distribution. I am going to use shadow, so it says shadow equal to true, which is another parameter or an argument, and then I'm going to start my angle at 60 degrees, and here I have used a title called roll of players participated that will have a font size of 15, and finally I'm saying plt.plot. So let me just run it. There you go. So here we have a nice pie chart or a pie plot. So you can see the different pies here. We have all-rounder, wicketkeeper, batter and bowler. So majorly there are all-rounders in the auction followed by bowlers. Then we have 17.69% batters and 10.11% wicketkeepers, which is the lowest. Cool. Now we are going to create another bar plot or a bar graph that will tell us how many players were sold and unsold. So for this I'm going to use a count plot. So we'll create two bars, one for sold and the other one for unsold, and each of the bars will have different colors. One will have orange, the other one will have pink, and I'm using labels. So to label the x-axis and y-axis, I have sold or unsold. Y label will have number of players. The title of my bar graph would be sold versus unsold. I've given a font size of 15 and I'm saying plt.plot. Now the function that you see here at the bottom will display the data labels for each of the bars. Let me just run it and show you the result. There you go. So I have used a figure size of 10,5. Alright, now you can see we have a really good bar plot which says there were total 237 players sold and 396 players were unsold as per the data we have. Cool. Now you can also print the total sold and unsold values. Let me show you how to do it. I'll say IPL dot, we can use the group by function, and I want to group it by status column, and the value that I want to measure is the players count. So I'll say players, rather player, and then I'm going to use the count function. If I run this, you can see here I've successfully grouped the unsold and sold players. The values are matching with the bar plot that we just created. So sold were 237 players and unsold are 396. Cool. Now we are going to see the total number of players bought by each team. Again, this is going to be a count plot, so basically a bar plot. So here the condition I'm passing is in the teams column the value shouldn't be unsold. So players bought means the value should be sold. So here I'm using this condition and the rest of the things remains the same. One improvement I have done here is I'm using x-tex rotation equal to 70 degrees. This basically means the x labels would be tilted by 70 degrees. Now let's see the bar plot. There you go. So here you can see I have the title players bought by each team. On the y-axis we have the number of players, and on the x-axis you can see the values have been tilted by 70 degrees. Let me just zoom in so that you can see it better. And this is the bar plot. So the maximum a team can purchase is 25 players. Some of the teams have also purchased 24, 22 and 23 players. Let me just show you. So Gujarat Titans have totally purchased 22 players. Then Delhi Capitals have total 24 players in their squad. Again, Lucknow Super Giants have 22 players. If I scroll and see again, Bangalore Royal Challengers or RCB, the Royal Challengers Bangalore have 22 players in the team, and Rajasthan Royals and Sunrisers Hyderabad have 24 and 23 players respectively in their teams. Alright, now we will create 3 more columns called retention, base price and base price unit. For that, first of all, I am creating a new column called retention, which is equal to IPL base price. Let me just run it, and then I'm going to replace these values that are present in the list: 2 crore, 40 lakh, 20 lakh, 1 crore, 30 lakh, 1.5 crore with from auction, and I'm saying in place equal to true. Let me just run it. Then we are going to treat the base price. So here in the base price column, I'm going to replace draft pick value as 0. So let's run that as well. And now I'm going to split the base price value into two separate values called base price unit and base price. So basically I'm splitting on the space that I have. Let me show you how it is going to split. So this is, let's say, our base price column. What I did was I replaced the draft pick values to 0, and then the rest of the values will be split into two columns called base price unit. So basically it will have the unit of the base price, let's say crores or lakhs, and the base underscore price column will have the value, which is 2, here 40, 20, 20, so on and so forth. Let me just scroll down and run that particular cell. Now to create these two columns, the base price unit column and the base underscore price column, I have used the lambda function and I'm splitting based on the space. Let's just run it. Now I have replaced retained with 0, and let me show you the final data frame that I have. So here you can see we have replaced the draft pick values in the base price column to 0, and on the right side you can see the 3 different columns that I wanted to create. So one is called retention. So zeros refer to draft pick. Any other value will say the player was picked from the auction. Then you have the base price unit. So here you can see crores, lakhs, and the value base price is 2, 40, so on and so forth. Cool.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's check how many players were retained and bought from the auction by each of the teams. So I'll say IPL, let me just scroll down, dot, I'm going to use the group by function. Then I'll say team, comma, retention. Then I'm going to use the value as retention because I want to find the count of retained players. And then I'll say colon -1. Let me run it. You can see here the different team names because I have grouped by team and then retention. So I have Chennai Super Kings. From the auction they had picked 21 players and they had retained 4 players. Coming to Delhi Capitals. Delhi Capitals in the 2022 IPL auction, they picked total 20 players and they have retained 4. Similarly, if I scroll down, let me talk about, let's say, Punjab Kings. They have picked 23 players from the auction and retained 2 players from the team last year. Talking about RCB or Royal Challengers Bangalore, they have picked 19 players from the auction and they have retained 3 players. Alright. Now in the next cell of code, we are going to display the players in each team based on the different types of players. So let me just run it and show you the result. So here I am using the same condition. The value shouldn't be equal to unsold, and I'm going to use another parameter called hue for the different colors. So here I have used hue as type because I want to show the players in each team based on the different types. Again, I have given my title to the bar plot, and then I have the X label, the Y label, and my rotation is 50 degrees now. If I scroll down, you can see the different types of players. Here is the legend. So blue is for bowler, orange or yellow is for all-rounder, green is for batter, and red, which also looks like maroon, is for wicket keepers. And on the x-axis you can see the different team names. Alright, now let's answer another couple of questions. So here I have, what is the highest amount spent on a single player by each team? So to solve this question, I'll say my data frame name, that is IPL. Then I'm going to say retention equal to, this should be from auction because we want to see the highest amount spent and not from the retained players. Then I'm going to group by, I'll say team, and then I'll say cost in, let me just copy it from here, cost in rupees, that is in crores, and I'll say max colon -1 dot sort underscore values, I'll say ascending equal to false, which means I want the sorted result in descending order. Okay, let me just bring this to the left side and we'll run it. There seems to be some error. Let me check the error. It says there's a spelling mistake. This should be team. Let me run it again. There you go. So you can see Mumbai Indians have spent 15.25 crores for one of the players, and this player happens to be Ishan Kishan. Then Chennai Super Kings have spent the highest amount for a player who happens to be a bowler. The name is Deepak Chahar. They have bought him for 14 crores. Kolkata Knight Riders bought Shreyas Iyer for 12.25 crores, and so on and so forth. So these are the highest amounts spent on a single player by each of the teams. Let me scroll down. Now we are going to see the player retained at maximum value or maximum price. Now if you follow IPL, the maximum price at which a player was retained happens to be Ravindra Jadeja. So let's see at what price was he retained. I'll say retention equal to, I'll say retained, then I'll say sort underscore values, buy equal to, I'll use the same column, cost in rupees, that's in crores. I'll say ascending equal to false dot head, and I want to find the top player. Again, there's some error. Let's see, where is the error? Says ascending equal to false dot head. Okay, this should be sort underscore values. Within bracket I should say buy. I think this should be fine now. Let's run it. There you go. So you can see here our result is player name Ravindra Jadeja, who was retained for 16 crores by Chennai Super Kings. Cool. Now the next cell of code will display or print the top 5 bowlers who have been picked in this year's IPL based on their cost in INR. Let me just run it and show you the result. You can see here Deepak Chahar went for 14 crores. Then we have Shardul Thakur, who was bought by Delhi Capitals. Earlier he was part of CSK for 10.75 crores. Then we have Prasidha Krishna, who has been bought by Rajasthan Royals this time. Last year he was with KKR and he has been bought for 10 crores. Similarly, Lockie Ferguson has been bought by Gujarat Titans and he played for KKR last season. He has been bought for 10 crores while his base price was 2 crores. Then we have Avesh Khan. You can see Avesh Khan's base price was just 20 lakhs and he has been bought for 10 crores by Lucknow Super Giants again, and last year he was part of the Delhi Capitals. Now you can replace this value. Suppose, let's say you want to find the top 5 batsmen picked or batters picked with the highest amount. You can just say batter instead of bowler, and if I run this, you can see here Shreyas Iyer was bought by Kolkata Knight Riders for 12.25 crores. Last year he was part of Delhi Capitals. Then you have Shimron Hetmeyer, who's from West Indies. He has been picked by the Rajasthan Royals for 8.5 crores. Then we have Rahul Tripathi, Shikha Dhawan and Devdutt Padikkal. Now if you wanted to check for, let's say, all-rounders, you can replace batter with all-rounder. If I run this, you can see Liam Livingstone has been bought by Punjab Kings this season for 11.5 crores. His base price was just 1 crore and last year he was part of the Rajasthan Royals. Then we have a player from Sri Lanka, Hasaranga. Then we have Harshal Patel, Shah Rukh Khan and Rahul Tewatia, who have been the top 5 all-rounders picked at highest amount. Cool. Now finally, we want to see the players who were part of the IPL last season but were not picked for this year's IPL. So for that, what I'm doing is, first I'm renaming my 2021 squad column. This column I want to rename it as previous team. Let's run it. Then I'm going to find out the unsold players. So here I'm saying previous team not equal to not participated, and then I'm using another condition. The team should be equal to unsold, and I'm going to find out only the player and the previous team. So let's run it and see the result. So here you can see these players were part of the IPL last season but they haven't been picked this season, and last season they had played for, let's say, Suresh Raina played for CSK, Steve Smith was part of the Delhi Capitals, Saqib Al Hasan was part of KKR. If I scroll down, you have David Malan, who played for Punjab Kings in 2021, Owen Morgan, who played for KKR. He also captained KKR, but unfortunately he was not picked this season. Chris Lane from Australia also remained unsold this season. Andrew Tai, we have Ben Cutting, Aditya Tare, There are other players as well. We have Kane Richardson, Dhaval Kulkarni. Cool. So these were the players who were part of the IPL season 2021, but unfortunately were not picked and remained unsold for 2022 season. Cool. And that brings us to our end of this demo session on IPL data analysis 2022. So we learned how to use the different functions and attributes that are part of the Python libraries, and we manipulated the data, we visualized the data and answered some specific questions. Hi everyone, welcome to this video tutorial on Python data analysis project for 2022. In this video, we'll be covering two interesting hands-on projects using Python programming. You will learn how to use real-world data to perform data analysis and data visualization. The two projects are based on coronavirus and Olympics data. You will learn to collect, analyze, clean, manipulate and visualize data with the help of Python libraries such as NumPy, Pandas, Matplotlib and Seaborn. These two projects will give you the idea to solve real-world problems using exploratory data analysis. So let's get started with our first project. Today, we are going to perform two hands-on projects on COVID data analysis using Python and Tableau. This is going to be a really interesting and fun session where I'll be asking you a few generic quiz questions related to coronavirus. Please make sure to answer them in the comment section of the video. We'll be happy to hear from you. COVID or coronavirus is an ongoing global pandemic of coronavirus disease that emerged in 2019 and was first identified in Wuhan, China. It is defined as an illness caused by a novel coronavirus called Severe Acute Respiratory Syndrome Coronavirus 2, commonly known as SARS-CoV-2. On March 11, 2020, the WHO declared COVID-19 a global health emergency. The virus has so far infected over 22 crore people and killed more than 4.5 million innocents. In India, there have been over 3.3 crore confirmed cases and nearly 4,41,000 deaths have been reported so far. This data is according to official figures released by the Union Ministry of Health and Family Welfare. As the world tries to cope up with this deadly virus, we request all our viewers and their family members to follow all the necessary precautions to avoid getting infected. Quiz time. Now let's see our first quiz in this project. What does corona in coronavirus mean? Here are the options. Is it A. beer, B. respiratory, is it C. crown, or is it D. sun? This is a very generic question. I'm sure a lot of you may already know, some of you may not. Please let us know your answers in the comment section of the video. We'll be glad to hear from you. Now in this video, we will use three different COVID-19 datasets and perform data analysis using Python and Tableau. The project will give you hands-on experience working on real-world datasets and how you can use the different Python libraries to analyze and visualize data and draw conclusions. You will learn how to create different plots in Tableau and then make a dashboard from the visuals. The project will give you an idea about the impact of coronavirus globally in terms of confirmed cases, deaths reported, the number of recoveries, as well as active cases. We will also see how India has been affected since the pandemic started and dive into the different states and union territories to learn more about the COVID-19 influence and the vaccination status. First, let me show you the two datasets that we'll be using. So for our first project using Python, we'll be using the first two datasets, COVID-19 India and COVID vaccine statewise. Let me open the two datasets. Okay, so this is the first dataset. You can see here we have the date, we have the time, then we have the different state names. If I scroll down, you can see we have Kerala, Tamil Nadu, Delhi, Haryana, Rajasthan, Ladakh, Punjab, Telangana and other states. Then we have something called as confirmed Indian national. So actually this two datasets, confirmed Indian national and confirmed foreign national, we won't be using. So in the demo itself, we'll be dropping these two columns. What we are concerned about are the last three columns, the cured cases or the recoveries, the number of deaths reported, and then we have the total number of confirmed cases. Let me just sort the B column, that is the date column, so that you have an idea about the recent data we have. I'll continue with the current selection and sort it. You can see here, this is till 11th of August 2021. So this data was collected from Kaggle. It has some discrepancies that we will see in the demo. The data is available for free. We will provide the link to the datasets in the description of the video, so please go ahead and download them. The visualizations and results that you will see in the demo are based on the datasets that we will be using. We haven't pre-processed the data to remove outliers or any missing values. Now before I jump into the demo, let me show you the second dataset that we are going to use. Okay, so COVID vaccine state-wise is my second dataset. Let me open it. There you go. So this is the second dataset that we'll be using in the Python project. You can see we have a column called updated on, then we have the state. Again, you can see here there are a few discrepancies here. It has taken the country name and not the state name. Below you can see there are the different state names, and you can also see we have information about the total doses administered. We have the sessions, sites, first dose administered, then we have the second dose, then we have information about male and female doses. You can see here the different vaccines administered, Covaxin and Covishield. You have Sputnik V, and here are the different age groups as well. And finally, if you see, we have male individuals vaccinated, the total number of female individuals vaccinated for a particular day. We have information about transgender individuals vaccinated, and finally we have the total individuals vaccinated each day. Alright, before we jump into the hands-on part, let's have a look at the second quiz in this project. So here is the second quiz question. Which is the first country to start COVID vaccination for toddlers? Is it A, Japan, B, Israel, C, Portugal, or is it D, Cuba? This is a very recent development that took place. If you watch daily news updates on coronavirus, you will be definitely able to answer the question. Please give it a try and put your answers in the comment section of the video. It is really important for our viewers to know the right answer. Alright, so now let's begin with our demo. So I am on my Jupyter notebook. So the first project we are going to use Python Jupyter notebook. I'll just rename this notebook as COVID data analysis project. I click on rename. Alright, so first and foremost we need to import all the necessary libraries that we are going to use. So first I'm importing pandas as PD. This is for data manipulation. Then we have numpy as NP. Numpy is used for numerical computation. Then we are importing matplotlib, seaborn, and plotly. These three libraries will be used for plotting our data and creating interesting visualizations. Finally, I'm also importing my datetime function. Alright, so I'll hit Shift Enter to run the first cell. Now it's time to load our first dataset, which is related to the COVID-19 cases in India for the different states and union territories. So I'll create a variable called COVID_df. df is for data frame. I'll use my pandas library and then give the read_CSV function, since our datasets are CSV files, and inside double quotes I'll pass in the location where my datasets are present. So I'll just copy this location, I'll paste it here. We'll change the backslash to /, and after that I'm going to give my file name followed by the extension of the file. I'll say COVID-19 India.csv. Let's go ahead and run it. Alright, now to see the first few rows of the data frame, I'm going to use the head function. I'll say head, and within brackets, let's say I'll pass in 10, which means I want to see the first 10 rows of data. If I run it, there you go. Here you can see from 0 till 9. So we have 10 rows of information, and these are the different column names. You have S number, date, time, state or union territory, then you have confirmed Indian national, confirmed foreign national, cured cases, deaths reported, and the confirmed cases. Alright, now moving ahead, let's use the info function to get some idea about a data set. If I run it, you can see here it gives us the total number of columns. We have 9 columns. The total number of entries or the rows, we have 18,110 rows of information starting from 0 till 18,109. You see here the different types of variables or column names that we have. Then it has information about the memory usage as well. And this side you can see the data types. Cool. Now we'll use another very important function, which is to get some idea about statistical analysis, the basic statistics about your data set. For that I'll be using the describe function. Okay, so if you can see here, the describe function is for numerical columns only, and you have the measures such as count, the mean, standard deviation, maximum, minimum, the 25th percentile, 50th percentile, and the 75th percentile value. Okay, now let's move ahead and import the second data set, which is related to vaccination. So I'll create a variable called vaccine_df. I'll write pd.read_csv function, which is present in pandas library. I'll move to the top and I'll copy the file location, and we'll change the name of the file. Copy this and let me paste it here, and instead of COVID_19_India, I'm going to say COVID_vaccine_statewise. Okay, so this is the dataset that we saw, COVID_vaccine_statewise. Alright, let me run it. Cool. And let's display the first 7 rows of information from this data frame. I'll be using the head function, and inside the function I'll pass in 7. There you go. So here you can see we have from 0 till 6. There are total 24 columns. A lot of them have null values, you can see here. Alright. Now from the first data set, which is the COVID_df data frame, we'll be dropping a few unnecessary columns such as the time column, confirmed Indian national and confirmed foreign national, as well as the S number. We don't need these columns, so it's better to learn how to drop the columns for our analysis. So I'll say COVID_df dot, I'll use the drop function, and within square brackets I'll pass in the column names. The first is S number. I'll give a comma. Within double quotes I'll say the next column is time. My third column that I want to drop is confirmed Indian national. Give another comma. Within double quotes I'll say confirmed foreign national. Outside the square brackets I'll give another comma and pass in my next argument, that is in place equal to, I'll say true. I'll give another comma and say axis equal to 1. Let's run it. Okay, it has thrown an error. Let's debug the error. Says confirmed Indian Okay, it should be Indian national and not Indian nation. I'll just mention it as national. We'll run it again. Okay, now we have removed these 4 columns. Let me show you the dataset now. There you go. So we have only the date column, state or union territory, cured, deaths and confirmed. Now let's see how you can change the format of the date column. For that you have the function called toDateTime. I'll say COVID underscore df. I'll pass in my column name, that is date. I'll say equal to pd dot. I'll use the pandas function, that is to underscore date time. I'll say COVID underscore df, which is my data frame name. Pass in my variable, which is date. Give a comma, and I'll use my argument, that is format, equal to. I'll say percentage %y, give a dash, say percentage %m, give another dash and say percentage %d. Let's run it, and I'll print the head of the data frame. Cool. Now moving ahead, now we will see how to find the total number of active cases. So active cases nothing but the total number of confirmed cases minus the sum of cured cases plus deaths reported. So let's find the active cases. I'll give a comment. Okay, I'll first write my data frame name, that is COVID underscore df. Within square brackets I'll give my new column, which is active underscore cases. I'll say equal to COVID underscore df, and my first column would be the confirmed cases column minus, I'll say COVID underscore df. Then I'll pass in my cured column plus, I'll again say COVID underscore df and add my deaths column. This time let's print the last 5 rows from the new data frame that we have created. Okay, let's run it. Okay, it has thrown an error. Let's debug it. Says data frame object has no attribute tails. This should be tail. There you go. You can see here we have added a new column called active cases, which is the confirmed cases minus the sum of cured and deaths reported column. Now we will learn how to create a pivot table using the pandas library. So in this table we'll be summing all the confirmed deaths and cured cases for each of the states and union territories. So we'll be using the pivot underscore table function for this. I'll create a variable called statewise and say pd dot. I'll use the pivot underscore table function. I'll pass in my data frame, that is COVID underscore df, and then I'll give my values parameter. Inside the square brackets I'll pass in my columns confirmed, deaths, and then we'll have the cured column. I'll give a comma, and next argument would be index, which is going to be my state slash the union territory column. Let me bring this to the next line so it is more readable. I'll say union territory. I will give a comma now and pass in my last argument, which is agg function, that means aggregate function, and this function would be max. Alright, let's run it. Okay, now I'm going to find out the recovery rate. So recovery rate is basically the total number of cured cases divided by the total number of confirmed cases into 100. So I'll say state-wise, and within square brackets I'll pass in my variable that I want to create, which is recovery rate. This will be equal to the cured cases multiplied by 100 by the total number of confirmed cases. Within square brackets I'll give my column as confirmed. Let's run this. Okay, I'll just copy this column, paste it here. So this time we are going to find out the mortality rate. So mortality rate is nothing but the total number of deaths divided by the total number of confirmed cases into 100. So I'm just going to replace the names. Here I'll say mortality. Alright, and then instead of cured I'll say my deaths column into 100 divided by the confirmed cases. Let's run it. Okay, now we are going to sort the values based on the confirmed cases column, and we'll sort it in descending order. So let me show you how to do it. I'll say state-wise equal to, I'll use the function sort underscore values. So I'll pass in my variable state-wise dot and use the sort underscore values function. I'll say by, I want to sort it by my confirmed cases column. Give a comma and I'll say ascending equal to false. Let's run it. Now we are going to plot our pivot table using a nice visual. So for that I'm going to use my background underscore gradient function, and inside that function we'll pass in our CMap parameter. I'll show you how to do it. I'll say style dot background underscore gradient, and inside this we'll pass in a parameter called CMap. So CMap stands for color maps. This is present inside the matplotlib library. So here you can see there's a nice documentation on choosing color maps in matplotlib. This is provided by matplotlib.org. If I scroll down, you can see there are a number of CMaps that you can use. Purples, blues, you have something called reds. There are other things like magma, you have summer, autumn, spring, winter, cool, all these. You can use whichever color map that you want, and here you can see the different shades or the gradients. Okay, so I am going to use my color map as cube helix. Let me run it and show you the pivot table. There you go. Here you can see we have our pivot table ready. Now, as I said in the beginning, there are a few discrepancies in the data set. So here you can see there's one called Maharashtra, and there's also Maharashtra triple star. this you can ignore. Even if I scroll down, you have Madhya Pradesh followed by 3 asterisks. You can ignore this value as well. Even for Bihar we have. So these have been duplicated, and here you can see the different state names and union territories. Then on the top you have the confirmed cases, cured cases, the deaths reported, and the new columns that we created. These are calculated columns, recovery rate and mortality rate, and we have ordered it in descending order of confirmed cases. So far our data says that Maharashtra has the highest number of cases, followed by Kerala, Karnataka, Tamil Nadu, Andhra Pradesh and Uttar Pradesh. So these are the top 5 states which have the highest number of confirmed cases. Even if you see, the mortality rate is also high for Maharashtra, and if I scroll down, the mortality rate is also high for Uttarakhand. If you see here, if I scroll further, you have Punjab, the mortality rate is also high. Alright, so this was our first visual that we created in the COVID data analysis project. Now moving ahead, we'll see the top 10 states based on the number of active cases. So we'll start. I'll give a comment, top 10 active cases states. Okay, so we are going to explore another very important pandas function in this, which is known as group by. So I'll first pass in my data frame, which is COVID_df dot followed by the group by function. I'm going to group my data based on state/union territory column. Then I'll say dot max, which is to find the maximum value from the states that have the highest active cases. So I have passed in my active cases column, and we're also going to group it based on the date column. After that, we are going to sort the values. So I'll use my function that is sort_values. I'll say sort by my column that is active cases. Let me bring this to the next line. Underscore cases. I'll give a comma and say ascending equal to false, say dot, and then reset my index. For that I'll use reset_index function. Okay, let's check if everything is fine. I have missed a square bracket here. Let me give another square bracket here. Okay, and all this we are going to store in our variable called top_10_active_cases. Okay, now let me go ahead and run this cell. Okay, there is a syntax error here. Now let's run it. Okay, now I'll create another variable called fig. Here we'll pass in the plt, which is for matplotlib library, and we'll give the figure size using the fig size argument. It's equal to, and within a tuple and passing the size, let's say 16,9. We'll run it. Okay, and let's give a title to our plot. So here we are going to create a bar plot. So using plt.title, we'll pass in the title, let's say top 10 states with most active cases in India. I'll give a comma and pass in the size of my title, let's say 25. Okay, you can see we are slowly being able to create our graph. The most important thing is to pass in the x-axis and the y-axis. I'll say ax, which is for axis. To pass in the axis, I'm going to use the bar plot function that is present inside the Seaborn library. I'll say sns.barplot. I'll say data equal to my variable, which is top underscore 10 underscore states. This is actually active states. Alright, and now I'm going to use the iloc function and take the first 10 states. So I'm using a colon and then giving 10 as my value. ILOC is for index location. I'll give a comma and say my y-axis to be active cases. Give another comma and say my x-axis to be state / union territory. Give another comma. We are going to pass in the line width to 2. I'll say line width equal to 2 and we'll give an edge color. Let's say the edge color is red. Okay, so I have my axis defined now. Let's run it. There's an error here. It says top 10 active states not found. Let's go to the stop and see the exact. Okay, so this is top 10 active cases. Let me change it to cases here. Now run it. Okay, the x-axis also has a mistake. This should be state / union territory. Now let me run it. There you go. We have our plot created, but as you can see here, the labels of the different states and union territories are overlapping. So for that, let me first pass in the x labels. I'll say plt.x label and my x label would be states. Then I'll say plt.y label. My y label will have the total active cases. And finally, I'll write plt.show. Before I run it, let's collate all the lines of code that we have written for our top 10 states for most active cases in India into one cell. So what I'll do is I'll just copy this and we'll keep adding in this cell itself. Okay, I'll go to the top. Next, we'll copy my figure size and we'll paste it here. Next, let's take the title and put it here. Give a space and we are going to copy this cell and I'll paste it here. Alright, now it's time to run it. There you go. You see it here. We have a nice bar plot ready. On the top you can see the title, top 10 states with most active cases, and you see the edges are in red color for all the bars. On the x-axis you have the different state names: Maharashtra, Karnataka, Kerala. You also have Andhra Pradesh, Gujarat, West Bengal and Chhattisgarh. So as you can see, Maharashtra has the highest number of active cases based on our data, followed by Karnataka, Kerala and Tamil Nadu at 2nd, 3rd and 4th place respectively, and in the 9th place we have West Bengal, in the 10th place we have Chhattisgarh. On the y-axis you can see the total active cases, which are in lakhs. Okay, now moving ahead, now we'll see the top 10 states based on the total number of deaths reported. So I'll give a comment: top states with highest deaths. Okay, so I'll first create my variable saying top 10 underscore deaths. This will be very similar to what we did here, just that we need to change a few column names. So instead of active cases we'll be using deaths. Okay, so I'll start with my data frame, that is COVID underscore df, followed by using the group by function, and I want to group my data based on the state slash union territory column. Then I'll choose the max function, and within double square brackets I'll pass in my column names deaths and date. Let's make it consistent. I'll be using single quotes. Okay, I'll say dot, I'm going to sort my result, therefore I'm using the sort underscore values function. I want to sort it by deaths column. I'll give another comma and say ascending equal to false, which means I want to order my result in descending order. Then I'll say dot reset underscore index. Okay, after that I'll give my figure size. I'll say plt dot figure, and within brackets I'll pass in my argument, which is fig size equal to, using a tuple I'll say 18 comma let's say 5. Now let's give a title. For that I'll use the title function which is present in the matplotlib library. I'll say top 10 states with most deaths, and let's give a size to the title 25. Now it's time for us to give the access labels. I'll just scroll down. Okay, so I'll say ax equal to, again this will be a bar plot, so I'm using my cbourne library followed by the bar plot function. My data will be top underscore 10 underscore deaths, which is this variable. I'll give my index location ILOC. I'm going to choose 12 states. The reason being, there are some discrepancies in the data. I'll show you once I plot this result. So in the y-axis we'll have deaths column. In the x-axis we'll take state slash union territory. Okay, I'll give another comma and say line width equal to 2, and we'll give an edge color to our bars like we did here. So I'll say edge color equal to, let's say, black. Okay, now finally we'll give the x label, the y label, So I'll say plt.xlabel. Xlabel would be states. My ylabel will be total death cases. Then I'll write plt.show. Now let's run it. There you go. You can see here we have a nice bar plot. On the top we have the title, top 10 states with most deaths. Now what I specifically wanted you to see was these discrepancies in the data. You can see here Maharashtra is repeated twice. Even in our data that we collected from Kaggle, Karnataka spelling has an error. You can see here we have a few rows of information where Karnataka is spelled as K-A-R-A-N instead of K-A-R-N-A. Alright, so to remove these two results or to ignore these two results, I had given my index location till 12. So we have Maharashtra, Karnataka, Tamil Nadu, Delhi, then Uttar Pradesh, West Bengal, Kerala, Punjab, Andhra Pradesh and Chhattisgarh with the states that have the most number of deaths reported. Okay, now we'll create a line plot to see the growth or the trend of active cases for top 5 states with most number of confirmed cases. So the states are Maharashtra, Karnataka, Kerala, Tamil Nadu and Uttar Pradesh. I can show you. So these are the states with highest number of active cases. Okay, I'll just give a comment saying growth trend. Alright, so for that we'll start with our figure size as plt.figure. I'll use my parameter fig size equal to 12,6. I'll say my axis as SNS dot. This time we are going to create a line plot. My data would be my original data frame, that is COVID_DF, and within square brackets I'll say COVID_DF, and we are going to pass in the state or the union territory column. I'll give a dot and use the isIn function. So the states should include Maharashtra, I'll give a comma. The next state should be Karnataka. Next we have Kerala. Give another comma. My fourth state is Tamil Nadu. Give a comma, and my fifth state would be Uttar Pradesh. Alright, so I'll give a comma here and then say x equal to the date column, y will be active cases column, and I'm going to use another parameter called hue, which is to give different colors to the different states, the 5 states that we are looking for. So hue will be my state/union territory column. Okay, after this I'll say ax dot set title. My title will be top 5 affected states in India. We'll give a size, let's say 16. Alright, okay, this should be size equal to 16, and To make sure everything is fine, let me just move it to the above line. Okay, now we'll run it. Okay, there is some error again. It says invalid syntax. Let's see where we went wrong. Let me bring this to the above line. Okay, this should be COVID_DF. Okay, make sure you keep these small errors in check. Let's try and run it again. Alright, if I scroll down, there you go. Here you can see we have the top 5 affected states in India. You see the different states here and the colors. So this violet or the purple color is for Maharashtra. You can see how the active cases surged around April and May, and then you can see even for Karnataka the active cases surged very rapidly around May and June. Then it has decreased, luckily. Similarly, you can see the plots for even Uttar Pradesh as well as for Tamil Nadu. So all the 5 states, you can see one common trend that after March, so around April, the cases started to emerge very rapidly, and later after July they started dipping. Okay, now we are going to use our second data set, which is related to vaccination. Alright, so first and foremost, let me go ahead and print the data frame for you so that you know the data that we are going to use. So this is the data we are going to use for our next set of analysis. Even this data has a few errors, and you can see there are a lot of missing values. It makes sense because not all the days you would have vaccination for people, and very crucial error that we are going to deal with is this state column. Here you can see in the state column we have India in a few rows, so we are going to ignore these rows. Alright, first let's rename our updated on column to just vaccine date. So you can use the rename function present in the pandas library to do it. So I'll say vaccine_df dot rename. I'll say columns equal to, within curly braces I'll write updated on, which is my original column name, give a colon. I want to change this to vaccine_date. I'll give a comma and say in place equal to true. So it will change my column name from updated on to vaccine_date in the original data frame. Let's run it. Now let me go ahead and print the first 10 rows in the dataset. You can see here we have successfully changed the column name to vaccine_date. The rest of the columns remain the same. Alright, now you can check the total number of columns, rows, the data types, and the memory usage using the info function. Here you can see it. We have total 24 columns, 7,845 entries, and these are the columns that are present. And if I scroll further, you see here says the memory usage, and here on the right you can see the data type. Cool. Now as you saw, the data has a lot of missing values. Let's find the sum of all the missing values for each column. So I'll say vaccine underscore df dot is null, and then I'm going to use the sum function over it. If I run it, there you go. So almost all the columns have missing values, but columns such as male individuals vaccinated, female individuals vaccinated, even for columns like the age groups, there are a lot of missing values. Now in the next step, we are going to drop a few missing value columns. So I'll say a new variable called vaccination. I'll give the data frame name vaccine underscore df and use the drop function. And inside the drop function, we are going to write columns equal to, I'll pass in the column names that I want to drop. I'll say doses administered. So this is the column that I want to delete, Sputnik V doses administered. I'll give a comma. The second column is AEFI. The next column is 18 to 44 years. Within bracket, it has doses administered. Give a comma. I'll say 45 to 60 years, doses administered. Give another comma. The final column that we are going to drop is 60 plus, which is this one, 60 plus years. Doses administered. Okay. So these are the columns that we want to drop. And finally, I'll give my parameter access equal to 1. Okay, let me just recheck these column names. First one is Sputnik V doses administered, then we have AEFI followed by 18 to 44 years doses administered, then we have 45 to 60 years doses administered. Finally we have 60 plus years. I have added a S here which was missing, and there should be a space as well because there's a space here in the column. Now let's run it. Alright, so we have successfully dropped the columns that we wanted to drop. Now I'll say vaccination.head. You can see here we have dropped those columns and we are left with these columns now. Okay, now we are going to create a plot, that is a pie plot, to see the vaccination for male and female individuals. So I'll give a comment as male versus female vaccination. To create this pie plot, I'm going to use the Plotly library that we had imported, which is this one, Plotly. Okay, so first of all we need to filter out the male individuals from our data frame. I'll say male equal to vaccination male. I'll passing in the column individuals vaccinated. We need to recheck the variable name whether it is correct or not. You see here male individuals vaccinated. Then I'll say dot sum. Similarly, we'll filter out the female individuals I'll say female equal to vaccination, which is my new data frame. Within square brackets, I'll pass in the column name female individual, vaccinated, I'll say dot sum. Okay, these should be individuals as per the column name present in the data frame. Cool. Now I'm going to say px dot py function, which is present in the plotly library. I'm going to give the names of the pies. So first one is male and the second one is female. Give a comma and say values equal to male comma female. Then I'll give a comma and pass in my title, which is male and female vaccination. Okay, this should be names. Alright, now let's go ahead and run this cell. So it'll take some time to create the pie chart. Here we go. See, here I have my title, male and female vaccination. So these are the two pies or the areas. You have the label female and the value. Here you have the label male and the value. So from our data you can see 53% male individuals have been vaccinated compared to 47% for females. Okay, now we are going to drop all those rows where our state was mentioned as India in the original dataset. I had shown this to you in the beginning, so we are going to remove rows where state is India. Okay, so to do that I'll say vaccine. I'm creating another variable called vaccine and we'll use our original data frame that we had imported, which is vaccine underscore df. I'll say vaccine underscore df dot state not equal to India. Now let's print vaccine. Okay, you can see here we have our data frame printed, and from this data frame we are taking only those values or the rows where state is not equal to India. Cool. Now what we are going to do is we'll rename the last column, which is total individuals vaccinated, to just total. So I'll say vaccine dot rename. We'll use the parameter columns equal to, within curly braces I'll say total individuals vaccinated, give a colon, and we'll change this to just total, give a comma and say in place equal to true. And finally I'll print my head of the new data frame. This should be columns equal to. Okay, now you can see here if I scroll to the right and if I check, we have successfully renamed our column. Alright, now moving on to the last two visualizations that we'll see in this first project using Python, that is to find the states with most number of vaccinated individuals and the state with the least number of vaccinated individuals. Okay, just give a comment, most vaccinated state. Okay, for this I'll first create a variable called vax_VAC, which is for maximum vaccination. I'm going to use my data frame vaccine followed by the group by function. I want to group it by state column, and we'll find the total sum of vaccinated individuals for each state. I'll convert this to frame. There should be a dot, 2_frame, and I'll pass in my column name, which is total. After that, I'll say max_VAC equal to max_VAC dot sort underscore values. I'm going to sort it by my total column and say ascending equal to false, which means I want to sort it in descending order so that we have the states with the highest number of individuals vaccinated. I want the top 5 states. Now let's go ahead and print it. So this will create a nice table for us. There you go. Here you can see we have Maharashtra, Uttar Pradesh, Rajasthan, Gujarat and West Bengal as the top 5 states with most number of vaccinated individuals. Now we are going to use this table and convert it into a chart. Now I had already written my code for the bar plot. I'm just going to paste it. So here I have defined my figure size as 10,5. Then I'm giving a title as top 5 vaccinated states in India and the size is 20. After that I've created a variable called x, which is going to store my bar plot. This bar plot we have created using the Seaborn library, and you see here I have my y-axis defined, then I have the line width and the edge color as well. I have given my x label as states, y label as vaccination, and I'm finally going to display my plot. So let's go ahead and run it. Okay, you can see it here. We have converted this table into a bar plot now. So first we have Maharashtra with the highest number of vaccination. Then we have Uttar Pradesh, Rajasthan, Gujarat and West Bengal. Now I want the viewers watching this video to find the states with least number of vaccinated individuals and convert that table into a bar plot that will show the bottom 5 vaccinated states in India, which means the states which have least number of individuals vaccinated. So please go ahead and put your codes in the comment section of the video. It will be very similar to these two cells, just that now we want to know the least 5 vaccinated states in India. So please put the code snippets in the comment section of this video. We'll be more than happy to know from you. In case you are not able to do it, we'll definitely give the answers in the comments itself. Alright, so this brings us to the end of the first project on COVID data analysis using Python. So in this project we used 2 datasets. One was on the COVID-19 India dataset for different states and union territories, and the second dataset that we used was for analyzing the status of vaccination in the different states in India. Now we'll move on to our second project. Okay, so before moving on to our Tableau project, let's see the final quiz. Which of the following is not a common coronavirus symptom? So this question is to make you aware of the correct COVID symptoms. Here are the options. Is it A, fever, B, vision loss, C, loss of taste and smell, or is it D, cough? Please put your answers in the comment section of the video and let us know what you think. Now we'll move on to our second COVID data analysis project. For this project, we'll be using the Tableau software and a global coronavirus dataset. First, we'll look at the dataset and the fields we have. Okay, so I am in my dataset folder. We have already seen the first two datasets in our Python project. This time we are going to use the global COVID data. Let me open it. Alright, so here you can see we have the different country names. There are 192 countries in our dataset. Let me go to the top. So we have country or region. We also have the code for each of the countries. Then we have a column called last updated. So here you can see our data is still 12th of March 2021, and there are two columns which don't have any information, that is people hospitalized and people tested. Then we have a column called active cases. Then we have a column for confirmed cases in the different countries. We have the number of deaths, and then we have the incident rate, the latitude and the longitude for the countries. Then we have the mortality rate. This is in fractions. Then we have the number of recovered cases, and finally we have a column called UID. So we'll be mostly using the country column, active, confirmed, deaths, and the recovered cases column. And we'll be using the Tableau software to create interesting visualizations, and we'll convert those visuals and put it in the form of a dashboard towards the end of the project. Okay, so let me close this file, or let it be open. I'll search for Tableau public. You can see here I have Tableau public installed. You can use the desktop version of Tableau or the public version of Tableau. So for this project we are going to use the Tableau public edition. So here you can see I have created a few visuals already. If you want, you can clear them out. Okay. Now the first thing we need to do is to connect our CSV dataset to Tableau. For that, under connect we have to a file. I'm going to use text file, and under Chrome downloads I'll search for my folder COVID-India, and here I have my global COVID data file. Let me open it. This will take some time to load. There you can see. So on the Tableau you can see the view here. It shows the country or the region. You have the last update. You have columns like active, confirmed, deaths, mortality rate, and recovered. And here you can see the symbols for the different columns. So this is a globe, which means this field is a region or a geographic field. ABC means it's a text field. Then we have the calendar, which is for a date field. ABC are text field, and this hash represents numeric fields. Alright, so now that we have loaded our data, let me just click on sheet 1. So this is the canvas where we are going to create our different reports. Alright, so on the left you can see there are two panes, the data pane and the analytics pane. In the data pane you can see the name of the dataset, global COVID data, and here you can see the different columns that we have in the dataset. So on the top, the ones marked in blue are called as dimensions, and at the bottom whatever you see are marked in green and are called as measures. So dimensions are always represented with blue icons and measures are in green icons. So Tableau has automatically detected the different data types for each of the columns. Alright, so first of all we are going to create a simple table to see the total number of confirmed cases for each of the countries. So for that, I'm going to drag my country or the region column onto rows. Here you have rows. I'll just drag it and drop it here. There you go. It has populated all my country names starting from Afghanistan till Zimbabwe. So it has ordered in ascending order of alphabets. Now to see the total confirmed cases for each country, I'm going to drag my confirmed column onto text. So here under marks card you have the text option. I'll just drag it and drop it here. There you go. So Tableau how easily has shown me a table where you can see the different country names, and on the right you have the total number of cases that have emerged from these countries. Now this is not the most recent data. As I told you, this data was till March 2021. Cool. Now you can go ahead and sort the table based on the total confirmed cases. Here on the top you can see here there are two options to sort in ascending order or in descending order. Let's first sort in ascending order by sum of confirmed cases within country and region. There you go. So here you can see these are the countries which have very few cases, and if I scroll down you have France, UK, Russia, Brazil, India and US with the highest number of COVID-19 cases. If you want, you can also sort it in descending order so that the countries with the highest number of confirmed cases appear at the top. You can see it here, and these are the countries that have very few COVID cases. Now you can convert this simple table into different charts and graphs. To do that, here on the right top corner you have an option called show me. Now I can just click on this horizontal bar graph, so that will automatically convert my table into a bar graph. Again, you can go ahead and sort the data. There you go. So here you have US, India, Brazil, Russia, UK, France, Spain and Italy. This is a horizontal bar graph sorted in descending order of confirmed cases. Now suppose you want to display only the top few countries with the highest number of confirmed cases. For that you can select these bars. So I'll select till, let's say, Germany, or let's say till Argentina. Okay, and I'll click on keep only. You can see it here, it says 12 items selected, that is the sum of confirmed cases. I'll just click on keep only. There you go. So this horizontal bar graph has information only for these few countries that have the highest number of confirmed cases. Now you can go ahead and play with the color formatting. So here under colors, let me choose a green color. Okay. Now you can mark here, since we selected only the top 12 countries with the highest number of confirmed cases. So what we did was we just filtered it to the top 12 countries. So Tableau has automatically added country region in the filters card. Now if you want, you can go ahead and edit this filter as well. Suppose you want to remove Argentina, you can just uncheck this, click on apply and OK. You see here Argentina has been removed. I click on undo, so Control Z to get it back. Cool. Now you can convert this horizontal bar plot into a vertical bar plot. Let me show you how to do it. I'll just remove these fields from my chart. Now what I'm going to do is I'll drag country or region onto columns, and I'll have a confirmed column under rows. There you go. Here you can see we have a vertical bar plot now, and again you can use the axis now to sort your data. This is in descending order. Similarly, you can sort it in ascending order. Here you have the option to sort your data. Okay. and below you can see the different country names. Alright, now you can go ahead and give a name to this sheet. Let's say top 10 confirmed countries. Just apply and click on OK. You have the title to this plot. Similarly, you can change it here as well. Top 10 confirmed countries. Okay. Now let's move on to our second visualization, where we will create a global map. So this global map will show the different countries present in the map and the cases that they have. So to create the map, first I'll drag my longitude generated field onto columns, and then I'll drag latitude onto rows. You see here we have the map ready, and now I'll drag country region onto detail. So this will give you the different country names. You can see here we have Canada, the United States, Mexico, here you have India, Sri Lanka, there's Australia, this is Brazil, and similarly we have Spain, France, Belgium, there's Italy here, we have also Greece. Similarly we have the African countries like Central African Republic, there's Congo, Angola, and on the top you have Russia, and this is Iceland, so on and so forth. Now I'm going to drag the active cases column onto detail again. Now if I hover the cursor, you can see the active numbers for Brazil, you can see for India, you have countries like China, then here you have Thailand, Algeria. Now I'm going to drag the confirmed cases column onto label, so that you have the labels here. You can see here the confirmed labels. Cool. Now if you only want to focus on a few countries present in a particular region, you can highlight that region. For example, suppose for Europe you want to focus on this region. If you select it, it will highlight only those countries, and if you hover your mouse over these points, it will show you the active cases and the total number of confirmed cases. Alright, now if you want, you can go ahead and change the color of the circles. Let's say I'll keep it as red. Okay, so this is how you can create a map to represent the different active and confirmed cases. I'll rename the title to global cases. I'll just click on apply and OK. Similarly, I'll change the sheet name as well to global cases. Okay, now from this map you can see the countries such as USA, Brazil, you have Russia and India with the highest number of COVID-19 cases. Even in countries such as Spain, the numbers are really high, and a lot of the African countries were also impacted. And these small countries like Solomon Islands, you have Fiji Islands with few number of cases, even for New Zealand as well. Alright, now moving to our next visual. Now we are going to see the top 10 countries where highest deaths have been reported so far due to the pandemic. For this we will create a tree map now. So first of all, I'll choose my country column and put it under columns, and then I'll select the deaths column and put it under rows. I have the bar plot ready. Next I'll go to show me, and here I have the option to select a tree map. You see here, for a tree map you need one or more dimensions and one or two measures. So I'll just click on this tree map. Okay, here you can see I have my tree map ready. So Tableau has automatically adjusted my fields. So it has removed my fields from rows and columns and put it under size, color and label. Next, I will drag my country column and put it under filters. And from here, I'm going to choose top. I'll filter by field. I'm going to select the top 10 countries based on the total number of deaths. Just click on apply and click on OK. So these are the countries: US, Brazil, Mexico, India, United Kingdom, Italy, Russia, Spain, France, Germany, which have the highest number of deaths reported. Now you can also give the label. I'll put the deaths column under label so that you have the labels here. Alright, so this was a tree map that we created to show the top 10 countries with the highest number of deaths. I'll just change the title, top 10 deaths cases. Now you can also edit the title in terms of the font, color and everything. I'll keep it Tableau bold and I'll choose this as 14. Click on apply and OK. There you go. Similarly, let's rename the sheet to death cases. Cool. Now moving to the next visualization, where we'll see about the recoveries. So before we move on to create a visualization for the top 10, or let's say the bottom 10 countries in terms of recoveries, let me show you how to change the color of this tree map. So here by default Tableau select the automatic palette. If you want, you can change it to different palettes. Let's say I'll go with gold, purple, diverging. Click on apply and I'll click on OK. If this is not looking that great, you can select another one. Let's say red, green, white, diverging. Cool. Now let's go to our fourth visualization, which is about top 10 recoveries. I'll click on apply and OK. First, I'll drag my country or the region column under columns, and then I'll take the recovered column under rows. This time, instead of sum, we are going to choose average. Okay. And here I'll select my packed bubble chart. After that, I am going to drag my country or region onto colors, and then I'll also put country under filters. So I'll go to the top menu and I'll filter it by field. I want to show the top 10 countries based on the average number of recoveries. So click on apply and OK. You can see here these are the countries that have the highest number of average recoveries. You have India, Brazil, Turkey, Italy, Argentina, Germany, Colombia, Russia, Poland and Mexico. I'll just rename this sheet to recovery cases. Cool. Now let's move on to our next visual. Okay, so here we are going to create a scatter plot to analyze the total confirmed cases versus the total number of deaths. So whenever you have two numeric fields, it is better to create a scatter plot to visualize the cases. So for that, I am going to drag my confirmed cases to columns, and then I'll drag my deaths column onto rows. Okay. So by default, the shape is a circle, and to see all the countries, I'm going to drag country under color. I'll say add all members. There you go. Here you can see the legend for the different countries, and the top you have US with the highest number of confirmed cases and the highest number of deaths as per our data set. Then you also have Brazil here, which has the second highest number of deaths. Then you have Mexico followed by India. So this data is not a very recent data. This data was last updated on March. Now from this we are going to filter out the top 10 countries with the highest number of confirmed cases and the deaths. So for that I'll drag my country column onto filters, and I'll go to top, I'll filter by field, I'll say top 10, and I'll click on apply and OK. So here you can see we have Siberia, Sweden, Belgium, Netherlands, Spain, Italy, France, Russia, UK, and you have Brazil. So these are the countries which have the highest number of active cases. So instead of active, let's select deaths, click on apply and OK. Okay, now if you see we have US here, Brazil, India, then Mexico, UK, Russia, France, Italy, Germany and Spain, which have the highest number of deaths reported so far. Now if you want, you can change the size of the circles based on the highest number of active cases. So I can just drag my active column under size. So you can see here Spain, France, UK have the highest number of active cases. Now let's say instead of active, I'll just have my confirmed cases under size. Okay, and then you can also change the shape from circle to any other shape, let's say square or this asterisk. Okay, let's go with the triangle. Cool. I'll rename this sheet to confirmed versus deaths. Click on apply and OK. I'll rename this to confirmed versus deaths. Alright. Now moving on to our next visualization, where we will see the mortality for each of the countries and figure out which countries have the highest mortality rate. Okay. So first I'll drag mortality rate onto column, and then I'll have my country column under rows. So there you go. Now let me go ahead and sort it in descending order. So you can see here you have Yemen, there is Mexico, Syria, Sudan, Egypt, Ecuador, China and other countries which have the highest mortality rate. And you can also select the country region under colors. Let's go ahead and edit the color. Instead of automatic, let's select summer, or you can go for some other palette. Let's say Tableau Classic Medium. I'll assign this palette. Yes, I'll apply and OK. Alright. Finally, we'll move ahead to our last visualization, where we'll create a dual axis chart. So the dual axis chart in Tableau will have one column and two different visualizations on the rows. So here you have one column, and on the right also you'll have one column with their own axis values. So this dual axis chart will be for recovered cases and the death cases. Let me show you how to do it. So I'll drag my country field onto columns, and then I'll choose recovered column onto rows. So here I have got my line chart, and the second column I'm going to choose is the deaths column. I'll hold my cursor and I'll place it when I get this green color rectangle. I'll place it here. There you go. So now we have created two measure names, deaths and recovered, and here you have the access values. You can synchronize the access values if you want. The recovered cases are in millions and the deaths are in thousands. Now let's go ahead and change the recovered line to bars, and we're going to short it. Okay, now let's change the color. We'll select, let's say, blue. I'll assign the palette, click on apply and OK. And if you want, you can also change the color for deaths from blue to, let's say, winter. I'll assign the palette, click on apply and OK. You can have whichever color you want, and to make the axis same, you can just right click on this axis and click on synchronize axis. So here you can see the values. Let's keep it in thousands only. Cool. I'll rename this sheet to dual axis. Okay. Now before we move ahead and create our final dashboard, I want to show you one more feature in Tableau, that is to format the labels. So you can see here, instead of writing 5,30,821, we can change this in terms of millions or thousands and write it as, let's say, 530k. To do that, what I'll do is I'll go to format, and here we have the option to select font, and in font I'll go to fields and click on sum of deaths, and here in this pane I'll choose number custom. Decimal places will be 0, and display units I'll select thousands. You can see here the values have been changed to 531k, 193k, 158k, so on and so forth. Cool. Now let's go ahead and create our final dashboard. Here is the option to create a new dashboard. So I'll just click on new dashboard, and we are going to increase the size here so that it fits our view. So we have selected the default view, and the size I'm going to choose here is automatic. So now we can drop our sheets one by one. First, let's drag the global cases sheet here. Okay, you can see we have our map. Now I'm going to choose the top 10 confirmed cases. Alright, and after that we'll choose the death cases sheet. So Tableau will prompt you to place the sheet at the right location. Okay, and now I'll choose my fifth visual, which is confirmed versus deaths, and if you want you can choose any one of these. Let's say I'll take the dual axis chart. Now you can just minimize the sheets and adjust the sizes to make it look better. Okay, so you can see here we have our dashboard ready. Now you can still go ahead and customize the dashboards in terms of adding different filters to it. We are not going to show that. Now you are getting some messages here, 2 unknown, 4 nulls. You can remove them as well. And here on the top you have the option to click on the presentation mode. There you go. So this is our final dashboard that we have created. Alright, so this brings us to the end of the second coronavirus data analysis project using Tableau. Now you can just click on escape to go back. Alright, now you can save this and this will be published in the Tableau public platform under your profile. So that brings us to the end of this video tutorial on COVID data analysis project using Python and Tableau. Welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC, so they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly, there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as NumPy, Pandas, Matplotlib and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first dataset. You can see on the top athlete_events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge dataset that we are going to use. The other dataset we are going to use in this demo is called NOC_regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. We have the region names, so AFG is for Afghanistan, you have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright, let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete_events.csv contains nearly 2,71,116 rows of information, and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. Alright. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two datasets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I've opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use NumPy, Pandas, Matplotlib, and Seaborn. Let me hit Shift Enter to import all the libraries. Alright. Now the next thing is to load the datasets using Pandas read_CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read_CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another /, and after that I'll give the file name, that is athlete_events.csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set, I'll create another variable called regions. So it will have my data frame. I'll use the same function pd.read_csv. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc_regions.csv. You can verify here. The first one is athlete_events, the second one is noc_regions. Okay, I'll close the quotation and we'll run it again. Okay, there seems to be some error. I think this is the regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes.head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions.head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second dataset. You have NOC, region and some notes. Alright. Now the next step is to combine both the datasets. So we'll join the data frames using the pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes_df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the datasets is actually NOC. So I'm going to use the NOC column as my common column to merge both the datasets. Now let's go ahead and print the merged data frame. I'll say athletes_df.head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added 2 more columns that were present in the second dataset, which was regions. So we have regions and notes added to my first dataset, that is athletes_events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last 2 columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt. I'll select athletes_df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows. So 2,71,116 rows, and earlier we had 15 columns in the first dataset, and now that we have added 2 more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes underscore df dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region. I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually. My second column, that is notes, I want to change the first letter to uppercase, so I'll say capital N. The rest all remains same. I'll give a comma here and say in place equal to true. So it will change the column names and will reflect in this athletes underscore df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last two columns, region and notes. Alright. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values, and memory usage. So for that you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. Alright. Next, the describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile, and the 75th percentile value of the columns ID, age, height, weight, and year. Alright. Now one thing to notice here is, if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright. Now moving ahead. Now let's check if there are any null values present in the columns of the dataset. So first I am going to create a variable called nan values, give equal to, I'll say athletes underscore df, and the function to check is, I'll say is na. I'll create another variable called nan underscore columns, and here I'll use the any function. I'll say nan underscore this variable, which is underscore values dot, I'll say any, and I'll print my nan columns variable. So this will display the result in terms of Boolean values. So if there are any null or nan or missing values in any of the columns, it will say true, otherwise it will say false. Let's display the result. There you go. So if you mark here clearly, So there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any NaN or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. Let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, we'll use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year and everything. Alright, similarly you can also check for Japan. Let me just copy the above code, I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright, now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that I'll create a variable called top underscore 10 underscore countries. I'll say equal to, I'll use my data frame, that is athletes underscore df, I'll say dot team, then I'll use the function value underscore counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top underscore 10 underscore countries. Alright, let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short underscore values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896. You have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot the top 10 countries who have participated in Olympics. So here I'm using the figure function to give the figure size. So these are the dimensions 12,6. Now I'll tell you what this PLT_X means. Just wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the X and the Y axis. So my X axis has top. I should make this top 10 countries because above we used top underscore 10 underscore countries. Similarly for Y axis, I'll make it top underscore 10 underscore countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this, we are going to create a histogram. I'll be using the matplotlib library specifically for this visualization. So I'll say plt.figure. We'll give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the X labels. I'll say plt dot X label. This will have age. Then we'll say plt dot Y label, and this will have the label as number of participants. Next, I'm going to use the hist function. So I'll say plt.hist, and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function. So np is for numpy, and inside this I'll say 10, 80, 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge color, this is the parameter or the argument name, and the color I want is white. Let's give a semicolon here, and this should be edge color. There's a spelling mistake here. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the Summer and Winter Olympic Games. Let's look at the different sporting events that are part of the Summer and Winter Olympic Games. Just to give you a heads up, the Winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter_sports, so I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the Winter Olympics. Now similarly, let's see for Summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer_sports, athletes_df remains the same. Here season we'll change it to summer. .sport.unique remains the same, and here I'll say summer_sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the Summer Olympics compared to Winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender_counts, which is my variable name. I'll use my data frame, that is athletes_df dot my variable name, that is sex, dot value_counts, and then we are going to print gender_counts. Let's run this. There you go. So since the inception of Olympics, we have more number of male participants than female participants. Now here in this current cell you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender_counts.index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. Now we can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we are going to find the total number of medals that the athletes have won. So I'll use my data frame athletes_df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female_participants. I'll say equal to, and then use my data frame name, that is athletes_df. Using square brackets, I'll say athletes_df dot, the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column. So here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function. Say group by, which is part of the pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index is a function, and finally we are going to print female underscore participants and let's say the head. Alright, so what we are trying to do is I'm trying to filter my data only for the female athletes for Summer Olympics, and here I am printing the participation based on each year, so I'm finding out the count. So here we need to add one more square bracket. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here. For the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics, we had 5,815 Olympics. Similarly for the 2016 Rio Olympics, we had more participation than the London Olympics. So 6,223 women athletes had participated. Alright. Now here, this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid. Then my figure size I have given as 20,10. My count plot will have the x-axis as year. The data is Women Olympics, and palette I'm using as spectral, and then I've given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot, which says Women Participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend, which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis. Now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next, I'm going to say gold medals dot head. Let's run it. There you go. So here we have the top 5 rows of the athletes who have won a gold medal. You can see all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have set gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event. This is going to be my variable name, equal to, I'll use the same variable name, gold medals. I'll going to choose my sport column and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called Rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it, and if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years, and since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright, now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals, then we have Russia, Germany, UK, Italy and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6. So it will give me the top 6 countries. Alright. Now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets, I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team. Then I'll say team underscore names dot value underscore counts dot head, and will display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20 and Japan 17. Alright. Now using the above result, we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it, and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values. So we are not going to consider those null values here. We are only going to consider for the athletes who have won a medal. So for that, I'll create a variable called not underscore null underscore medals equal to, I'll say athletes underscore df, then I'll give my, let's make it df I'll give my condition. Let me just copy this. I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis. I'll say athletes underscore df. This time we'll consider the weight column. Again, I'll use the function as not null, and I'll close the parenthesis. Okay, I had missed one s here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure. I'll give my figure size equal to, I'll say 12,10. I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma. In my y-axis I'll have weight, comma. My data should be not underscore null underscore medals. So this is what we created here, not underscore null underscore medals, comma. I'll use hue equal to my sex column. Cool. Finally, I'll say plt dot, I'll give a title to my plot saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Alright. So that brings us to the end of this video tutorial on Olympics dataset analysis. Indian Premier League, that is IPL, is one of the most popular and exciting events in world cricket. IPL 2022 will begin on 26th of March, so it's the best time for us and our viewers to learn about how to perform exploratory data analysis using the recently held IPL auction dataset. So in this video, all the results and insights that you will see are totally based on the data we have collected from Kaggle. We will leave a link to the dataset in the description of the video. You can go ahead and download it. For this demo, we'll be using Python and Jupyter Notebook to answer specific questions. So let's get started. We'll move over to our Jupyter Notebook. Okay, so I'm on my Jupyter Notebook and this is the file that we are going to use. So here you can see I have some of the cells already filled in. So this will save us some time and we can explore this data set in depth. So this is the file that I'll be using, or the IPython notebook. Cool. So first, let's go ahead and import all the crucial libraries that will be needed for our analysis. So here you can see I am importing the pandas library, the numpy library. These are for data manipulation and numerical computation. Then we have seaborn and matplotlib for data visualization. Then I have imported this warnings module so that we do not get any warnings while running the code. Cool. So let me just hit Shift Enter to run the first cell. So here we will import all the libraries. Okay, it's done. Now the next step is I'm going to create a data frame in the name of IPL, and here I'm importing the dataset using the read_csv function, which is part of the pandas library. So PD here has been imported as pandas. I'm giving the dataset location followed by the name of the dataset. So here the name is IPL_2022_dataset.csv is the extension of the file. So let me go ahead and run this as well. Alright, so now we have successfully imported or loaded our dataset. Now the next step, let's go ahead and explore our dataset. So I'll use the head function for this, IPL.head. Okay, so here you can see the different columns. We have an unnamed column which is actually unnecessary for our analysis, so we'll see how to drop this column. Apart from that, we have the name of the players, the base price at which the player was sold, or whether the player was a draft pick. So here Rashid Khan from Afghanistan, Hardik Pandya, then we have Subman Gill. These are all draft pick, and then we have the price at which the players were listed in the IPL auction. Then we have the type of player, whether the player is a bowler, an all-rounder, a batsman, or a wicket-keeper. Then we have the cost in rupees. This is in crores. So basically this column tells us the price at which the player was sold in the auction. Then we have the price or the cost in dollars. After that we have 2021 squad. Basically this means in last year's IPL, where was the player? So here you can see Rashid Khan was playing for SRH, the Sunrisers Hyderabad, in 2021. But this year in 2022, he'll be playing for Gujarat Titans. Similarly, Hardik Pandya was playing for Mumbai Indians for past few seasons, including 2021. But this season is going to play for Gujarat Titans. So on and so forth. Now, let's see the total number of players that are present in the dataset and the total columns that are there. For this, I'm going to use the shape attribute. So I'll write IPL.shape. You can see here there are total 633 players that were part of the auction, and this includes the players who were draft pick also. And there are total 8 columns in my data frame IPL. Next, let's use the info function to check the columns, the data types, and the total non-null objects. So I'll say IPL.info, which is a function, so I have to use brackets. There you go. So here you can see it says total 633 entries from 0 to 632. Data columns, we have total 8 columns, and then these are the different column names, and here you can see the total non-null objects present in the column, and here you can see the data types, and at the bottom you can see the memory usage as well. Cool. Now the dot columns attribute will return the name of the columns in the dataset. So if I say IPL.columns and run it, it will give me all the different column names that are present in the data frame. Now, as I said, the first column, which is unnamed :0, is actually unnecessary. So we are going to drop it. For that, we are going to use the dot drop function, and then I have passed in my column name followed by the axis, on which axis is it there, and then I say in place equal to true, which means it will replace and permanently remove the unnamed column from the data frame. So let's run it, And now we'll again check the head of the data frame. You can see before we had the unnamed column, which was the first column in the data frame, and now we have successfully removed it, so player becomes the first column in the data frame. Alright, now moving ahead, let's see the total number of null values that are present in each column of the dataset. So I'll say IPL dot, I'm going to use the isNull function followed by the sum function. If I run this, you can see here the player column doesn't have any null values. Similarly, base price and type column also don't have any null values, but you can see cost in rupees and cost in dollars have nearly 396 missing or null values. The reason being those players were not picked in the IPL auction and hence there was no price associated. And then you can see there were a few players who were not part of the IPL squad in 2021, so those are being reflected as null as well. Now we'll check the rows that have cost in dollar as null or NaN. So here I have used IPL, and after that I'm passing in the column name, which is cost in dollars, and then I've used the isNull function. If I run this, you can notice the cost in dollars column, all these values are NaN or null, and even the same rows have NaN for cost in rupees as well. Cool. Now the next task is to fill these null values or NaN values with zeros. So for that I'm going to use the fill NA function, and here I have passed in 0. So all the null values in the dataset will be replaced with 0 for cost in rupees column and cost in dollars column. Let me just run it. Alright. Okay. Now we will see the players who were unsold in the 2021 auction, which means we will check the rows that have null values for the 2021 squad column. So what I'll do is I'll say IPL, within square brackets I'll say IPL, and then I'll pass in my column name, which is 2021 squad, and then after this I'll say dot isNull. So this cell will give us the unsold players in the 2021 auction. If I run this, you see here you mark the 2021 squad column, all these players were unsold or did not participate, so hence it has NaN values. Alright. Now what we are going to do is we will replace all the null values that are present in the 2021 squad column with not participated. Like how we did in the previous example, we replaced all the null values with 0. Here we'll replace with a text value called not participated. So I'll say IPL, I'll pass in my column name, which is 2021 squad, equal to, I'll say IPL 2021 squad dot fill NA, which is the function, and here I'll pass in a text or a string saying not participated. Alright, let's run it. Before that, let me just scroll it down. Now I'll run it. Cool. Now that we have treated the null value successfully, let's verify it again. So I'll just say IPL dot is null, and then I'm going to use the sum function. If I run this, okay, this is also a function. Cool. Now if you see, we have successfully removed all the null values and replaced with either zeros or not participated, and hence now you can see none of the columns in the IPL data frame have null value, so it shows 0. Great. Now moving ahead, Now we are going to add another column called status, which will hold two values, sold and unsold. But before that, we are going to slice our data frame. So here I am looking for all the rows where cost in rupees is greater than 0, and those should be unique, and I'm storing the value in a variable called teams. So here you can see we have the different teams where the cost in rupees is greater than 0. Now I'm going to create another column called status. So I have written IPL within square brackets. I'm passing in the column name, which is status, and that will be equal to the team replaced by sold value. Let me just run it and show you the result. There you go. So here you can see we have added a new column called status, and it has values sold and unsold. If I just say IPL, at the bottom you can see the unsold values as well. Cool. Now in the next cell, we are going to check for duplicated players. So there are duplicate rows in the data frame, but here the names of the players are same, but in reality the players are different. So it is quite understood that different players can have the same name. So to get those names, I am using the duplicated function, and I'll say keep equal to false, which means I don't want to keep those players. Now let's run it. There you go. So here you can see Lalit Yadav, we have two entries. So Lalit Yadav here is an all-rounder whose base price was 20 lakh for 2022 IPL, and last year he was playing for the Delhi Capitals, and this year also he is sold to Delhi Capitals. Next we have Lalit Yadav, who happens to be a bowler. So this is again different Lalit Yadav. So last year he was unsold, and even this year he remains unsold. Similarly, we have Amit Mishra, who earlier used to play with the Delhi Capitals, but this time he remains unsold, so on and so forth. So you can see two entries for Subham Singh as well and Shivam Mishra. Alright. Now let's answer a very basic question. We're going to find out how many players have participated in the 2022 IPL auction. For that, we have already seen the total number of rows that were present, but again I'm going to use the shape function, and within square brackets I'm going to say 0, which means it will give me the total number of rows, and you can see 633 players were part of the auction. This is as per our data that we have collected from Kaggle. Up next, we are going to find how many types of players have participated. So I'm going to say types equal to, say, IPL. I'll use the column name, which is type, and I'm going to find the count of each type of players that are present in the data frame. I'm going to use the values underscore counts function, and then I'll say types dot reset underscore index. If I run it, okay, there is an error here. Let me debug the error. Okay, so this should be value underscore counts, and the variable name is types and not type. So let's run it. You can see here we have the different types of players. So all-rounders, there are total 242 all-rounders who are part of the auction. Then we have 215 bowlers, 112 batsmen and 64 wicket keepers. Now using the above table that we just created, I'm going to plot my first pie chart. So for that I'm going to use the matplotlib pie function. So plt.pie, I'm using types.values since I want only the values from this table, and then I'm saying labels equal to types dot index. I've used a label distance of 1.2 to maintain some space, and then this is my format in which I want to print or show or display the percentage of distribution. I am going to use shadow, so it says shadow equal to true, which is another parameter or an argument, and then I'm going to start my angle at 60 degrees, and here I have used a title called roll of players participated that will have a font size of 15, and finally I'm saying plt.plot. So let me just run it. There you go. So here we have a nice pie chart or a pie plot. So you can see the different pies here. We have all-rounder, wicketkeeper, batter and bowler. So majorly there are all-rounders in the auction, followed by bowlers. Then we have 17.69% batters and 10.11% wicketkeepers, which is the lowest. Cool. Now we are going to create another bar plot or a bar graph that will tell us how many players were sold and unsold. So for this I'm going to use a count plot. So we'll create two bars, one for sold and the other one for unsold, and each of the bars will have different colors. One will have orange, the other one will have pink, and I'm using labels. So to label the x-axis and y-axis, I have sold or unsold. Y label will have number of players. The title of my bar graph would be sold versus unsold. I've given a font size of 15 and I'm saying plt.plot. Now the function that you see here at the bottom will display the data labels for each of the bars. Let me just run it and show you the result. There you go. So I have used a figure size of 10,5. Alright, now you can see we have a really good bar plot which says there were total 237 players sold and 396 players were unsold as per the data we have. Cool. Now you can also print the total sold and unsold values. Let me show you how to do it. I'll say IPL dot, we can use the group by function, and I want to group it by status column, and the value that I want to measure is the players count. So I'll say players, rather player, and then I'm going to use the count function. If I run this, you can see here I've successfully grouped the unsold and sold players. The values are matching with the bar plot that we just created. So sold were 237 players and unsold are 396. Cool. Now we are going to see the total number of players bought by each team. Again, this is going to be a count plot, so basically a bar plot. So here the condition I'm passing is in the teams column the value shouldn't be unsold. So players bought means the value should be sold. So here I'm using this condition, and the rest of the things remains the same. One improvement I have done here is I'm using x-text rotation equal to 70 degrees. This basically means the x labels would be tilted by 70 degrees. Now let's see the bar plot. There you go. So here you can see I have the title players bought by each team. On the y-axis we have the number of players, and on the x-axis you can see the values have been tilted by 70 degrees. Let me just zoom in so that you can see it better. And this is the bar plot. So the maximum a team can purchase is 25 players. Some of the teams have also purchased 24, 22 and 23 players. Let me just show you. So Gujarat Titans have totally purchased 22 players. Then Delhi Capitals have total 24 players in their squad. Again, Lucknow Super Giants have 22 players. If I scroll and see again, Bangalore Royal Challengers or RCB, the Royal Challengers Bangalore have 22 players in the team. and Rajasthan Royals and Sunrisers Hyderabad have 24 and 23 players respectively in their teams. Alright, now we will create 3 more columns called retention, base price and base price unit. For that, first of all, I am creating a new column called retention, which is equal to IPL base price. Let me just run it, and then I'm going to replace these values that are present in the list: 2 crore, 40 lakh, 20 lakh, 1 crore, 30 lakh, 1.5 crore with from auction, and I'm saying in place equal to true. Let me just run it. Then we are going to treat the base price. So here in the base price column, I'm going to replace draft pick value as 0. So let's run that as well. And now I'm going to split the base price value into 2 separate values called base price unit and base price. So basically I'm splitting on the space that I have. Let me show you how it is going to split. So this is, let's say, our base price column. What I did was I replaced the draft pick values to 0, and then the rest of the values will be split into 2 columns called base price unit. So basically it will have the unit of the base price, let's say crores or lakhs, and the base underscore price column will have the value, which is 2, here 40, 20, 20, so on and so forth. Let me just scroll down and run that particular cell. Now to create these 2 columns, the base price unit column and the base underscore price column, I have used the lambda function and I'm splitting based on the space. Let's just run it. Now I have replaced retained with 0, and let me show you the final data frame that I have. So here you can see we have replaced the draft pick values in the base price column to 0, and on the right side you can see the 3 different columns that I wanted to create. So one is called retention. So zeros refer to draft pick. Any other value will say the player was picked from the auction. Then you have the base price unit. So here you can see crores, lakhs, and the value base price is 2, 40, so on and so forth. Cool.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's check how many players were retained and bought from the auction by each of the teams. So I'll say IPL, let me just scroll down, dot, I'm going to use the group by function. Then I'll say team, comma, retention. Then I'm going to use the value as retention because I want to find the count of retained players. And then I'll say colon -1. Let me run it. You can see here the different team names because I have grouped by team and then retention. So I have Chennai Super Kings. From the auction they had picked 21 players and they had retained 4 players. Coming to Delhi Capitals. Delhi Capitals in the 2022 IPL auction, they picked total 20 players and they have retained 4. Similarly, if I scroll down, let me talk about, let's say, Punjab Kings. They have picked 23 players from the auction and retained 2 players from the team last year. Talking about RCB or Royal Challengers Bangalore, they have picked 19 players from the auction and they have retained 3 players. Alright. Now in the next cell of code, we are going to display the players in each team based on the different types of players. So let me just run it and show you the result. So here I am using the same condition. The value shouldn't be equal to unsold, and I'm going to use another parameter called hue for the different colors. So here I have used hue as type because I want to show the players in each team based on the different types. Again, I have given my title to the bar plot, and then I have the X label, the Y label, and my rotation is 50 degrees now. If I scroll down, you can see the different types of players. Here is the legend. So blue is for bowler, orange or yellow is for all-rounder, green is for batter, and red, which also looks like maroon, is for wicket keepers. And on the x-axis you can see the different team names. Alright, now let's answer another couple of questions. So here I have, what is the highest amount spent on a single player by each team? So to solve this question, I'll say my data frame name, that is IPL. Then I'm going to say retention equal to this should be from auction, because we want to see the highest amount spent and not from the retained players. Then I'm going to group by, I'll say team, and then I'll say cost in, let me just copy it from here, cost in rupees, that is in crores, and I'll say max colon -1 dot sort underscore values, I'll say ascending equal to false, which means I want the sorted result in descending order. Okay, let me just bring this to the left side and we'll run it. There seems to be some error. Let me check the error. It says there's a spelling mistake. This should be team. Let me run it again. There you go. So you can see Mumbai Indians have spent 15.25 crores for one of the players, and this player happens to be Ishan Kishan. Then Chennai Super Kings have spent the highest amount for a player who happens to be a bowler. The name is Deepak Chahar. They have bought him for 14 crores. Kolkata Knight Riders bought Shreyas Iyer for 12.25 crores, and so on and so forth. So these are the highest amounts spent on a single player by each of the teams. Let me scroll down. Now we are going to see the player retained at maximum value or maximum price. Now if you follow IPL, the maximum price at which a player was retained happens to be Ravindra Jadeja. So let's see at what price was he retained. I'll say retention equal to I'll say retained, then I'll say sort underscore values by equal to, I'll use the same column, cost in rupees, that's in crores. I'll say ascending equal to false dot head, and I want to find the top player. Again there's some error. Let's see where is the error. C is ascending equal to false dot head. Okay, this should be sort underscore values. Within bracket I should say by. I think this should be fine now. Let's run it. There you go. So you can see here our result is player name Ravindra Jadeja, who was retained for 16 crores by Chennai Super Kings. Cool. Now the next cell of code will display or print the top 5 bowlers who have been picked in this year's IPL based on their cost in INR. Let me just run it and show you the result. You can see here Deepak Chahar went for 14 crores. Then we have Shardul Thakur, who was bought by Delhi Capitals. Earlier he was part of CSK for 10.75 crores. Then we have Prasidh Krishna, who has been bought by Rajasthan Royals this time. Last year he was with KKR and he has been bought for 10 crores. Similarly, Lockie Ferguson has been bought by Gujarat Titans and he played for KKR last season. He has been bought for 10 crores while his base price was 2 crores. Then we have Avesh Khan. You can see Avesh Khan's base price was just 20 lakhs and he has been bought for 10 crores by Lucknow Super Giants again, and last year he was part of the Delhi Capitals. Now you can replace this value. Suppose let's say you want to find the top 5 batsmen picked or batters picked with the highest amount. You can just say batter instead of bowler, and if I run this, you can see here Shreyas Iyer was bought by Kolkata Knight Riders for 12.25 crores. Last year he was part of Delhi Capitals. Then you have Shimran Hetmeyer, who's from West Indies. He has been picked by the Rajasthan Royals for 8.5 crores. Then we have Rahul Tripathi, Shikha Dhawan and Devdutt Padikkal. Now if you wanted to check for, let's say, all-rounders, you can replace batter with all-rounder. If I run this, you can see Liam Livingstone has been bought by Punjab Kings this season for 11.5 crores. His base price was just 1 crore and last year he was part of the Rajasthan Royals. Then we have a player from Sri Lanka, Hasaranga. Then we have Harshal Patel, Shahrukh Khan and Rahul Tewatia, who have been the top 5 all-rounders picked at highest amount. Cool. Now finally, we want to see the players who were part of the IPL last season but were not picked for this year's IPL. So for that, what I'm doing is, first I'm renaming my 2021 squad column. This column I want to rename it as previous team. Let's run it. Then I'm going to find out the unsold players. So here I'm saying previous team not equal to not participated, and then I'm using another condition. The team should be equal to unsold, and I'm going to find out only the player and the previous team. So let's run it and see the result. So here you can see these players were part of the IPL last season but they haven't been picked this season, and last season they had played for, let's say, Suresh Raina played for CSK, Steve Smith was part of the Delhi Capitals, Sakib Al Hasan was part of KKR. If I scroll down, you have David Malan, who played for Punjab Kings in 2021, Owen Morgan, who played for KKR. He also captained KKR, but unfortunately he was not picked this season. Chris Lane from Australia also remained unsold this season. Andrew Tye, we have Ben Cutting, Aditya Tare. There are other players as well. We have Kane Richardson, Dhaval Kulkarni. Cool. So these were the players who were part of the IPL season 2021 but unfortunately were not picked and remained unsold for 2022 season. Cool. And that brings us to our end of this demo session on IPL data analysis 2022. So we learned how to use the different functions and attributes that are part of the Python libraries, and we manipulated the data, we visualized the data and answered some specific questions. In this video, we'll be using 4 publicly available datasets about Formula 1 that has information from 1950 to the 2019 F1 season. We'll see how using the Python libraries you can perform exploratory data analysis and draw valuable insights. So let's begin by understanding what Formula 1 is. Formula 1, also known as F1, is a motorsport defined by open-wheeled single-seat race cars. It features the best drivers in the most powerful and technically advanced cars. The sport is governed by the FIA, that is International Automobile Federation. Here 10 teams comprising of 2 drivers each compete in a series of races over a period of 1 year to find out the ultimate driver and a constructor champion. In our demonstration, we'll be using 4 datasets. Let me show them one by one. These are all CSV files. Now this is the first dataset that we'll be using in our demo. So if you notice, the dataset does not have column names. In fact, none of the datasets have column names. So while importing the dataset, we'll assign the column names using the names parameter. I'll show that in a while. Now this is the results dataset. The results dataset has information about the result ID. Then we have the race ID, driver ID. We have the constructor ID, grid, position. Then we also have information about the fastest lap. Then we also have information about rank, the fastest lap speed, and the status ID. Now moving on to the second dataset, which is about races. Now this is the second dataset which is about races. So it has information about the race ID, the year in which the race was held. Then we have the round number, circuit ID, then the name of the Grand Prix. So you can see here Australian, Malaysian, Chinese, Spanish, Monaco, Turkish, British, German, and others. Then we have the date on which the GP was held or the Grand Prix was held. We have the time and a URL which basically leads to the Wikipedia page of that particular Grand Prix for that year. Now moving on to our third dataset. So this is our third dataset which is about drivers. Now it has the driver ID, the name of the driver. You can see here Hamilton, Rosberg, Alonso, Raikkonen. Then we have Sato, Massa, Button, Weber, and all. After that we have the number code. Then we have the forename of the driver, the surname of the driver, and then we have the date of birth of that particular driver. We have the nationality as well. And we have the Wikipedia page for the driver. Now moving on to the last dataset, which is about constructors. So this is the fourth and the final dataset that we'll be using in our data analysis project. So here we have the constructor ID, then the constructor reference in Formula 1, and this is the actual name of the constructor. So we have McLaren, we have BMW Sauber, Williams, then we have Ferrari, Toyota, Red Bull, Force India. We also have Jordan, Jaguar, and all. Next we have the nationality and the URL, that is the Wikipedia page of that particular constructor. Now let's head over to our Jupyter notebook and we'll start with our analysis. Here is my Jupyter notebook that I'll be using for this demo. You can see some of the cells are already filled. This is just to make sure we save some time. So using these datasets that we just saw and our libraries such as NumPy, Pandas, Matplotlib, and Seaborn, we'll answer specific questions such as the drivers and constructors who have been the most successful throughout the history of F1 sport. Then we'll explore the impact of starting and finishing positions and if the speed of the cars has changed over the years. So let's begin with our analysis. First and foremost, we are going to import all the necessary libraries. So here I'm importing NumPy, Pandas, Matplotlib and Seaborn. Now after that I'm writing %matplotlib inline. That is to ensure that all the plots are embedded inline. I'll hit Shift Enter to run it. It'll take some time. There you go. So we have successfully imported all the libraries. Now the next step is to load the data and assign column names. So I'll load my first data, which is results. I'll say pd.read_csv. I'll give my file name, which is results.csv, and then using the names parameter I'll pass in the column names. So actually I have written the column names in a notepad. Let me open that. So I have this F1 notepad created which has the column names. I'll just start copying the column names. Within the names parameter I'll paste it. If I scroll to the right, you can see the different column names that have been assigned, and to that I'm going to say comma, and I'll write header equal to none. I'll close the bracket. Cool. Similarly, let's import the second data set, which is about races. I'll say pd.read_csv. I'll give my file name, which is races.csv, and then I'll give the names parameter. This is actually names and not name. Okay. I'm going to copy the second line and I'll paste it here, and again I'll say header equal to none. Next, we'll import our third data set, which is about drivers. So I'll say pd.read_csv. I'll say drivers.csv, and then again use the names parameter, and I'll copy the third line now, which has the column names for the drivers dataset. Here I need to give another parameter, which is header equal to none. Finally, we are going to import our constructors dataset. We'll say constructors equal to pd.read_csv, which is the function present in the pandas library. I'll say constructors.csv, which is my file name, and then again I'll use the names parameter. I'll go to my notepad, and this time I'll copy the fourth line, which has the column names for the constructors dataset. I'll paste it, and here I'll give my final parameter, that is header equal to none. Alright, now let me hit Shift Enter to run it. Okay, we see some error here. Let's debug the error. It says no such file or directory, drivers.csv. Let's see where was the issue. Okay, this should be driver.csv. Cool. Now we have successfully loaded the data and assigned the columns to the various data sets. Now the next analysis is to merge all the data set. So here I'll create a data frame called df, and I'll use pd.merge function. First I'll use the results data frame that we just imported above, this one, and I'm going to merge it with races data frame, and from the races data frame I'm going to take specific columns like the race ID, then I need the year, after that I need name. Next I'm going to take the round column as well, and I'm going to use on parameter. So on parameter is actually the column that is common to both the data frames, that is results and races. So here my common column is going to be the race ID because it is present in both the data sets, and I would like to merge. So for that I'm going to use how. So I'm going to use a left join. So if you know SQL, you will be aware of left join. It takes all the rows from the left table and only the matching rows from the right table. I'm again going to use the merge function. So I'll write df equal to pd dot merge. I'll say df comma, and now I'm going to merge the drivers data set, and I'm going to select specific columns. So I'll say driver ID. Make sure there are no spelling mistakes in the column names. Then I'll say driver ref, which is the name of the driver or reference, comma, and then I want the nationality of the driver. All right, I'll give a comma. I'll say on which column I want to merge. So here the common column is going to be the driver ID. Again, how is going to be a left join. Going to the final merge part, I'll say again df equal to pd dot merge. I'll pass in my data frame, and my final data set which I have is about constructors. From constructors we are going to choose specific columns. So I'll take the constructor ID, then I'll take the name column, and again the nationality column of the manufacturer. Here I'll say on equal to the common column I'll use is constructor ID. Give a comma and say how equal to left again. Cool. Make sure you're merging it with the right column names. So let's run this cell to merge all the 4 data sets. I'll hit shift enter. Oops, there is some error. Let's see. It says constructor ID index. Okay, there's a spelling mistake. This should be constructor ID. Cool. Let's run it. There you go. Now the next thing we want to do is to drop the unnecessary columns. So I'll say df dot drop. Within the drop function we are going to pass in the column names. I'll say number. Then we also don't want the position column. Next we have position underscore text. After that we have laps. Next we are going to drop fastest lap. Then we'll also drop the status ID, comma. We'll drop the result underscore ID column. Then going to drop the race underscore ID column. We'll also drop driver underscore ID column. And finally, we are going to drop the constructor underscore ID column, and I'll say access equal to 1, and in place I'll say equal to true because I want to remove it from my original data frame, that is df. There you go. Now the next thing I want to do is I want to rename some of the columns. So I'll say df dot rename, I'll say columns equal to, now we are going to pass in a dictionary. I'm going to change the rank to test underscore lap underscore rank. Let me give a comma. Now I'll say name underscore x equal to, I'll say the Grand Prix name, so I'll say GP underscore name. Next column I'm going to focus is the nationality column, so I'll say nationality underscore x. I'll give a colon. The value I'm going to pass in is driver nationality. Alright. Up next, we have one column called underscore y, and that I'm going to change it to constructor name. Another comma, I'm going to say nationality underscore y colon, change it to constructor nationality underscore nationality. Finally, we have driver underscore ref column, and that I'm going to replace with just driver. Finally, I'll say in place equal to true. Cool. Just verify if all the column names are correct. Let's run it. Alright, so now we have successfully renamed the columns. After that, in the next cell, I'm going to rearrange the columns. So here I'm using the same data frame and we have just renamed the columns. So starting with year, Grand Prix name, round, driver, nationality, and others. Let's run this. Up next, we're going to drop the 2019 season data because it is incomplete. So I'll say df equal to df, then I'll say year not equal to 2019. Let's see how to sort the values. So I'll say df equal to df dot sort underscore values, which is the function name. I'm going to sort it by year followed by round followed by the position underscore order, comma, I'll say ascending equal to first, let's say, is false, next I have true, and then I'll have true. Alright, moving ahead, now we are going to see how to replace the /n values in the time column with something called NAN, because the time column was not registered when a driver did not finish a race or was lapped by another driver. So to do this, I'm going to say df dot time dot, I'm going to use the replace function, and here I'll say / or /n, and I'm going to replace with numpy's NAN. I'll say in place equal to true. Let me just copy this because we are going to use the same meters. Next, I'm going to replace the milliseconds value, the milliseconds dot replace, I'll paste it here, then I'll say df dot fastest underscore lap underscore rank dot replace, paste it. Next I have df dot fastest dot lap dot time, say replace. To that I have the next column, which is speed, so I'll say fastest underscore lap underscore speed dot replace, I'll paste it. So here I'm going to replace this particular value, the backward /n, with NAN. Let me run it. Cool. Step, I'm going to change the data types for fastest underscore lap underscore speed to float, then fastest underscore lap underscore rank to float again. Now problem here is we cannot convert it into an integer because there are missing values, so we are going to change it to float. Again, for milliseconds also we are changing it to float values. Let me run it. Now I'll reset the index. Let me show you how to reset the index. I'll say df dot reset underscore index. I'll say drop equal to true. I'll give a comma and say in place equal to true. Alright, that we have done our initial processing step of the data set. Now we'll check the shape of the data set. Then we see all the data sets, the total number of non-null values, the memory usage, and we'll check the head of the data set. Now to see the total number of rows and columns, I'll say print df dot shape. You can see here there are total 24,197 rows in my dataset, and there are total of 15 columns. Now let's use df dot info function. So it gives me the year, the Grand Prix name, the round number, driver, constructor name, grid, position order, total number of points, time, then time in milliseconds, the fastest lap rank, the fastest lap speed, the nationality of the driver, the nationality of the constructor. Then here we have the total number of non-null objects, and then you also have the memory usage at the bottom. Finally, let's see the head of the data frame. So I'll say df dot head. Let's say I want to check the first 10 rows. There you go. If I scroll down, you can see here we have the top 10 rows printed, and you have the year, the Grand Prix name, round, driver, constructor name, and other columns. Now let me just brief you about what these column names stand for. So the year column that you see here is the season that the Grand Prix took place, and then we have the name of the Grand Prix. Now the round column is the number of the race in each season. For example, 1 means it was the first race of the season, and then 2 means it was the second race of the season, so on and so forth. Then we have the name of the driver. For that we have the name of the car constructor, so you can see Ferrari, Mercedes, Red Bull, Renault. Then we have the grid, that is the starting position before the race. Actually, this depends on the qualifications which occur 1 day before the race. Then we have the position underscore order column. This means the final position at the end of the race. Then we have the points column, that is the total number of points scored in the race. Next we have the time, that is the amount of time that took to finish the race. Only the winner's time is displayed, and drivers behind the winner are shown how far behind the winner they are. Then we have the milliseconds column, that is the amount of time that took to finish the race in milliseconds. If I just scroll down, I'll just move to the right, go to the top. Then we have the fastest underscore lap underscore rank, that is the order of the fastest lap during a race. Next we have fastest lap time, that is the shortest amount of time that took to complete a lap in the race. Then we have the lap speed, that is the average speed of the fastest lap. Then we have the country to which the driver belongs to, and then we have the constructor nationality, that is the country where the car constructor is based out of. Okay. Now here I'm going to set my figure size to 10,6. This is going to be for all the plots that we are going to create afterwards. Cool. We'll create a data frame that will have all the Grand Prix winners. So here I'm going to say driver underscore winner equal to, use my data frame df dot, I'll say loc, then I'll say df, I want the position underscore order, and that should be equal to 1, so which means the driver won the race. And then I'm going to use the group by function. I'm going to group it by driver, and for values I'll say position underscore order. Use the count function followed by sort underscore values. I'll say ascending equal to false. Change it to 2 underscore frame dot reset underscore index. So what essentially I am doing here is I am finding out all the drivers that have participated and won a Grand Prix. Next, I'm going to create a bar plot. So this is going to be the first visualization of our analysis. So I'll say SB, which we have taken in our analysis. Ideally it should be SNS, but SB also will work. So I'll say SB dot bar plot. I'm going to say data equal to driver underscore winner. In the y-axis, I'll have driver. In the x-axis, I'll have position underscore order. Then I have color equal to green. That I'll set my alpha value to 0.5, or let's say 0.8. Then we are going to give a title to our plot. So I'll say plt dot title, let's say most Grand Prix winners in F1. Then we are going to label our axis. So for Y label, I'll have driver name. We have the X label that will have number of Grand Prix wins, and I'll say plt dot y ticks. Cool. Let's run it, and you can see we have our first bar plot here. Now the bar plot shows that there are a large distribution of Grand Prix wins. Only a few drivers in history of F1 have won over 20 Grand Prix in their careers, and there are some drivers who completely dominated the F1 racing and have won over 50 Grand Prix in their careers. So we are going to focus on those top 5 or top 10 drivers in the next section. So what I am doing here is, from the above result that we just got, I'm going to filter out only the top 10. So I'm going to use the head function, and inside that I passed in 10. If I print it, you can see here, as per the data that we have Michael Schumacher, who is the position order leader with 91 GP wins. Then we have Hamilton, Vettel, Prost, Senna, Alonso. Then we have Stewart, Clark, and Lauda. The data that we have is not the most recent one. So if you check the actual stats, Hamilton has actually overtaken Michael Schumacher and has won over 103, close to 103 races as of now. And next we have Michael Schumacher. So this is not the most recent data. Cool. Now using this data, we'll create another bar plot for the top 10 drivers. So I'll say sb dot bar plot. I'll say data equal to the name that we have used, that is top 10 drivers. So I'll say top 10 drivers. In the y-axis, we'll have the driver name. In the x-axis, we'll have position underscore order. For the bars, I'm going to use a color equal to, let's say, blue this time. I'll set my alpha value to be 0.8, and I'll say, let's say, line width equal to 0.8, and I'll also give an edge color of, let's say, black. Cool. Follow the same drill. I'm going to give a title to my plot. So I'll say plt dot title most GP winners in F1. I'll give a Y label that says driver name, and then I'll have X label, which will have number of Grand Prix wins. Cool. Let me see if everything is fine, and then we'll run this. There you go. You can see we have a very nice horizontal bar plot that shows the top drivers in F1. So as per our data that we have Michael Schumacher, who has won over 91 or close to 91 races. Then we have Hamilton, Vettel, Alonso, Clark, and others. All right. In the same way, we are going to create bar plot for the top constructors that have participated in F1. So here I'm finding out all the constructor winners. So here I'm using my position underscore order equal to 1, and then I'm using the group by based on the constructor name, and then I'm finding the count of position order and sorting the values in descending order, and I'm changing it to frame or to a data frame. And to create my bar plot, I'm using the bar plot function, the data which is constructor underscore winner. In the y-axis I'll have the constructor name, on the x-axis I'll have the position order. So you can see here I've used color as pink, and I've given a title, x label, y label, and y ticks. Let's run it. There you go. So here you can see again the data is widely spread. So we have a lot of constructor names. Now our next task is to check the top 10 GPA constructor winners. So here I'm using the head function and finding out the top 10. If I run it, you can see here the manufacturing companies or the constructors who have won the most number of races are Ferrari, McLaren, Williams, then we have Mercedes, Red Bull, Team Lotus, Renault, and others. Okay, now we'll convert this data into a horizontal bar graph or a bar chart. So that will show the bar plot for the top 10 constructors. Now let me show you how to do it. So I'll say SB, which is for Cbond dot bar plot, going to say data equal to top 10. Let me just confirm the name. We have top 10 constructors. Scroll down, I'll say constructors. The y-axis I'll have constructor on the x-axis I'll have position underscore order. Then I'll say color equal to, let's say we'll use the red color for the bars. Then I'll set my alpha to 0.8. I'll say line width equal to 0.8, and my edge color I'll say black. That I'll say plt dot title, say top 10 most GP wins, plt dot y label would be constructor name, and I'll have plt dot x label as number of GP wins. Cool. Let's run it. There you go. So here you can see we have Ferrari at the top, then we have McLaren, Williams, Mercedes. I'm pretty certain by the end of 2021 season, Mercedes would have gained a lot of wins since Hamilton has been on the top for Mercedes for quite some time now. All right. Now, finally, we are going to create a regression plot that will show how two variables, that is the starting position and finishing position, vary. So to do that, I'm going to exclude the data points with grid 0 because it skews the data. So 0 means that the driver started from the pit lane. So I'm using this function called reg plot to plot my regression line. Let me run it and show you the result. There you go. So if you see here, we can easily see there's a linear relationship between the starting and finishing position. So on the x-axis we have the starting position, on the y-axis we have the finishing or the finished place. So which is what is actually expected, right? Now we can also see that most races had up to 25 drivers. You can see the density of the points here, but some of the races also had over 30 drivers. You can see the light color blue dots. Next, we are going to check whether the speed of the cars changed over the years. Now, since this data is only available from 2004 onwards, so we have taken years that start from 2004 onwards. Now let me show you the result of this data. So essentially we are plotting the average speed amongst all teams during the fastest lap at individual Grand Prix, and here on the y-axis you have the average fastest speed in kilometer per hour, and then you have the different GPs, and you can see here the year values. Now in general what we see is there's a decrease in the average fastest lap from 2004 till around 2015 for almost all the circuits, and again from 2015 onward the speed started to increase. You can see here there's an increase after 2015, there's an increase here as well. You can also notice that the speed is very different on each track. For instance, if you check the Italian Grand Prix, which is here, Italian GP has the fastest race in the calendar with average speed exceeding over 240 kilometers per hour. On the other hand, if you talk about the Monaco Grand Prix, let me show you. If you see here, the Monaco GP is the slowest race with average speed below 160 kilometers per hour. Now this is actually expected because the Monaco Grand Prix has very narrow streets and hence the drivers cannot drive fast in this circuit. Alright, so
hello and welcome to this session on Python projects, and today we are going to discuss about how we can leverage Python as a programming language in order to automate downloading of images from a web page or Google search. So we will see what all Python libraries and utilities are required in order to perform that activity. So this is primarily an automation activity which you can perform in Python, where you want to download certain amount of data, certain images. We are taking images as an example over here. So how can you scrap a web page, download the images automatically in a particular folder? Now what we are going to do is we are using the Selenium utility, the Selenium package in Python in order to perform this activity. So what we are going to do is we're going to import Selenium package, and then from Selenium we are going to import these libraries: WebDriver, by, then we are going to import request, IO, import image and time. Okay, so these are the relevant libraries which we're going to use in this particular example. Now, for executing this example, you need a particular Chrome driver. As we're going to use Chrome, we're going to download this Chrome driver. So in order to download the Chrome driver, you need to go to this URL of chromedriver.chromium.org.downloads, and please download the latest version. If you depending on what operating system you're operating on. So I am using Chrome driver Win32, so I'll download the Windows driver and unzip it at the relevant folder. So wherever you're going to unzip the Chrome driver.exe file, please give the path over here and then initialize that using the WebDriver utility which you have imported. Okay. So this is the initialization, and you can see a Chrome browser has got opened. Now we are going to create a function called get images from Google, and we are going to write a internal function which will scroll down, which will scroll through that particular browser to a particular position, and at a particular delay it will start downloading the data. Now as a sample, what we have done is we have embedded a tree search, a tree image search, Google search in my URL. So this search will automatically get opened from my Python script automatically. So you'll see that, and then I'm going to run that in a loop and put that image URLs as a set. Now I'm going to write a loop, how many images I want to download. By that I'm going to run a while loop on the particular function and write the piece of code in order to download till the time my max images have been reached. Now I will find elements by class name Q4LUWD. Okay. Now for images and thumbnails, I'll start clicking that image. So I'm using the Selenium utility over here. I'm clicking the image and then I'm getting the source attribute of the image URLs and then downloading it. So this entire function actually allows you to download the image. And then I have a function which is the download function. Now I'm going to download images from the web page. I want 4 images. Now please make sure that you have provided a path. So see, the images have started to get download, and 4 images, the parameters which I have passed, are getting utilized. And if I want to quit it, now my program has got quit. So if you see this, the browser from where the images were starting to get downloaded got opened automatically, and now as I have quit the program, it got closed. And here are the 4 images randomly which has been picked from that particular search and added. So I've killed the connection, so that's why this error is coming.
Hello everyone, I am Mayank and welcome to Simplilearn. Today we will take you through the hands-on lab demo of how you can automate Excel using Python. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes in the chat section. If there are any issues, do let us know in the chat section so that we can resolve them. I'm repeating again, before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. So I'm waiting for some more minutes to let other people join. Okay, till then, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great, I think we can get started. So in today's session, we will go through what is Excel. After that, we will see what is Python, and moving forward, we will see what is automation and where it is used. At the end, we will see a hands-on lab demo like how you can automate Excel with Python in detail. We already have dataset with us. We will perform different function and automate Excel dataset using Python. Before we move on to the programming part, let's discuss what is Excel first and importance of the same. So Microsoft developed Microsoft Excel, a spreadsheet for Windows, Mac OS, Android and iOS. It has calculating or computing capabilities, graphing tools, pivot table and the Visual Basic for applications. The Microsoft Office program package includes Excel. Users of Microsoft Excel may format, arrange and compute data in a spreadsheet. Data analysts and other analysts can make information easier to examine as data is added or altered by organizing data using tools like Excel. The boxes in Excel are referred to as cell and they are arranged in a row and column. The key features of Excel are the spreadsheet document in MS Excel can have headers and footers, and user can protect their data by giving it password protection. And the second one is filtering is supported, allowing you to locate the necessary data in your spreadsheet and replace it with the appropriate value. After discussing what is Excel, let's go through and see what is Python. So Python is the one of the most popular programming language available today. It is widely used in various sectors of business such as programming, web development, machine learning and data science. Given its spreadsheet use, it is not surprising that Python has surpassed Java as a top programming language. Python frequently used to create software, website and to perform data analysis and many more. Because Python is a general purpose language, it may use to develop a wide range of programs and isn't tailored for any particular issues. So the key features of Python are, it is open source and free. Python can be downloaded from the company official website. It is simple to download and install. Python is open source because allowing users with solid technical background to modify the code to suit certain business use case and product requirements. Since Python is a language for beginners, most anyone with a understanding of programming can quick pick it up and begin coding. So after seeing what is Python, let's move forward and see what is automating Excel with Python. We all know Python is dominant everywhere, and we also know that compared to other language, Python is beginner friendly and simpler to use. Automation is the one of the coolest thing you can do with Python. So how to automate an Excel sheet in Python? Imagine that you are asked to create accounts for 30,000 employees on a website. What would you think? You will undoubtedly become frustrated carrying out this task manually and repeatedly. Additionally, it will take too much time, which is not the wise choice. So just try to picture that what it is like for employees who work in data entry. Their responsibility is to extract the data from tables like Excel or Google Sheet and insert it in the another location. They read various magazines and websites, get the data there and they entered it into the database. Additionally, they must perform the calculation for the entries. In general, this job performance determines how much money is made. Greater entry volume, more pay. Of course, everyone wants a higher salary in their job. So, however, don't you find doing the same things over and over boring? The question is now, how can I accomplish it quickly? And how to automate my work? Spend an hour in coding and automating these kind of codes to make your life simpler rather than performing these kinds of things by hand. By just writing fewer lines of Python code, you can automate your laborious activity in simpler. So overall, Python Excel automation is a creative method that allows you to build visual reports on Python in a smoother manner, similar to how you would on Excel. Businesses can use Python Excel automation to streamline their operation in accordance with their requirements. So here is one question for you guys. I will give you 1 minute for this. You can comment or you can give answer in chat section so I can see the answers are given by you are correct or not. I'm repeating again. Here is one question for you guys. I will give you 1 minute for this. You can comment or you can give your answer in chat section so I can see if the answers given by you are right or wrong. So the question is, which type of programming does Python support? Object-oriented programming, structured programming, functional programming, and all of the mentioned. So I am repeating again, which type of programming does Python support? Option A, object-oriented programming. Option B, structured programming, functional programming, and all of the mentioned. So I am starting the timer of 1 minute. Just type your answers in comment section or in chat section. Do let me know your answers, guys. So please, I want that everyone should participate in this. So I'm starting the timer. So your time starts now. So I want that everyone should participate in this, guys. Please do let me know your answer in chat section or in comment section, so I can see if the answers given by you are right or wrong. So 36 seconds or more. Please guys, I want that everyone should participate in this. So let me know your answers in chat section or comment section. So you can just type the answers or A, B, C, D. Your wish, totally your wish. So 10 seconds are left, guys. Hurry up. Please, I want that everyone should participate in this. 5 seconds more. Okay, so time is over. We will give reply those who gave correct answers, and those who didn't give correct answer, we will give you a reply with the correct answer. Okay, so no worries. So now let's move to our programming part to perform Excel automation using Python. So first we will open command prompt to write command to open Jupyter Notebook. Jupyter Notebook. Yeah. So this is the landing page of Jupyter Notebook, and select open, select here new, open new file. So this is how the Jupyter Notebook UI looks like. So at first we will import some major libraries of Python which will help us in importing our workbook or worksheet. So the first one is, let me first rename this. We will write automating Excel using Python. Yeah, sounds good. Okay, so the first one is open PyExcel. Open PyExcel. Okay, I have to write import. Yeah, perfect. So a Python package called open PyExcel can read and write Excel 2010, XLX format, XLSM format, XLTX and XLTM files. It was created since there was no library that could read and write Office OpenXML files natively from Python. Since OpenPyExcel was initially based on PHP Excel, all praise to the PHP Excel team. So OpenPyXL does not by default provide protection from your quadratic blowup or billion laughter XML assault. Install diffused XML to protect yourself from these assaults. So we will write OpenPyXL and then like, yeah. So then we will write for importing our workbook. So we can write here from OpenPyXL import workbook load underscore workbook. Is capital here. So and this is for code for the importing our workbook. So let me write in comment like you can import workbook like this. So I can write you can import workbook this. Okay, perfect. Yeah. So here, so let me import workbook then. So I have to write wb for workbook equals to load underscore workbook, the destination of the workbook. So the destination is in like desktop, so I have to write C users LP 09375 stop dash automation dash learn dot cell sx format. Okay, cool. Users slp, this one desktop automation Simplilearn dot xlx. Fine. So our workbook is loaded to Jupyter notebook. We can see, yeah, perfect, no error. So let's active this workbook for the use. So we have to write ws for worksheet. So worksheet equals to wb dot active. Why active? Like import from OpenPyXL a workbook, there must be always been one worksheet in a workbook. It is accessible through the workbook.property active. So that's why we have write wb.active. So after making workbook active, so we will print our workbook like we can print. So print ws. So here you can see the sheet 1. So it is showing worksheet sheet 1. Why sheet 1? Because if you open your workbook and see, here is your worksheet name. Like I can, so this is my automation file. No. This is Simplilearn. So here you can see the sheet 1. That is why it is showing sheet 1 there. So okay, so let me just finish it. So moving forward, let's change the worksheet name. So I will write here import open pyxl. So like it's your wish that you want to write this import file or like this thing. This is not necessary at all. So now I will import the workbook. So I will write here wb equals to open pyxl dot load underscore workbook 1pyxl it is. My bad, sorry guys. So you have to give the path, so I can copy path from here. Yeah, perfect. Okay, sounds good. Yeah, here wb underscore sheet equals to wb and square brackets, then you have to write the sheet name. So there we have sheet 1. So sheet 1, okay, correct. So I can change with wb underscore sheet dot title sheet dot title equals to code with Simplilearn. Perfect. Yeah, seems good. Let me save this wd dot save and the same copy here, paste. Yeah, so when a sheet is generated, it immediately receives a name. Like they have sequential numbers of names like sheet, sheet 1, sheet 2 and so on with the worksheet. You can modify this name whenever you want to, like using the title property. So here let me save this and yeah, no error. So again go to Simplilearn. Yeah, you can see code with Simplilearn. First it was sheet 1 and now it is changed to code with Simplilearn. So let me cut this again. Okay. So if you want to change the color of your sheet name tab where is written code with Simplilearn, so you can write like here you can write wd, or okay, let me make this new one. Oh, okay, right, I will write here. So underscore sheet dot sheet underscore properties tab color equals to, here you have to give hex values, so 4 zeros. Okay, so let me save this. Okay, it is saying sheet 1. Why sheet 1? Because we already changed sheet 1 to code with Simplilearn. So what we have to do is, here we have to write code with Simplilearn. Okay, same Simplilearn, same code. Yeah. So what I will do here, I will just make W capital. So yeah, now it will work fine. Yeah. So if you save or run your code like this, let me show you one thing. Like color is already changed. Wait for 1 minute, guys. I will show you something crazy. So it will see like this W. Okay. So here I will small. So if you save or run your code, not actually save but run your code while your Excel sheet is open. So my Excel sheet is open, code with Simplilearn. Okay. So my Excel sheet is open. So it will give you error. Like which error? I repeat, like what error? This. Okay, let me do one thing. This is 1. Okay. It will give you Simplilearn 1 does not exist. Let me check. This is Simplilearn, code with Simplilearn 1. Code with, okay, W is capital there. Okay, see, this is a permission denied. then the location. It is showing permission denied. So this is something important to remember, that Excel file should be closed while running the code. I'm repeating again. So like this is something important to remember, that Excel file should be closed while running the code. So first what I have to do is close the Excel file, then I have to run it again. So no error now. So here you can see what we simply learn, that red color came. Yeah, perfect. So moving forward, let's create new workbook. Till we were working on the same worksheet which was present in my desktop. So let's create new workbook. So for that I have to write import Excel SX writer. So I will write here in command to create new workbook. W would be equals to Excel SX writer dot workbook, and where you want to save the workbook. So I will give the same path but with different name. So this time I will give only like coders, simply okay, simply coders. Then I will write wd close. Okay, I will run it. Yeah. So the primary class export by the XLS writer module in the workbook class, and that is only class you will need to instantiate directly. So the workbook class represents both the whole spreadsheet as it appears in the Excel and the Excel file as it is stored on the disk internally. So you can see now, yeah, you can see now the workbook which is created in the desktop with the same name with like simply coders. So this is done. Let's move forward and let's retrieve cell values. So right now we are not having any data inside the workbook. So let's put some random values like names and all. So I will put some random values. I will put here names. Okay. Here Mayank, Kaushal. Okay. Wow. Like Jelly. It. Chloe. So let's save it. Let's save it. And let's move to our coding part. So here what I have to write to retrieve cells. Here I just write a equals to a is variable here. So I am assigning is ws that a1 value, the value which is presented at a1. So here I will write in comments like to retrieve cells. Okay. So here I will print a okay. What I have to do is like we have created this one file, so it is not giving the this is giving sheet1.a1. Why? Because it is taking from the simply coders one. So what I can do is I can import this file because we have saved data in this file. So let's paste this here and make it active. Yeah. So yeah, you now I haven't write here value file name a1 only. So now it will print. names. Why names? Because at the A1 position we have names. So if you want to like print Anjali, so what you have to do is, okay, let me check this, B3. Okay, if you want to print Anjali, you have to just write here, just copy paste this code. Okay, just write here the location B3. You can see Anjali is printed. So this is how you can retrieve cells, and we can do the same for the other cells too. So there is one thing like retrieving, we can change the cells values too. So just we have to write here. So let me give first enter for the better visual. Yeah. So here what we can write is ws, like I want to change the name of I will take this A4 Smith. Okay, let me close this. Okay, I will give here A4 dot value equals to, here you can give the value. So here you can write Smith, you can write John here as a replace value. So I will write here in as a command, change cell value. Okay, so what you have to do is just save it, wb dot save. You have to give the path for the same. Yeah, fine. So let me save this, and let me save this first and run this first. Okay, no error. And let's open our workbooks to see the changes. So here you can see the changes has been implemented in our workbook. First there it was like Smith and now John. So like this you can change the cell values, and let's move forward and see how we can merge the cells in a worksheet. So like just close this, and yeah. So we are doing for the merging cells. So here I will write from open pyxl dot styles import alignment. So here I will write merge cells for your better understanding. Okay, so here I have to write wb equals to workbook. Okay, let me active this workbook, wb dot active merge the cell. Which one? Let's take for a while A1 and B2. Okay, A and B should be in capital letters. So after that we have to save this. We will save in this only. So I can copy, I can paste it here. Okay, fine. Like using merge underscore cells, and after giving cell position you can easily merge the cell. So let's see the output. So let me open this Simplilearn file. You can see they are merged together, and like, but what if you want the values at the same time? A should be capital alignment. Okay, so the same thing you have to write wdb equals to workbook ws equals to wb dot active don't have to give parenthesis ws dot merge underscore cells a1 b2. So here I have to give the cell value equals to ws dot cell which row which column. So I can write row equals to 1, column equals to 1. So cell dot value equals to, here you can give the value which you want to print at the cell. So here I will write code with Simplilearn. Okay, fine. So what we can do this, we can give the alignment. Alignment equals to alignment horizontal equals to center, and from vertical the same. Center. Okay, let me save this file wb.save at the same location. So I can copy the path from here. Copy here and paste here. So I will. Yeah, seems good. Let me save this. Why it is giving error? Cell object has no attribute alignment. Okay, alignment spelling is wrong. Sorry, my bad. GNMENT. It seems good now. Oh, good to go. So here you can see, like by giving row equals to 1, column equals to 1, basically position, and after giving the value to what to print on that cell, and one more thing is alignment. Like it is not necessary to give alignments, like I just wrote it to cover it like in video. So you can give alignments like right, left. This time I gave the center to print in the center. So let's move and see the results. So you can see the value has been printed exactly at the center of the cell. Well, I will make it like this. You can see the value is printed exactly at the center of the cell because I gave the alignment center. So let's do one more for like to see what is the default place if we don't give the alignments. Okay, if you don't give the center alignments, what is the default value? So let me first remove this. Okay, save, no issues. Okay, yeah. So with alignments, or here what we can do is like from open UI Excel dot styles import alignment. It is not necessary to write import alignments. Okay, this is without. Okay, I can write is default value. Seems good. Okay, everything we have to cover from here, so I can just copy from here and paste it here. So what we will do here, we have to give row equals to 6 and column must be 8. So let's make it B6 B6. Okay, let's column should be 6. So code with Simplilearn, coders of Simplilearn. Orders of Simplilearn, like we are giving the value. So at the same time we have to just save it, wb.save, save. Copy, paste here. Okay. So this time we are not giving the alignments. You can see here we have gave alignments, not now. So let's run this, and after that we will open our workbook. So this is saying merge cells. Okay, 2 must be greater than 3. Okay, so here what is happening? Okay, I can write here D6, right? So now it will run properly, I guess. Yeah, it's working. So let me open this. So you can see this is the default value of like it. So here you can see the value is printed at its default location, not in centered or not in right, not in left. It is default location. So till now we know how to merge cell. So I repeat, I hope you guys understand till here. If you have any questions or any query regarding any code or question, just put as in comments. Our team will shortly provide you the correct solution. So moving forward, until now we know how to merge cells. So let's learn how to unmerge cell. Okay. So let me open the code. Yeah. Let me open the code and write for you. So let me quickly write the code how we can merge cells. So we can write open, okay, from open py excel dot styles. So just I can copy paste from here. I have to write here import alignments. Okay, alignment only. So what we are doing here, though we will not give any value or any this. So here I will remove like B6 6. Actually we can give like A6 B6 as a value. So let's see the cells are merged or not by running it. Okay, see, permission denied because our Excel was open. So let me save this and close it and run it again. No error. So here you can see, let me zoom if I can. Yeah. So here you can see A6 and B6 are merged. So what should I do to unmerge? I have to write, yes, you can write here like here you can write ws dot unmerge underscore cells. Okay, cells, got it, and just give this same value a6 underscore b6. Okay, colon b6. Let me save this again. No error. Let me open the file. So you can see here A6 and B6 now unmerged. So by just using unmerged cells, you can easily unmerge the cells in your workbook. So let's move forward and see how can you set dimensions for a particular cell or column. So let me close this and go to the workbook again. This is something frustrating by regularly doing the same thing, going next. Oof. So like you need a particular column height should be something and width should be something. So That is what I'm like meant to be dimensions. So let's write code for it. You will see and understand by seeing. So import open pyxl hashtag to set dimensions of a particular cell. Okay, wb equals to open pyxl dot workbook worksheet equals to workbook dot active ws dot row underscore dimensions. Okay, one. I will explain you. Don't worry. Height equals to let me give 70 for a while. Okay, ws dot column underscore dimension width. I will explain you. Don't worry. Don't worry. 8. So let me save the file wb dot save and let me copy the path from here. Okay, everything seems good. Okay, y column. Okay, column name is like function or column dimension. Okay, dimensions. No error. So like this, you can see here 1 for the column, like 2 for the column, 3 for the column. Let me zoom it. You can see now 1 for the all the 1 column row, 2 for the 2 row, 3 for the 3 row, like this. For you can say I use 1 for the particular row, or you can say 1 for denoting row, particular row, 1 2 3 4 5 6 like this. ठीक है? I repeat, and particular alphabet to denote the column. See, A for this column, B for this column, C for this column, D for this column, like this. Okay, so here you can see every cell of row 1 has the same height, this, and every cell of every cell of column B has same width. So like we can do one more thing. We can print value though in a particular cell. Like, okay, let me close this and open this one. So what can I do is I can write here, like we can write at wd cell row equals to 1 comma column equals to 1. Okay, dot value equals to hello. Okay, and ws dot cell, here I will write row equals to 2 comma column equals to 2 dot value equals to coders. So I have to write it here, not below this. Yeah. Okay, cool. Let me give this space line. Okay, so let me save this and let me check. So here you can see hello is for the row 1 and coder at the column B. Okay, fine. So let me close this and okay. Next, I repeat. Next, let's see how we can move data to a particular row or column, or you can say a particular cell. Here we need data to make it move. So let's fill some random data on it. So what I can do is I can put some random data of like fruit, vegetables, and some names like Mayank, Anjali, Ubhav, Kaushal, Kahana, and we can give like anything Smith, John, and Chloe, Sarah, and I Sachin. Okay, I think this much is enough, so let me save this. And yeah, so data part is done, and let's move to the this one and write import open pyxl. Okay, so let me write here move cell. You can say move or jump, whatever you want to say. So from open pyxl import workbook comma load underscore workbook will be equals to load can give the path like this, yeah, C and V. Okay, let's make it active. WS equals to WB dot active of X seems good. Okay, so I have to move WS dot move score range. This is I can give. Okay, let me see the data first. Okay, I will make Anubhav here and Mayank here or here. Okay, so let's see again. I forgot. It is B5 and A4. B5 A4. Okay, so what we can do it like O B5 comma like row equals to 2 and call B rows equals to 2 and calls equals to 2. So let me save this w.save and so here what I am doing is changing the position of the value which is present in the location A4 and B5. So and moving them by, you can say the value will jump by 2 rows and 2 columns because I gave here 2 rows equals to 12, columns equals to 2. So let me save this, run this. Okay, and so here you can see. So let me run this, and what you have to do is open this file. Yeah, so you can see A2 means 1, 2, it comes, fruit comes here and coders come here. So this is how you can move your coding part. I repeat, so this is how you can move the cell values. So let's move forward, and so moving forward, let's see how we can insert a row in a workbook. Okay, so first what I will do is I will add some data like name here like fruits, and something like car, and here I can write bike, scooter. Okay, something here coding. Okay, all the data is filled, and all rows are filled by some values. So here we have no empty row present here till now. So what we will do is we will insert a row. Okay, so what we have to write is import open py excel hashtag insert rows. Okay, from open p excel import workbook comma load underscore workbook. To load let me copy the path. See. Okay. So let me make it active. So I want to insert row the position 2 and one more row at the position 5. So let me save this. I will copy from here. Okay, I will make it like this. So let me save this. No error. Let's move to the workbook. So you can see here row 2 is created and row 5 is created with no values. So here you can see rows are added to the particular position, or you can say the indexes. So we have seen how we can insert the rows. Let's see the deletion of the rows. So what we can write is, let me open the code. So what we can write is, let me copy to save our time. Okay, just delete this. So we can write ws dot delete underscore rows, and which row? 2 5. I will delete row number 2 for a while. So let me save this and run this. So now you can see empty row 2 is deleted. So by using insert rows and giving them index, you can insert the row at the index position you gave, and meanwhile you can use delete underscore rows function to delete the particular row. So moving forward, let's quickly write code for the insert column. So for inserting column, I will copy from here. Yeah, insert row column, and this one is for deleting row. Okay, so I have to write here ws dot active, not active, sorry, insert calls at the position second. Okay, at the position 1, and okay, I will make it insert calls at the position 3. Okay, let me save this file by copying this path. Okay, saving. Let me do one thing. Yeah, perfect. So let me open the workbook. So here what I've done is insert call at second position. Here we can't give alphabet, we have to give a number for denoting a position. So here you can see the column is added at the position 1 and 3. So by using insert underscore calls and by giving index, you can insert column in your workbook. So let's do one thing, guys. Okay, first let me close this and yeah. So what I was saying that let's do one thing, guys. You will tell me how can I delete a particular column. Okay, let me write here the question. Comments like how can you delete a particular column. Okay, I'm giving you 1 minute for this. Just comment the code for this column deletion, or else you can reply on chat. I will suggest you to write a comment because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answers at the end of the session, or our team will reply at your comment at the same time. So like for those who are watching this video, like we watch normal video, means you are not watching the live session. So what you can do is just pause the video right now and put the comment how you can delete the column. I'm repeating again, I will suggest you to write a comment because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answer at the same time, or our team will reply at your comment at the same time. And those who are watching the video like we watch normal video, so that you can do is just you can pause this video and put the comment how you can delete the column. So I guess time is up, guys. I hope most of you gave the correct answers by putting comments. We will verify your comments and we will back to you soon. So okay, moving forward, let's see how we can style the font in Excel. Okay, this is something crazy and interesting, so you will not get bored. And writing from open py excel dot styles import font. So here I will write for your styling. Okay, so what I can do is like wb equals to open py excel dot workbook ws dot equals to wb dot active. Don't worry, I will explain you. Row equals to 1 comma column equals to 1 equals to Simplilearn. Okay, and I will set the size of the cell. So ws equals to cell row equals to 1 comma column equals to 1 dot value. Okay, here I have to write font equals to font equals to font, and here I have to write size equals to 24. Okay, here I have to give dot value. Okay, now we can do it for the many others. But we will do it we will change hello, not world again. We will write coder, hello coders, and here we will write code with simply learn, and here we will write hello YouTube. Okay, so what I will do is like it will 2 column 2 row 2 here. Here what I will do is font size equals to 24 and I will make it italic equals to true. Okay, fine, and I will make it bold. Bold equals to true, and here I will give 3 3 3. Okay, and at the end what I can do is okay by times new one. So let me save it quickly. wb dot save with the path. So let's run this and see the results. So let's run this again one more time. So here what I did is just gave the particular row and column value where we want to print the value, like Simplilearn, hello coders, hello YouTube, code with Simplilearn. Okay, and by using font I am giving the font size and font like italic, bold, and so on. Like this is italic, this is bold. Okay, and here you can see at the end by using name, here you can see at the end by using name we are assigning the styles of the particular text like Times New Roman, and you can give the name of your choice. So why it is not, because I have gave the it is collapsing. So here I have write 444. Okay, now it is collapsing now. Hello YouTube and Simplilearn. So what I will do is now I will run. Now you can see. Yeah, perfect. So this is simple one. This is it in italic. This is in bold, and this hello YouTube is in Times New Roman style. Okay. So okay, let's move forward and do something with cells. Like what we can do it. Let's do color them. Okay. Let's write code for this. How we can like color a particular cell. We know how to color the particular tab of sheet, and now let's color it. So we can write is import open py excel. Here I will write coloring particular cell. Okay, so I will first copy this thing here from here. Okay, I don't think I want this. I have to write from open py excel styles port pattern fill. I want something like this. Okay, so wd dot open pyxl workbook. So here I can write open pyxl dot load workbook. Okay, workbook, and here I will give the path fill att pattern. Type should be, I will prefer solid. Okay, and comma, here, comma, fg color foreground color equals to, I will write here f c 2 c 0 3. Okay, fine. We can make four cells. Four cells are enough, I guess. So we can write here cell 1, paste, copy, paste, copy, paste. So we'll 4, 3, 2. Solid, yeah. So let's change color. We can give 0, 3, FC, F4. Here I will give 3, 5, FC, 0, 3. Perfect. Here I can give FC A03. So now let me assign the cells to them WS, like I can assign A1, assign A2 dot fill equals to fill underscore cell. Okay, fill underscore cell 1. That seems good. This I can make it for 4. Same here, A2, A4, A5, A3. Everything seems good. Let me save this. So I will copy from here. Why error permission denied? Because it was open. So let me cut this. So let me see. So here I'm using the pattern fill to fill the color in solid style and giving the FG color like foreground color. And at the below you can see I'm like assigning the cells to a particular pattern fill cells. So let's see the output. Yeah, it's working. Here you can see the results. We colored these for the particular cell like A2, A3, A4, A5. So this is something you can style the color. So let's move forward and see how we can import the image in our workbook, like something here, something here, something here. Let's see. So let me first cut this. Okay, let me do one more thing. Yeah, perfect. Coloring particular cell. So how we can import our file or image, you can say. So I will write from open pyxl Import load underscore workbook. Okay, load underscore workbook, and I have to write here workbook, write wd equals to load underscore workbook, and give, let me copy this and this whole. So logo is for variable used for the image. Okay, so I don't have any image for right now. Let me do one thing. Let me import one image, any kind of image for a while. So I can do like, so this is my image. What can I do is I can give the path like path would be same. We will change here something. Don't worry. Desktop. Don't remember name of the file. This is picture 2. Okay. P is small or capital? P is capital, so I have to write picture 2.png. Okay, so I will give logo dot height equals to 150, logo dot width equals to 150. A bit of resizing to not fill the whole spreadsheet with the logo, so that's why just for that. So ws dot add image to logo, comma, cell, in which cell you want to print. I will M2. Fine. So here we will save it by using this one. Okay, perfect. Cannot import name image from open file drawing this one. So might be there is problem. Open pyxl dot drawing dot image. Okay, import image. I think I is capital here. Seems logo image. Okay, I is capital here. Yeah, it seems good. Yeah, here is the picture. So what can I do is, so here we need one more library, drawing image, variable logo. This one is for the location of the image, and giving and height and width, because a bit of resizing to not fill the whole spreadsheet with the logo, like with the whole spreadsheet with the logo. So just a bit of resizing. And add image function is used to append image on it, and m2 is for like this. M2 is for position, m2, like that. It's for in which cell you want to append it. So image is coming to the particular index m2. Okay, so this is how you can import image in Excel using Python. Okay, let's move forward and see how we can import date and time. So let's write code for that quickly. Okay, so what I will do is I will write here import date time. I will write date time from OpenPy Excel import workbook import time. So what can I do is make it WB equals to workbook. Okay, blue should be capital here, and WS equals to WB dot active. So what can I write is WS dot cell row 1 comma column equals to 1 dot value equals to date and time. It's something. So I can write, copy it, paste it. What I can do is, let me first change the 3 row equals to 3. Okay. Column equals to 2, I guess. Value. So here I can assign date and time. Date time dot date time dot now dot string format strf time. So what you have to write it, %y %m for month, %d for days, %h, then %m for minutes, and %seconds. So that should be in between this. Okay. Yeah, perfect. So let me save this. Close it. Import data time, not date time. It's date time. Okay, row equals to 1. Data time, not date time. Again, date time dot now. Date time dot date time. Date time. So date time objects has no attribute strf time. Okay, time it is, yeah. Okay. Yeah. Finally it's working, no errors. So here okay. So here I have imported some libraries like date time and so on. strf time used for string formatter, and date time now used for the current date time. This date time now is used for the current date time. And so let's run this and see. So here you can see the correct time and date is coming. It can be different from which country you are watching this live session. So what if you want to print the time after like 2 seconds late? So for that we can write here quickly. So I will copy this whole. So like we have to copy this, and just what you have to do is let me make for to see the difference. V. Okay, 3 are enough. So what I will do is go 4, 5. Okay, fine. What I will add here is time dot sleep. How much second you want? Like 2 for this one, and something for this one, like 5 seconds for this one. Okay, so what we can do is let's save it and let's see the results. So here I've used the time.sleep function given parameter as 2 or 4, I guess 5, for printing the seconds difference. So here you can see the difference in seconds. Okay, the time is not coming. Wait, let me check. Okay, why permission denied? Sorry guys. Now I have to run it. Open it. And it is not coming. Why so? Permission denied. Okay. Let me run it again. Okay, because I am giving seconds difference, not that is why it's giving permission denied. So let us wait for 5 seconds. Okay, I think 5 seconds are over. Now we can open it. Yeah, you can see 47 seconds and 49, 2 second difference, and 49, 54, 5 second difference. So here I've used the time sleep function given parameter as 25 for printing the second difference. So let's move to the workbook. I repeat, here you can see the difference in seconds. So I hope you understand till here. If you have any questions or any query regarding any code or question, just put as in comment. Our team will shortly provide you the correct solution. I'm repeating again. I hope you understand till here. If you have any questions or any doubt or any query regarding any code or whatever it is, so just put as in comments or our team will shortly provide you the correct solution. So moving forward, let's see how we can add values as an array. Okay, so what I will write, import xlsx writer wb equals to xlsx writer dot workbook. Okay, I will give the path from here. Okay, ws equals to wb dot add worksheet. W should not be capital here. Okay, so what I will do is row equals to 0 and column equals to 0. Okay, so I will write here data equals to, and take as the names, just names. Okay. Just random names they are. Above, let's take one more. Kisle. So for item in data, okay, ws dot write I will explain you line by line, don't worry. Row, comma, column, comma, item. Perfect. So here what I will do is row plus equals to 1, or you can write row equals to row plus 1 wb dot close. Okay, let's save this. Let's see our data is appended or not. Okay, first I will explain this code to you. So here I have created one new workbook, name. No, I haven't created. So let me create two. Okay, example. Okay, so I'll run this. Yeah, perfect. So here I repeat. So here I have created one new workbook name example. So at row 0, column 0, I am printing my content values, like for data values. Using for loop, I am moving to the next iteration of the values, like from Anju to Koshu and then Mayank, then so on. So let's see the results. Okay. Yeah. So here you can see all the values are printed. So using these codes of line, you can do things like this easily. So for that we need data for that. So let me add the full data of let me copy some data from somewhere. So just give me a minute. Okay. It's the blank worksheet. Let me give me 1 minute, guys. Okay, what I will take is this one. I can take this, some values we can copy, like 50 values. Okay, 50 is I know. See, yeah. Okay, we have data now. Simplilearn. We have data in the Simplilearn. Okay. Now we can write code for that, like how to retrieve multiple column. So the same I want. See. Let's do wb dot active. Okay, ws equals to wb spreadsheet column in worksheet A. Okay, so what I have to do is just print column values, column dot value. I hope it will work. wb dot active workbook object has no attribute active. Okay, let me see. Okay, sorry. Import open py excel. XLS writer is used for to create new workbook. Okay, open py excel dot load underscore workbook. Now it will work, I guess. Still it is not working. Note. It should work, I guess. Open pyxl. Open pyxl. Dot load. Okay, sorry, my bad. Here, dot. Now it will work. Okay, sheet. It's too much. This is sheet 1. You never know when the sheet will create sheet 1. Yeah. You can see all the list of column A is printed here. All the 50 values, and you can match from here to all the 50s values. Okay, till Travis Scott. So let me match this till Travis Scott. Okay. So I hope you understand till here. If you have any questions or any query regarding any code, so just put as in comment, or our team will shortly provide you the correct solution. After doing importing, exporting the values and all, let's perform some basic operation like addition, average and all. Okay. So first we will start with the addition. So I will write here. So we need data in workbook for the addition. So let's take some data from which set? The same Insta data set. So I will take this 50 values are enough. Okay, copy it and let me paste here. So data we have, let's code for it. We have to write here import open pyxl. We are doing sum of columns, not column values. Yeah, like from open pyxl import workbook, comma load underscore workbook. So wb equals to load underscore not workbook copy the path. Okay, so I will make it active. So here what I'm doing is, I will tell you shortly. So it is in C, I guess. C or B? Which column? Oh, B. So B 51, I guess. Yeah. B51. B should be capital, equals to, see carefully what I'm doing, like sum from B1 till B, I guess 50 values we have, 50. Okay, B should be capital, my bad, sorry. Okay, this is what I'm doing, and wd dot save, where is the save one? Okay. So here I have added all the values which are between in the range of B1 to B50, and what I'm doing is the result will be displayed on the B51th cell. Okay, so let's run this code. Okay, let's go to the B51. Yeah, result is coming. For verifying the result is correct or not, I won't use calculator for this. So we can use this code for the same for average, product and count. So let's do it quickly. Okay, so let me just copy paste this stuff. CV, this is will be for average. A spelling mistake, average. Okay, what I will do is just write capital average here. Okay, and I will print it to 52. Okay, code is almost same, just one change, like you have to write instead of sum you have to write average there, and just okay, let's see then. So now you can see this is the 137 point something 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 is the average of these all values. Everything look good. Let's see the count quickly. Let's we code is almost same, just we have to capital 53. Visible? Okay. This count will give you how many values are there between the range till 1 to 50. So let's check, let's run it again and check if it's working or not. Yeah, 49 values. Okay. So what I'm planning is, let's do one thing now guys. You will tell me how I can find the product of a particular range. I'm writing question as a command as I did before. So how to okay, how to find product of numbers, like where the range is between A2 to A98. Okay, so I'm giving you 1 minute for this. Just comment the code for this like multiplication, or else you can reply on chat. You can write just syntax only for the product. I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide the answers at the end of the session, or our team will reply at your comment at the same time. And those who are watching the video like we watch normal video, or you are not attending the live session, so you can just pause this video and comment on how we can find the product in Excel using Python. I'm repeating again, I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answers at the end of this session, or our team will reply at your comment at the same time. Those who are watching this video like we used to watch normal videos, so what you can do is just pause this video and comment on how we can find the product in Excel using Python. So I guess time is up guys. I hope most of you gave the correct answer by putting comments. We will verify your comments and we will back to you soon. So moving at the last of this session, let's do something with charts. So what I will do is, first I will move it bit up. Yeah. So let me write code for that, for the chart. So I will write from open py excel import workbook from open py excel dot chart import reference comma line chart. Okay, we will create line chart. WB equals to workbook, WS equals to workbook dot active. So after this I will set the chart title, title equals to chart. Okay, let me create the rows. So rows equals to I will do is I will create something like weeks, okay, comma sale, comma veggie sale. This comma not here, comma, and I have to give the values. Weeks are Monday. Okay, let me give the same. Food sale should be like 100, comma 200. Tuesday, comma 200, comma 300. Wednesday, 300, comma 400. For the Thursday, comma 400, 30. Day, 20, comma Saturday. Sixty, comma 30. Okay, it seems good. Let me do like for rows. Okay, row in rows. ठीक है. WS dot append row values equals to reference WS comma min call equals to 2 comma min row equals to 1 comma max column equals to 3 comma max underscore row equals to 7. Okay, it seems good. Okay, x dot values equals to reference underscore string equals to chart A2 A7. So chart equals to line chart we are making. So let's add the data to line chart object. Chart dot add underscore data values comma titles t titl yes titles underscore from underscore data equals to true. Okay, T should be capital. So let's set x-axis chart dot set categories x underscore values okay, let's set chart dot equals to sales chart dot axis equals to weeks and chart dot y axis dot title equals to fruit and veggies sales. Chart dot legend dot position equals to b. Okay, so ws dot add underscore chart comma h1 cell. So wb, okay, let me copy this code from here. Yeah. So here I am importing reference and charts library like this, reference and charts library, and just giving title as charts. You can say here chart. So rows are the data from which we will make chart, and for loop is to append the data on the workbook. Chart add data values titles from data equals to true. This is for adding data to the line chart object, just giving the title x-axis and y-axis and all. So let's save this and see whether chart is visible or not. Let's save this. Okay, what is it going? Cannot import name reference from open file reference. Okay, let me see. Error in line 2. Okay, sorry, my bad. Okay, now it will workbook fourth number workbook. Okay, w should be capital. Now it will work, I guess. Again, that's reference. Okay, x dot values chart, my bad, h-a-r-t c-h-a-r-t .save. Okay, wb.save. Okay, finally no error. So let's save this and see whether chart is visible or not. Let me go to the Simplilearn. Yeah, you can see chart is coming and it looks so good. I hope you guys must have understood the concept of automating Excel with Python. If you have any queries or doubt, you can ask them in comment section below. Our team will respond as soon as possible. And if you want this full code, just comment for the same.
A project on Python and how Python can be used to invoke and send messages in WhatsApp. So what we are going to today do is we're going to demonstrate you how to use PyWhatKit. It's a Python utility which is available in order for you to interact directly with the Python and WhatsApp. So we will show you certain examples using which you can directly interface with your WhatsApp. Now, in order to perform this activity, first you need to go to your Python installation folder. Now, in my case, I have my Python installed in my app data local programs Python 310. So your first task is to go and open a command prompt from this folder, and then you need to install pip install PyWhatKit. So under Python 310 there is a folder scripts, and you paste this command and you should get this particular message if you have already installed PyWhatKit. If not, then Python will install the relevant library in your computer. After you have done this, then go back to your Python root folder, go to the Python terminal, and then run the command import PyWhatKit. Okay, so after you have installed the PyWhatKit library, then you need to import the PyWhatKit, and this message should be successfully imported. Now, I want to send a WhatsApp message to a phone number, and I want to send it at a particular time. So right now I'll just set the time as 20:38. And please make sure that you are already logged in to your web.whatsapp.com, and so that when Python tries to send a message, you are already pre-logged in. Okay. Okay, so now if you see with this message, with this API, I'm going to send the message at 8:39. So this will go and open the WhatsApp window in next 46 seconds, and after 20 seconds the message will be delivered. So 8:39, so when the timer in my system clock will reach to this particular time, Python will open a WhatsApp window, log into that, reach to this phone number which is there in my WhatsApp contacts, and then after 20 seconds this message will be delivered. So let's just wait for a few seconds and wait for Python to perform that activity. Yes, now Python has opened the web.whatsapp.com in which I'm already logged in. It has reached out to that number and typed the message, "Welcome to Simplilearn World," and I can send this message. Now let's move on to another example. If I want to send a message to a WhatsApp group, then you need a WhatsApp group chat ID and the message you want to send. So now in order to send a message to the WhatsApp group, you can pick any WhatsApp group in which you are administrator, go to the group info and click invite to group via a link, and in this link copy this part, copy link, go to notepad, just copy this part, this is the group ID, okay, and paste it over here. Okay, so now you can send message to a group, copy paste this in your command prompt, set the timing, in 16 seconds WhatsApp will open a window, and after 30 seconds the message will be delivered. Okay, so WhatsApp window is open. It will reach out to that particular group. It will type the message and submit it, and even it will close the window automatically now. Okay, so this particular command has typed the message, submitted it, and closed the window. Now if you want to send the WhatsApp message instantly, you just use the API send WhatsApp message instantly, and it will send it instantly to the user. Now another utility is that if you want to find a keyword on YouTube, so we'll just play on YouTube, Simplilearn on YouTube. So it will automatically play the YouTube channel which you have put in that particular keyword on the YouTube. So Python can also directly open a YouTube URL, or if you want to do a Google search, here you go. So as soon as you put that command on the Python console, it will open google.com and search it.
In this video, we are going to perform a really interesting data analysis using Python on the Spotify music streaming service platform dataset. I'll also be asking you a few questions related to Spotify during our discussion. Please make sure to answer them in the comment section of the video. So now let's get started. Spotify is a Swedish audio streaming and media services provider founded in April 2006. It is the world's largest music streaming service provider and has over 381 million monthly active users, which also includes 172 million paid subscribers. The total number of downloads on the Spotify app in the Android store exceeded 1 billion in May 2021. So millions of people listen to music all day. Even I am hooked to music. As an analyst, what's better than exploring and quantifying data about music and drawing valuable insights? Before I move ahead, I have a quiz question for you people. The name Spotify comes from a combination of two words. So which are those two words? Please let us know your thoughts in the comment section below. I would like to repeat the question again. The name Spotify comes from a combination of two words. So what are those two words? We would love to hear from you. So please put your answers in the comment section below. Now let's use Python libraries and functions to analyze and visualize our dataset. First, I'll show you the two datasets that we'll be using. So here is the first dataset that we'll be using for our demo, and then I have my second dataset called Spotify features, which is essentially about the genres of the different soundtracks. Now these datasets have been downloaded from kaggle.com. Now the links to the datasets have been provided in the description box. Please go ahead and download them. Now let me just go ahead and brief you about the columns that are present in our first dataset, which is about tracks. We have our column A, which is ID. This is the unique ID for each of the songs. Then we have the name column, which is essentially the name of the song. Then we have a column for popularity. So the popularity ranges from 0 to 100. Then we have duration in milliseconds. This is the duration of the track in milliseconds. Next, we have a column called explicit. Now we are not bothered about this column because we are not going to use it in our analysis. Then we have artist, so the name of the artist who has composed or sung the song. Then we have ID of the artist. Then we have a column for release date, which is basically the date on which the song was released. Then we have a column for danceability. So this describes how suitable a track is for dancing based on a combination of musical elements such as tempo, rhythm stability, beat, strength, and overall regularity. The value ranges between 0 and 1. Next, we have a column for energy. So the energy is a measure between 0.0 to 1.0 and represents a perceptual measure of intensity and activity. Typically, the energetic tracks feel fast, loud, and noisy. Higher the value, the more energetic is the song. Then we have a column for key. So key is the pitch, notes or scale of song that forms the basis of a song. There are 12 keys ranging from 0 to 11. Moving ahead, we have loudness. So the overall loudness of the track in decibels, it ranges from -60 to 0 decibels. Then we have mode. So songs can be classified as major and minor. 1.0 represents major or 1 represents major and 0 represents minor. A column for acousticness. So a confidence measure of 0 to 1 of whether the track is acoustic or not. So 1.0 represents high confidence the track is acoustic. Then we have other information about instrumentalness. Then we also have a column for liveness. So liveness detects the presence of an audience in the recording. Then we have a column for valence. So valence is a 22 onwards. So all the songs from 1922 till 2021. Cool. Okay, so I'm on my Jupyter notebook. So you can see I have a few cells that have already been filled up. So we'll start with our analysis. First of all, let's go ahead and import the necessary libraries. So I'm importing NumPy, Pandas, Matplotlib, and Seaborn for my analysis and visualization. I'll hit Shift Enter to import the libraries. Alright. And in the next cell, I'm going to load my dataset using the pandas read_csv function. I have my location already put here. Let me show you the location where the data files or the data sets are located. So this is my location under Chrome downloads. I have a folder called Spotify datasets. Okay, so let's import and check the first 5 rows in the dataset. So for that I have used the head function. There you go. So here you can see I have my first 5 rows of information from the dataset. And on the top you can see the different columns. You have ID, name, popularity, artist. Then we have the release date, danceability, energy, key, loudness, liveliness or liveness, valence, tempo, and other information. Cool. Now let's check for null values in the dataset. I'll just give a comment as null values. Every time when you download a dataset from an open repository, there are chances that the dataset would contain null values. So it's better to check them beforehand. So I'm going to use the isNull function present in the pandas library. PD I'm using because I had imported pandas as PD. So pd.isNull. Then I'm going to use the variable name df_tracks because I imported my dataset and stored it in the variable df_tracks. So I have my data frame under df_tracks variable, and then I'll use the sum function to check the total number of null values present in the dataset for each of the columns. If I run it, there you go. So here you can see my name column has 71 missing values or null values, and we don't have any null values for the rest of the columns. Okay. Now let's use the info method that will give us the total number of rows and columns in the dataset, and we'll also check the data types and the memory usage. So I'll say my data frame name, that is df underscore tracks dot info. If I run it, you can see here, now if you mark, there are total 5,86,601 names, or the names of the songs present in the dataset, while the rest all have 5,86,672. So clearly there are total 71 song names or soundtracks missing from our dataset. And below you can see the data types. We have float, integer and object, and then you can see the memory usage. Cool. Now before I move ahead with our next analysis, I have another question for you. Which artist or musician has the most number of followers on Spotify? I repeat, which artist or musician has the most number of followers on Spotify? Please put your answers in the comment section below. We would be happy to hear from you. Now let's move ahead and do our first major analysis in this demo. We are going to find the 10 least popular songs present in the Spotify dataset. So I'll create a variable called sorted underscore df that will be equal to my data frame name, that is df underscore tracks dot. I'm going to use the sort underscore values function and say my column name is popularity. So I'm going to sort the values based on the popularity and then say ascending equal to true, since I want only the least popular songs. And then I'm going to say head of 10, which means I want the top 10 least popular songs. Now let's go ahead and print sorted underscore df. If I run it, you can see we have the list of 10 least popular songs on Spotify. You can see that popularity is 0, and you can see the names of the songs. Some of them are songs which are not in English language, and you can see the artist names as well. Cool. Now moving ahead, let's see some descriptive statistics for the numerical variables that are present in our column. So I'll say df underscore tracks dot describe, which is the function to get some descriptive statistics, and I'm going to use the transpose function after that. If I run it, there you go. So we have the statistics about count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, and the maximum value for these columns like popularity, duration in milliseconds. Then we have energy, key, loudness, mode. Cool. Now if you see this popularity column, the minimum value is 0 and the maximum value is 100, and you can see the 50th percentile is 27, which is essentially the median. You have the standard deviation as 18.37. Then similarly you can check for the other features as well. Cool. Now we'll see the 10 most popular songs which are greater than 90. So we are going to check for the top 10 songs with popularity greater than 90. Let me show you how to do it. So in this cell, I'm going to create a new variable called most popular, and I'll say df underscore tracks dot. This time I'm going to use the query function that is part of pandas library again. I'll use the column that is popularity, and we'll set the condition popularity should be greater than 90. I'll give a comma and say in place equal to false, because I don't want to change my original data frame. And then I'll say sort underscore values, and I'm going to sort it based on popularity in descending order. So I'll say ascending equal to false, and then let's take only the top 10 popular songs. So I'll say most popular, use square brackets, and we'll then pass the slicing operator and say :10. Now if I run this, there you go. So here you can see the 10 most popular songs that is present in our Spotify dataset. So first we have Peaches by Justin Bieber, Daniel Caesar and Givon. Then we also have a song name called Driver's License, Astronaut in the Ocean, Save Your Tears. We also have The Business, Streets and Heartbreak Anniversary. So these are the most popular songs that are present in our dataset based on their popularity. You can see Peaches has the highest popularity with 100. Alright, now moving to the next cell. So here we are going to set the index to be release date column in the main data frame. So I am setting my index using the set underscore index function. I have passed in my column name as release date and I'm saying in place equal to true, which means I want to change it in my original data frame, and then I'm changing the value to date time format, and let's print the head of the dataset. So you can see here we have successfully changed our index. Now here you can see instead of 0, 1, 2, 3 we have the release date column and the rest of the columns are intact. Cool. Now let's move ahead. So suppose you want to check the artist at the 18th row in our dataset. You can use the index location method for that. Let me show you how to filter only specific rows of information from the dataset. I'll use my data frame df underscore tracks, and using double square brackets I'll say my column name, which is artist, and I'll use the index location method and say, let's say I want to check the artist who is present in the 18th row in my dataset. So I'll use iloc18. If I run it, the artist's name is Victor Boucher. Cool. Now let's move ahead. We are going to convert the duration in milliseconds to just seconds. So if you see our dataset, we have a column called duration in milliseconds. So all our songs are present in milliseconds. Let's convert them into just seconds. So for that, I'm using the lambda function and dividing the values in milliseconds by 1000 so that they get converted into just seconds. I have used in place equal to true, so I want to change it in my original data frame. Let's run it and do the necessary changes. Alright, now we'll print the head of the dataset just to check the duration column. So I'll say df underscore tracks dot duration dot head. If I run it, there you go. So you can see the values have now been changed to just seconds. Cool. I have the final quiz question for you. Who has the most monthly listeners on Spotify? Please put your answers in the comment section below. We'd be glad to hear from you. Now coming to the next cell. So here we are going to create our first visualization that is going to be a correlation map. We are going to drop 3 unwanted columns, and those are key, mode and explicit, and then we are going to apply Pearson correlation method. Now I have set my figure size to 14,6, and then we are using the Seaborn heat map function to create our correlation map. I have put the variable that is correlation underscore df. You can see above we had created this, and then I'm setting annotation equal to true. So this will write the data value in each cell. I have set fmt equal to .1 G. So this is a string formatting code to use when adding annotations. Then I have set my vmin and vmax. So these are the values to anchor the color map. Otherwise they are inferred from the data and other keyword arguments. CMap here stands for color map. You can just search for SNS CMap. You will get the documentation. So you can choose whichever color palette or the color map you want. Here I have used Inferno and I have set my line widths and line color. Finally I am giving a title to my correlation map and I have set the X-tick labels. Let's go ahead and run this to get our first visualization. If I scroll down, there you go. We have got a nice correlation map. So here on the right side you can see the scale. It ranges from -1 to +1. -1 means the variables have least or negative correlation, while the values which are above 0.0 means that the variables have a positive correlation. Now here you can see there are values like -0.7 for energy and acousticness, which means if the energy is high, the acousticness is really low. Again, for loudness and say speechiness, if the song is loud, the speechiness is low, so there is negative correlation. But if you see for energy and loudness, there is a really high correlation between these two variables. You can see the value is 0.8. So if the song is loud, this implies the song has really high energy and vice versa. Now if you see for a few other variables, there is negative correlation between acousticness and danceability. There is negative correlation again between valence and acousticness. Similarly, there is positive correlation between energy and valence, which is 0.4, and even for danceability and valence there is positive correlation, which is 0.5. Cool. So from the correlation heat map you can note that acousticness appears to have a strong negative correlation with energy. So if you see for acousticness and energy, there is a strong negative correlation, and there is a moderately strong positive relation between loudness and popularity. So if you see for popularity and loudness, the color is orange, which means it lies in this positive region. And there is also a moderately strong positive relation between danceability and valence. So if you check for danceability and valence here, there is a moderately strong positive correlation. Alright, now let's move ahead. We are going to sample our data and take just 0.4% of the total data, and we'll create 2 regression plots using this data. So let me first sample my data. So I'll create a sample data frame using my original data frame, which is df_tracks, and say sample. I'm going to use the int function and say 0.004 multiplied by the length of my original data frame, which is df_tracks. Alright, now let's run this and we'll print the length of my sample data frame. If I run it, you can see 0.4% of my total data set is 2346 rows. Cool. Now we are going to create a regression plot between loudness and energy. Now in our correlation map, we saw there was a positive correlation between loudness and energy, which was 0.8. Let's plot it in the form of a regression line. So I'll use plt.figure. I'll set my figure size equal to, let's say, 10,
6, I'll say SNS dot regression plot. So I'm using the function called reg plot, and I'll use my data as sample underscore tf, give a comma, and say in my y-axis I'll have my column loudness, and in the x-axis we'll have energy. I'll give a color to my data variable. Let's say the color is C. Then I'll set my title to loudness versus energy. Let's say correlation. Alright. Let's make sure everything is fine. Now we'll run and see our result. There you go. So you can see here clearly there is a very high positive correlation between loudness and energy. On the y-axis we have loudness, and on the x-axis we have energy, and you can see all the data points or the songs are in one direction. So if the energy increases, the loudness of the song also increases, and similarly if the loudness of the song decreases, your energy of the song or the track also decreases. So there is a very high positive correlation, and you can see the regression line here. It has gone and is increasing gradually. Cool. Now similarly, I'll just copy this code, and we are going to see another regression plot, this time for two different features. Let's say we have popularity in the y-axis. So I'll say popularity, and then in the x-axis we have, let's say, acousticness. I'll change the color to, let's say, B, which stands for blue, and will set the title to popularity versus, I'll have acousticness correlation. Just scroll down and we'll run it to see the result. There you go. So I have the different points for the songs, and here you can see the regression line is downwards, which means if the acousticness of the song increases, the popularity decreases, and similarly if the popularity increases, acousticness decreases. You can see the downward trend of the regression line. Alright. Now in the next cell we are going to create a new column called year from our release date column, and I have changed this to date time format. Let me just run it. Cool. Now after that we are going to create a distribution plot to visualize the total number of songs in each year since 1922 that is available on the Spotify streaming app. So I have used my Seaborn library and dist plot function. Now one thing to remember, you need to update your Seaborn library to this version if you haven't done it. So use this command pip install --user Seaborn and the version. So here in the distribution plot we are going to plot a histogram. So I have used kind equal to hist, which stands for histogram. Let's run and see the result. Okay, so here you can see I have my distribution plot. So the plot tells us that the number of songs for each year in the dataset according to their release date have increased in the recent years since music became more accessible to people globally with technological advancements. So earlier you can see there were very few songs available in the 1920s. Later on the number of songs increased rapidly, and now you can see we have a lot more songs available for people to listen. Cool. Now we are going to see the duration of songs over the years. For that, again, we are going to create a bar plot. So I'll first create a variable called total duration equal to df underscore tracks dot, I'll use the duration column that we created with seconds, and then I'm going to set my figure dimensions. So I'll use figure underscore dims for dimensions equal to 18,7. After that, I'll have my figure axis defined. So I'll use the matplotlib subplots function, and I'll set the figure size equal to my figure dimensions, and then I'll say figure equal to sns dot, I'll use the bar plot function and say my x-axis to be years, my y-axis will be total duration or total underscore dr that we created here. I'll set my axis equal to ax, and then I'll set error width equal to false. Let's set the title for my plot as title equal to year versus duration, and finally I'll say plt dot xtext, I'll rotate it by, let's say, 90 degrees. Alright, let me just recheck once if everything is fine, and then we'll go ahead and run it. My axis, error width, title. Okay, let me just run it. We'll see the result in a moment. If I scroll down, you can see we have the bar plot for the different years and the duration of the songs in seconds in the y-axis. So earlier in the 1920s, you can see the duration of the songs were less, and later it increased around late 1930s, and this remained consistent until 2010, where the duration was high. But after 2010, you can see the duration of the songs have started decreasing. Now in the next cell, I'm going to create a line plot to analyze the average duration of the songs over the years. It is going to be similar to our bar plot, just that now we are going to visualize it in terms of a line. So I have my code ready. You can see here I've used my Seaborn library and the line plot function. In the x-axis I have years, and in the y-axis I have total duration. I've set my title to year versus duration, and I'm rotating my x labels by 60 degrees. Let's run it and we'll see the output. There you go. Now if I scroll down, you can see we have a nice line plot, and on the x-axis you have the years, and on the y-axis we have the duration. You can see that the songs from 1920s to 1960s have comparatively shorter duration, since most of the songs tended to be more singing based rather than instrument based. After 1960s, you can see the duration of the songs started increasing until I would say 2010, and in the present day the duration of the songs have started declining since the attention span of the average listener is also declining. Alright, now let's move to our second data analysis project, which is based on genres of the songs. So I am importing my dataset using the pandas read_csv function. I have given my location, and here I have my dataset name followed by the extension of the type. So this is a CSV dataset. Let's go ahead and run it. Okay, now let's print the first 5 rows of the dataset. I have stored my dataset in a data frame called df_genre. I'll use the head function to get the first 5 rows of information. I'll hit shift enter to run it. There you go. You can see here I have my genre column, artist name, track ID, popularity, acousticness, duration in milliseconds again, and we have the rest of the other columns that we saw in our first dataset. Just one thing to note, here key is present in terms of C, D, E, C minor, F minor, and not in terms of numbers between 0 to 11. Now we'll see the duration of the songs for different genres. For that, I'm going to create a bar plot. So I'll start with setting the title for my plot as duration of the songs in different genres. I'll use the Seaborn library and I'll set my color palette to, let's say, rocket. I'll give a comma and say as CMap equal to true. This would be color palette. Now I'll say SNS dot bar plot. In the y-axis I'll have genre, and in the x-axis I'll have my duration column, which is in milliseconds, so duration underscore ms, and then I pass my data frame using the data argument. So I'll say data equal to df dot genre. Next we'll set the x labels, so I'll say plt dot x label. Let's say my x label is duration in milliseconds, and then I'll say plt dot y label as genres. Now let's go ahead and run this. There you go. So here you can see we have the different genres on the y-axis, and on the x-axis you have the duration in milliseconds. And if you see the graph for classical genre and for songs that belong to world genre, the duration of the songs are more compared to other genres. Now if you check for children's music genre, the duration is less or the least. Cool. And finally we'll move to our last demo, where we'll see the top 5 genres by popularity. So I'll say SNS dot set underscore style. I'll set my style to dark grid, which will be my background, and then I'll say plt dot figure. I'll set my figure size to 10,5. Then I'll create a variable called famous, since I want to take only the most popular songs based on the genre. So I have created a variable called famous, and I'll pass my data frame name, that is df underscore genre, and I'll sort the values based on my popularity column. So I'll say popularity, and I want to sort it in descending order. So I'll say ascending equal to false, and I'll take the first 10 values. I'll tell you the reason why I'm taking the first 10 values and not 5. Then I'll say SNS dot bar plot, and in the y-axis I'll have genre, in the x-axis we'll have popularity, and I'll give a comma, and using the data argument I'll say my data to be famous, which is this variable that we created, and then I'll set my title as top 5 genres by popularity. Alright, now the reason why I took head of 10 is because there are a few genres which are repetitive. So if you see this, we have children's music appearing twice, so hence we have taken 10 instead of 5. Let me just go ahead and run it. There you go. So here if I scroll down, you can see I have my top 5 genres based on the popularity. So we have dance, pop, rap, hip hop and reggaeton. So these are the 5 genres which are most popular based on the data that we have collected from Spotify. Alright.
Welcome to the Simplilearn YouTube channel. In this session, we will learn how to create a QR code and then learn how to decode it. But before we begin, if you love watching tech videos, subscribe to our channel, like the tutorial and hit the bell icon to never miss an update. And before starting, let us have a simple question to brush up on our knowledge. And please answer in the comment section below. We will update the correct answer in the pinned comment. And your question is, what does QR in QR code stand for? And your options are quick record, quick response, quick review, or quick restore. You can pause the video, give it a thought and answer in the comment section. Now, moving on, let's learn a few facts about QR codes. QR codes are quick response codes used to store information that can be used to make a call, send a message or email, open a website, or even redirect to a location. And a QR code can store up to 4296 characters or 7089 digits in a single code, making it viable to hold large amounts of content. Let's see how QR code is generated on web. We will open the browser and search for any free website that is used to generate QR code. We will search QR code generator. And we can enter any URL or any text to just create a QR code. So we'll write Simplilearn, and you can see your QR code has been generated. You can download it, copy it and send to anyone, and he can just scan it and see the text Simplilearn. To check it, we can also open a QR scanner in our mobile phone. For that, we'll just write QR scanner in our Google Chrome or any browser and open any free one and just scan it. You can see that it has scanned and decoded it as Simplilearn, what we have encoded it in it. So let's move and create our own QR code scanner using Python. For that, first we'll create a folder. And name it as creating QR scanner. And inside it, we'll open the command prompt and open Visual Studio Code. I have chosen the Visual Studio Code as my editor. You can choose any, like Jupyter Notebook or PyCharm, any editor. And inside I will create the file and name it as qrscanner.py. And now the first thing we have to do is import the Python modules. So for that, the first module we would be importing is Python QR code. That will write the command pip install QR code. As you can see that it states that the requirement is already satisfied. I have already installed the Python package. You can use this command to install that, and if you face any issues, just comment down in the comment section and we'll get back to you. Now moving to our Visual Studio Code, we will import the package import QR code, and now we'll use the function make to make a QR code. For that, we'll write QR code dot make, and inside we'll just copy any URL link or any command, any contact information or anything. So we will go to our browser. We'll open the YouTube and search for creating a virtual assistant in Python. And we'll copy this URL and paste it in the make function, so that we'll get the QR code of our own video, that is creating virtual assistant using Python. Now we'll save this into a variable and name it as myQR, and get this variable saved as a PNG image so that we can get it in our folder, as our folder only contains the Python file. Now when we save this as PNG file, now you have to save your code and just run it. You can see that myqr.png has been generated. So just open it. You can see that you have got your QR code generated. And you can also make some options, that is scale. I will set the scale equal to 8. Let's save the file and run it. And you can see the QR code scanner. Now we will use a mobile phone. You can use any mobile phone, Android or iPhone, and just check it using any QR code scanner that is available on your browser, or you have any other app, you can use that. I'm using a free version on my web, and that is qrcodescanner.in. And on scanning, I got the link, and when I open it, I am redirected to the video, that is how to create a virtual assistant using Python. So we have successfully made the QR code scanner. Now we have made the QR code scanner and we can also decode it using the Python libraries. So for that we have to install two more modules, that is PySpark and Pillow. For that we'll write the command pip install PySpark. You can see that the requirement is already satisfied as I have already installed these modules, and we'll also install pip install Pillow. This is also installed, and if you face any issue in installing these packages, just comment down in the section. We'll get back to you. Now moving on to our Visual Studio Code. Now we'll use the class decode. First we'll import the packages only from PySpark dot PySpark import the decode class, and from Pillow import the image class. Now moving to decode the QR code, we will use the decode class from PySpark and use the image class and open our PNG file, that is what we named as myqr.png. And now we will store it in a variable that would be equal to, and now we'll print what is decoded, what would be decoded, and we'll just get the value. For that we'll get the information at the 0th index, that is data. We'll decode it in ASCII. So yeah, now we'll save our code and run it. Here you can see that you have got this link that is decoded, what you have encoded in the QR code scanner. And now I have a question for you to just check whether our QR code is working or not. Now you have to make a task to just scan the QR code and see whether it's working or not. For that we will create my QR1 equal to QR code dot make, and inside we will get a link for our website. Now we'll save the file and run it. And we'll get also as an image. For that we'll write myqr1.save and the name of the file and at a scale of 7. We'll save the file, run the file. Here you can see that the QR code has been generated and we have get it pasted for you guys. So just scan the QR code and check whether it's working or not. So just scan it and answer as yes or no in the comment section below. If it's working, just answer it yes, else no. Hi everyone, welcome to the Simplilearn YouTube channel. In this session, we will create a QR code scanner using Python. But before we begin, if you love watching tech videos, subscribe to our channel, like the tutorial and hit the bell icon to never miss an update. And before starting our project, let us have a simple question to brush up on our knowledge. And please answer in the comment section below and we will update the correct answer in the pinned comment. And your question is, what is the minimum decodable size for a QR code scanner? That is QR code only. And your options are 1.5 by 1.5 centimeter or 1 by 1 centimeter or 1.75 by 1.75 centimeter or 2 by 2 centimeter. You can pause the video, give it a thought and answer in the comment section. And moving on, now we'll start a project, that is create a QR code scanner. For that, first we'll create a folder and name it as creating QR code scanner, and inside we will open the command prompt and write a command code space period and press enter to open our IDE. That is, I am using the Visual Studio Code. You can use any IDE as you are comfortable with. And we'll create a file and name it as qrscanner.py. And now the first thing we will do is install the modules that we will require for the project. For that, we will open the command prompt. The first module we will install is OpenCV, and you can search for the command in the web, or if you know, you can just write it down and press enter for that. I will show you how to get for the command. You can just type OpenCV Python and press enter. You will see the first link, that is OpenCV Python. That is the original documentation, and you can see the command here. Just copy it direct to the command prompt and paste the command here and just press enter. As you can see that it states that the requirement is already satisfied. I have already installed the OpenCV module. You can just type in the command and press enter. It will just install it for you. And the second one module we will install is PySpark. Just open the official link and you can see the command here, pip install PySpark. Just copy it and redirect back to the command prompt and paste your command here and just press enter. It will do the work for you, as it is stating that the requirement is already satisfied. I have already installed the PySpark module. You can do that by just writing the command and press enter. Now moving to our Visual Studio Code. Now we'll start with our code, and we will import the packages. The first package we will import is the CV2, that is the OpenCV. The next we will import the decode class from the PySpark module. So for that we will write the command for decode. Now, the first thing we will do is we will create a variable and ask the OpenCL module to make the video capture function work for us. For that, we will create the variable and name it as CM. And the command would be cv2 dot video capture Now we will set the window. This is the window that would be reflected when we just make our camera equal to true. That is, camera is always defaulted as false. You have to make it true to get it, pop it on your window screen. And for that we will set the size cam.set, and first we'll set the width, and we'll set the width as 5 and set the pixels as 640. And now we'll set the height cam.set and height as 6 and pixel as same or 480, as you wish. You can set it as. And now we will make the camera equal to true, as it is a button for a camera and it's been defaulted set as false. We have to make it true. Now, while camera is equal to true, we will read the QR code scanner. We will read the QR code that we will show in our front camera. So for that, we will write the command when camera equal to true, that is when the camera is open. We would get two things, that is success and the frame, and that would be equal to cam dot read. It will read the frame that would be shown into our camera, and the success is it will return the boolean value, that is 1 or 0, and the frame is it would read the frame as captured by our front camera and decode it. Now to decode it, we will run a loop for I. We will make it as decode, and inside we will pass the frame, that is the frame captured by our camera, and print the type, that is which type it is, that is it's QR code or it's barcode or it's any other code. So it will just capture the frame and it will return or print it as which type it is. Now we will print what we will decode from the QR code. For that we'll write the command code.data, what data is stored in it, and we'll use the function decode, and the memory we would be using is UTF-8. Oh, sorry, we have taken it as I. And now, after we have read the frame and decoded it, we want it to sleep for some time. For that, we will just import the time module, and you can install the time module from the datetime module. You can just write the command pip install datetime, or you can just search on the Chrome or any browser about the datetime module and Python. You can just write datetime space Python space module. You will be just directed to the main documentation and you will get the command there. And you can just copy it and paste it in the command prompt and the rest would be done for you. As I've already installed it, I will import the time module and now make this frame sleep for about 6 seconds. And now we want to make or show the camera on a window. It should be popped up and we should be able to see it. For that, we will use the OpenCV module and write the command show, and we will name the camera window with our QR code scanner. You can name it anything as you want. So I will name it as our QR underscore code underscore scanner. And the next thing we will do is pass the frame in it. And we will just write another command that would be wait key function. That would be we will using the OpenCV module and the wait key function, and this would be used to capture the frame after the 3 seconds. So this is our code. We will save it and make it run. Okay, we got an error. Okay, this error is due to as I was using the front camera for recording and it was not able to capture the frames. So I have switched off the front camera, the webcam, and now we will again save the file and run it. Now you can see that the webcam has opened up, and now we will show it a QR code, and you can see that it has concluded its data as http://www.simplilearn.com. I have created the QR code in my mobile phone and made it available to the webcam, and it has showed us the output as http www.simplilearn.com. We can just press on click and click on the right button of the mouse. We will be directed to the link. Hi everyone, I am Abhisar Oja and welcome to the Simplilearn YouTube channel. In this session, we will create an MP3 player using Python. But before we begin, if you love watching tech videos, subscribe to our channel, like the tutorial and hit the bell icon to never miss an update. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, to let us know in the chat section. And before starting, first we should have a look on what we would create. So for that, we will move to our code. Simply run this. You can see that the Take Enter window has appeared, and this is our media player. We have named it Simply Music Player. We have the GIF that would be running continuously, and we have the Browse Music button, which will direct you to the any folder you want to open that have the MP3 player files. I have selected this folder. It has 4 files, and we'll play Hey There. We'll just click on that and click on the play button. It will play the music. Now we'll just click on the pause button. So this is our MP3 player. So before starting the coding, I have a simple question for you guys. So moving to that. So the question is, who wrote the poem Zen of Python? And your options are Tim Berners-Lee, Tim Peters, Guido van Rossum, or Kevin Goldsmith. You could see the poem here also. You can easily get this poem. You just have to write import this in your interpreter and just press enter. You will get the poem. So please answer in the comment section below and we'll update the correct answer in the pinned comment. You can pause the video, give it a thought, and answer in the comment section. So moving to our code, first we will create a folder and name it as create mp3 player using Python. And inside we'll open the command prompt and write the command code space period and press enter. This will open up the editor, that is Visual Studio Code. If you want, you can use any editor. You have hands on any editor, you can use anyone. And here we will create a file and we will name it as player.py only. And we would require music also for that, and some GIFs and some images for our buttons. You can easily get those images from any free images website, or you can just get them drawn in the paint or Photoshop them. You can arrange them from anywhere. So we have our pics in this folder. So we'll copy all these and we have the music folder. It has 4 files and this is the copyright free music, so we can play on YouTube. We will paste this in a folder only, that is create mp3 player using Python. Yeah, moving back to our Visual Studio Code. So first thing is we should install the Python packages before starting our coding. So we would require the takinter package. It is already installed as you install the Python. If you want to install it again, just go to your terminal and write the command pip install tk. As you can see that the requirement is already satisfied, so I don't have to install it again. You can install it just writing the command and press enter. And the next we have to install is the Pygame. To import the mixer class, the command would be pip install Pygame and press enter. You can see that the requirement is already satisfied. I've already installed the Pygame module. You just have to write the command and press enter. You will get them installed very easily. And the next module we need is time. So you can install the date time module or the time module. It's your wish. So we have to write the command pip install date time. So it was not installed on my system. It has been installed and it doesn't have some classes in the module. It has installed them and it says the requirement is already satisfied for other modules. Okay, so now, and the last is OS module. Install this window is not going, So we will just go to the terminal. Okay. Just get a terminal and write the command here, pip install os and press enter. So it will install the OS module for you. It is doing for me right now. And we would be using the takeEnter module to create the GUI. And takeEnter is a Python module that is used to develop graphical user interface. And as I told you, there's no need to install it. It is the part of the standard Python library, so it would be installed as you install Python on your system. So it's downloading. Till then, we'll just import our packages. First, we'll import time, and that we will use in to get the GIF setup in our GUI. So we'll import the time, and from takeEnter, we will import all the classes and we will import the field dialog. And from Pygame, we'll import the mixer class to get our buttons functioning to make our MP3 music video, music like MP3 file to start playing, to pause it, and to resume it again. So for that, we'll write the command from Pygame import mixer. It's still downloading. Till then, we'll import the OS also. It will get it downloaded and installed for us. So first we'll create the takeEnter video window. For that, we'll write the simple command root equal to tk and circular brackets and write the command root dot main loop, and if we save it and run it, oh sorry, it was downloading. Just pause the downloading. Okay, we'll see it again. So you can see that the takeEnter window has appeared on the screen. It's the output. It's a simple takeEnter video. Now we will add functions to it, we'll add size to it, we will add background color, and we'll do other functionings to that. So takeEnter provides many methods, and one of them is geometry method, and it is used to set the dimensions of the takeEnter window as you have seen. So we will just position the main window on the user's desktop. We'll use the command root.geometry for that. Set the size as 485 gross that is x only, and for y-axis it would be 700, and now we would get it 290 points shifted from x-axis and 10 points shifted from y-axis, and we have to put them in inverted commas. We will save the file and run it again. You can see that the takeEnter window has changed its geometry, and it has set the x-axis as 485 and y-axis as 700, and when it appeared it was 290. As see what dimension it uses, it was 290 points apart from the x-axis and 10 points apart from y-axis. Yeah, 290 and 10. So now we'll give the title to this window. For that, we'll write the command root.title and just write the title. If you want to give it, you can give it anyway. So we'll name it as Simply Music Player. And now we'll use the configure function. So take enter configure function. It is used on any widget to change settings that you may have applied earlier or haven't applied yet. So for that, we'll write the command root.configure and we'll set the background color. So write background equal to, and in inverted commas, we'll write the hexa code for this color. So we're setting the gray color for our background. We'll save it and run the file so you can see the output. So we have set the Simply Music Player as the root title of our take enter window, and we have configured the background color as gray. So moving on. Now we will use the resizable method. It is used to allow take enter root window to change its size according to the user's need, as well as it will prohibit, it will not allow you to change the size of the window. The window you just saw on the screen, that was a take enter window. So we will use the resizable function and we will prohibit, will not allow anyone to change its dimensions. So for that, we'll write the command root.resizable false, comma, false. So in resizable method, user can pass either positive integer or true to make the window resizable. To make window non-resizable, user can just pass 0 or false. We have passed false, so our window won't be resizable. We'll save this file and run it again. You can see now we can't resize it. So first I will comment this command and save it and run it for you guys. You can see that you can resize it now, but after we write this command, no one is allowed to resize the take enter window. So we'll save this and run it. You can see now no one is allowed to resize this window. You won't get any option. So now moving on, as you have seen the previous dimensions and the demonstration of the Simply Music Player, we'll create as same as that only. So we will place the GIF here, a label here, and place the buttons on that, and beneath that we will just create a label and browse all the files there. So we'll start with the frame. For that, we'll write the command. First, we'll create a variable and name it as lower frame. And a frame is a rectangular region on the screen. It can be used as a foundation class to implement complex widgets. It is used to organize a group of widgets. So we'll be creating a frame and we'll place different buttons on that. That would be the play button, pause button, and the stop button, and the volume, that is just the image. We'll place the volume image there. So lower frame equal to, we'll write frame to get a frame, and inside we'll pass root and get a background color as white. That will write the hexacode hash, and the hexacode for white color is FFF, and that is 6 times. You can go and search on the web about the hexacodes, like which color is associated with which hexacode, or you can just write the simple name of the colors. You can get your background set as well, that also. And here we'll set the width for our frame. So width will set as 485 only. It should cover the whole window in X dimensions. And for height, we'll set it as 180. We'll create the same Simply Music player as I have shown the demonstration earlier. So we have set the height as 180. So now we will use the place method that allows you to explicitly set the position and size of a window or anything. Like we are just creating a frame, so it would use to position and size of the frame. It would be either in absolute terms or relative to another window. So for that, we will write the command. First we will get the frame that is stored in the lower underscore frame variable and use the place function to place it in our tkinter window, and write the dimensions for that. We would start from x equal to 0 and place it at y equal to 400. Now we'll save the file and run it. Okay, we have one tkinter window already opened, so I closed it. You could see that this is the frame. We have set it at x equal to 0 and y equal to 400. So it would measure as y equal to 0 here and y equal to 400 here. So we have placed the frame. Now we will place the buttons on that. And first we will set a logo for Simply Music Player that we have in a folder. So this is the logo for our Simply Music Player. We will set it. For that we'll write the command. First we will create a variable and name it as image icon, and here we will use photo image. So like after writing in this photo image, it would create a photo image object, and you can use it in other widgets that accept an image argument. That is, some buttons, they accept image argument, photo image argument. You can use the images there also, and the image object is returned by the photo image function. It's the easy to display a picture in Python. However, the photo image class only supports the GIF and PGM, PPM formats, which is a concern. JPEG, JPG, and PNG are the formats that are most often used. So now, in the photo image object, we'll just write the location of the file. as we have it in the same folder, so we'll write the name only, that is logo space png, and the extension, that is png only. Now to get it set as icon photo, we'll write the command root dot icon photo, and pass the argument as false, comma, image underscore icon. Now we'll save the file. First we'll close the previous one and run it. You could see that the logo has been placed there. So now moving on, we will create the menu. We will again run the file. So here we will create the menu to browser music. So for that, first we will create a variable menu and create a photo image object and write the file name only, as here we don't have to set the path as all the images are in the same folder only. So for this we will use the menu.png, that is the white image. I will show you what we will get as output. So we have to place this in inverted commas. And now for this we will create a label. So in Tkinter, some widgets can display an image such as label and button. So in Tkinter, in Tkinter, label is a widget that is used to implement display boxes where you can place text or images. So we will create a label here and place the menu.png image on that. So to create it, we'll write the command. We have started with label, and inside we will pass root and the image. We will write the variable name here, that is menu. And now we will place it. We'll position it in our Tkinter window. So for that, write the command place, and inside write x equal to 0 and dimensions are okay. So y would be 580, and we would also set the width and height for that, and the width would be 485, so it could cover the whole. Sorry, I didn't write the width. That would be 485, and now we will set the height. Height will set as 100 only, as it would be in the bottom section. So it won't get much height. So we'll save this and run the file. You can see that we have created a label here also and a label here also, and we have pasted the white image, placed the white image on that label. So this is the label that is of the white color, and now we have placed another image on another label. So I will show you what for what purpose we have done that. So first we will create a button that would be for the browse music. For that we'll write first pass root and then what text we want to show on that button. That would be browse music, and then we will set the width of that button. That would be 59, and then we would set its height and set the height as 1 only. And now you can set font also, like which font you want to get displayed on that button. For that you just have to write font equal to and start the circular brackets, and inside you can write which font you want. I will go with Calibri, and font size would be 12, and I want it bold, so in inverted commas I will write bold, and outside this circular bracket I will set the foreground color, that is the text color only, foreground color, as black. You can write the hexacode or just write the name of the color, and we'll set the background color as white for this button. Use hexacode here, that is 6 times Fs. And now what function does this button do? So it will show us the music that would be stored in our folder. We will browse the folder and it will show us the mp3 files that would be contained in that folder. So in command we will write the name of the function that we will create to get all the mp3 files. So we will just add music only. Now outside this bracket we will place it. It's showing error as we have not defined the add music function. So we'll place it at x equal to 0, y equal to 550. Now add scroll bar so that when we get all our mp3 files we can just browse just by scrolling, so we can get all the mp3 files on that small window we will create now. So we'll set the scroll bar for that. For that write the command scroll bar, and inside get a frame music. So first we'll set another frame and we will get it as gray color only. For that we will write the command frame underscore music. We'll create a frame and inside we'll pass root and set the border equal to 2 and relief equal to rich. So we have set the relief equal to rich. So relief is a style and It's a style of a widget that refers to certain simulated 3D effects, and we are giving the 3D effect to a button, and that effect is ridge. So we will see that, but before that we have to get our add music defined. So no, we won't get the take enter window as we have to define the add music. So we have created the frame, and now we will place this, and after that we will create that music function. For this we will write frame underscore music, that was the variable name, and period place, and now we will position it in a take enter window. So we want it at x equal to 0, y equal to 700, so we would place it at 585, and we would also define its width and height. So width would be 485 and height is 100. So we were creating the scroll bar. So first we'll create the scroll bar and then define the add music function. So now we will set the scroll bar in the frame music variable, as we want the scroll bar in that frame. I will show you in the demo only after I create the add music function. So first we'll create the add music function only. So we will create it here. And name it as add music. And first we want that it should have path, and here we would use file dialog, so it would pop out the dialog box to the directory which we would assign or take it to. Next, right, if our path change directory, pass the path here. Source equal to s dot list of directory path okay. We have problems here, but now we'll resolve them. So first, if the path we have chosen, and here we will change the path, and in this songs variable we'll get the list of all the songs in that directory. And now we will create or run a for loop for song in songs, but all the songs we got. If song ends with mp3, that is .mp3, get playlist dot insert, will pass and the process and pass the song. So we will get this playlist variable working in another function, that would be the play music function. So it should play the music. For that we'll create the function play music, create a variable name, that would be music underscore name, and inside get playlist dot get and make it active. And now we will print music name, and this would be printed in the terminal. First pass active, that is which music is playing. And now we would use the mixer class and music dot load function and pass the playlist. Use the function dot get and get it as active. And now here we will play it. Now we're getting errors for playlist. So first get the playlist variable, that would be having all the songs in that. So for that we'll write a variable playlist, and that would be equal to it would have the list box equal to list box, and inside we'll pass the frame that we have created for music. And set its width, that would be equal to 100. And now we will set the font for that. So you can see all the names of the mp3 files in the same font only, and for that would write Times New Roman and set the font size as 10. And outside this bracket we'll set the background color for the playlist. For that write PG and we'll set it as gray only. So the hexa code for gray is 3 3 3 3 3, and that is 6 times. We'll close the inverted commas and set the foreground color as gray only. Now select background, that would be of the light blue color. Set the cursor as hand to. I will explain you what this means. First we'll set the border equal to 0 only. Y scroll command, that would be equal to light blue. Now we will set the Y scroll command, that would be equal to scroll dot set. So it should be used to scroll. So we have set the cursor equal to hand to. That means that it would convert to hand when we scroll on the list box. That is when we would try to select any of the MP3 player files, it would show us the hand cursor. And the background color is light blue we have set, and scroll command equal to scroll dot set. Okay, now we will configure it. Okay, maybe we have some errors, we will resolve them and we will see the output also just after this. So first we will configure the scroll bar. So that will use the variable only scroll dot config, and inside we will have the command equal to playlist dot y view. So we should have in the y axis only. And now we'll back the scroll bar, place it at right, and fill the y-axis. For that we'll write fill equal to y, and now we will pack the playlist dot pack, place it side equal to right, and it should fill both the sides. It should be filled. So that will write the command, which cannot appear after keyword argument. Okay, we'll get it sorted. Save the file, run it. So you can see that we have the browse music button here, and if we click it, we have the functioning. we will select the folder create mp3 player, and this is the folder that is music, and we'll select it. It has 4 files. I will show you in that also. So this is the folder. It has 4 files. It is displaying us all the 4 files, and you can see that we have the cursor as hand here, that is we have set it as hand 2. So now we will do other functionings, that is place the GIF, run it, and place the buttons. So first we will place the buttons and run it. So for that, after this frame music, we'll start with the buttons. So first we'll create the play button. For that we will create a variable and name it as button play, and we will use a picture for that button. That will create a photo image object and pass the file for it, and we have that file name play1.png. so we'll just write the name of that file in inverted commas. And now we will set the functioning. Set the button, will pass root, and the image is equal to the variable we have set it for, that is button play with is capital for play, and we'll set the background color for the button. That would be white only because we have the white label here, so it would be perfect for that. And now we'll set the border, that would be equal to 0, and okay, we have to place it in inverted commas, else it would be functioning as a comment only. We have set the border, that is equal to 0. Now height, okay, HHT. Oh, so just forgot the spelling of height. Okay, so I have to declare the height first. So we will get these buttons in 60 to 60 dimensions only. We'll set the height as 60 and width also as 60. And now we would set the command for this button. So what functioning should it do? For that, we will write the function name, that is play music, and now we will place this at x equal to 215 and y equal to 487. And we have created the play music function above. You can see that it has the functioning to play the music. We have used the mixer.music.load from the Pygame, and it would get the playlist and the active contents there, and it would play it. So we are done with a play button. We'll save it and run the file. So when taken the window is opened, first we'll close that. Started. So first we'll browse. So this was the folder created music. We'll select this folder. You can see we have these 4 files. We'll click on the one and just click on the play button. Okay, we forgot to add one functioning. So first we will create all these buttons and then add all other functionings. Now we will create the second button, that would be the stop button. For that we will create a variable and name it as button stop, and here also we'll create a photo image object. We'll pass file in inverted commas and we have stop1.png for this. So we'll just write the file name, and in the next line we will define the functioning of this button. So inside button we will pass root and image, that is the variable button stop, and set the background color equal to white only, and that would be in the inverted commas. And now we'll set its border, that would be 0, and height and width would be 60 only. And after that we'll set its command, that would be mixer dot music dot stop. So we are using the mixer class, the music class inside that, and the stop function. And now we'll place this in a Tkinter window. For that we'll write the dimensions for that: x equal to 130 and y equal to 487. So we have created the stop button. We will save this and run the file. You can see that the stop button is also displaying on a Tkinter window. And now we will make a third button, that would be the pause button. For that we'll use the pose1.png. This is the image. So for that you can just copy these things, place it here. So button pose equal to photo image, and we will use the image pose1.png, and get it big only as we have set all others as big. So button pose, background color white, border 0, height 60, width 60, command would be mixer.music.pose. And we'll place it at 300,487. We'll save this file and run it. You can see that we have the pause button displayed here. Now we will get the volume button, not the volume button, just the image. So this is the image, volume.png. We will get it there. So for that we will create a variable volume1 and create a photo image object and set the file location, and the location is it's already placed in the same folder, so we'll just write the name of the file, that is volume.png, and that would be in the inverted commas. And now we will place this at x equal to 20 and y equal to 487. Now I'll save this and run the file. So we are having some errors. Okay, we can't directly use the place here. So first we'll create another variable and create a label for this image. So for that we will use panel and equal to well, side will pass root comma that is equal to volume 1 and now we will use the place and place it at x equal to, that was at 300 and y would be 700, that would be 487. So now we'll save this file and run it. You can see, okay, we have made a mistake here. So it should be here, so x would be less, it would be around 20 and y would be same for that only. So we'll change that. Save this and run the file again. Yeah, you can see that we have the volume image, we have the play button, the pause button and the stop button. Now we'll get the GIF working for us. And now we will get our GIF working, but before that we will make the mixer initialize so that our buttons, they should function, that is play, pause and stop. So we've imported the mixer class, so we will initialize it. We'll save this and run the file. Now you can browse the music, click on the any mp3 file and click on the play button. You can hear that the music is playing. So I will pause it. And now we will start with the functioning of our GIF. So we have to cut the previous part, and now start with frame count. So the frame count of our GIF is 30 and we will store it in a variable. And now we will create another variable as frames, and inside we'll start with square brackets and create a photo image object. And inside we'll pass the file, the GIF file. The name of the file is a1.gif and here we have to specify the format of the file. For that we'll write format equal to in commas gif one index, and we'll set the index and I. So we would be using the list comprehension here. Now we will run the loop. So for that we'll write for I in and use the range of the frame count. So what we will do is, the GIF has so many images in that, so we have to run a loop so it would again repeat itself, as the frame count would be equal to the count, as the images would be repeated in a loop. We will set the count equal to 0 and repeat it again. So for that, now we'll create a function and name it as update, and inside we'll pass a variable id. Create a variable with name frame, and inside we will pass ind variable frames, and as this image would be displayed, we will increment the ind variable, and if ind is equal to frame count, that is, if it has displayed all the images in the GIF, we will set it at 0 and run it again, and we'll set the GIF and label. So we will configure it, and we have to define the label also. So for that we'll write label equal to label, and inside we'll pass the root, and now we'll configure it and pass image equal to what frame we have currently, like and now we'll use the after function and pass 40 milliseconds so that the animation would start again, and pass the update function the current ind, and now we will place the label and x equal to 0 and y equal to 0, and again we will run the after function and pass 0 milliseconds, and the update function 0 frames, Okay. Define this if statement only. Okay, first we have to place the label statement above now. Yeah. Now we are done with our GIF. Save this and run the file. So we are getting an error here. Okay, so separated. Okay, then save this file and run it again. Okay, encode displayed. So we have this label above. Just browse the files, select the folder and click on any file and just click on the play button. You can see that our mp3 player is working. We'll just set the GUI again. You pause it, or you could stop it. So we will get this downwards. For the starting of the buttons. Now we'll save the file and click on run button. You can see that the GIF has taken the whole frame, and now we'll browse the files. We've selected the folder, and our if statement will find the mp3 files. You click on the file, just click on the play button. You can see that our Simply Music player is working fine. So I will share the code link with you in the description.
Hello everyone, I am Mayank and welcome to Simplilearn. Today we will take you through the hands-on lab demo of how you can create a speech-to-text or speech recognition system using Python. Before we start, I hope this screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. I'm repeating again, before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. Yeah. Until then, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. I'm repeating again, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from Simplilearn. Great. I think we can get started. So in today's session, we will go through what is a speech recognition system. Moving forward, we will see how a speech recognition system works. After that, we will create a speech recognition system using Python. We will perform different functions and create speech recognition system using different Python libraries. Before we move on to the programming part, let's discuss what is a speech recognition system first and proceed further for the same. What is a speech recognition system? A program capacity to convert spoken language into written language is known as a speech recognition system, also known as automatic speech recognition. Computer voice recognition or speech to text, despite being sometimes confused with voice recognition. Speech recognition focus on converting speech from a verbal to a text format, whereas voice recognition only aims to distinguish the voice of a certain person. Voice and speech recognition are two distinct technologies, and they shouldn't be confused. To recognize word in spoken language, speech recognition is used. Voice recognition uses biometrical technologies to recognize a specific person by their voice. So, after knowing what is speech recognition system, let's move forward and see how does speech recognition system work. Speech recognition in Python works with algorithms that perform linguistic and acoustic modeling. Acoustic modeling is used to recognize phonetics in our speech to get the more significant part of speech, as words and sentences. Speech recognition starts by taking the sound energy produced by the person speaking and converting it into the electrical energy with the help of microphone. It then converts the electrical energy from analog to digital and finally to the text. It breaks the audio data down into sounds and it analyzes the sound using algorithm to find the most probable word that fits that audio. All of this is done using natural language processing (NLP) and neural networks. Hidden Markov models can be used to find temporal patterns in speech and improve accuracy. So, here is one question for you guys. I will give you 1 minute for this. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. I'm repeating again. So, here is one question for you guys. I will give you exactly 1 minute for this. You can comment or you can give answer in the chat section so I can see if the answers given by you are right or wrong. So the question is, which of the following is the correct extension for the Python file? I'm repeating again, which of the following is the correct extension of the Python file? Option A .python, option B .pl, option C .py and option D .p. So let us know your answer in the comment section below. So I'm starting a timer of 1 minute. Just type your answer in the comment section or in the chat section. Do let me know your answers, please. I kindly ask that everyone take part in this to make this live session exciting. So I'm starting the timer. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. So the question is, which of the following is the correct extension of the Python file? 37 seconds remaining. Option A .python, option B .pl, option C .py, option D .p. Let us know your answer in the comment section below. I kindly ask that everyone take part in this to make the live session exciting. You have 15 seconds remaining. 10 seconds more. Which of the following is the correct extension of the Python file? 3, 2, 1. After that allotted time has passed, those who provided the correct response will receive a response and those who provided the incorrect response will receive one. Okay. So now let's move to our programming part to create a speech recognition system using Python. So first we will open a command prompt to write a command to open Jupyter Notebook. So here we will write Jupyter Notebook. Press enter. So this is the landing page of Jupyter Notebook, and here you can select new Python file. So this is how the Jupyter Notebook UI looks like. So at first we will import some major libraries of Python, which will help us in creating a speech recognition system. So here we will write, first let me rename this speech recog. So first I will import speech underscore recognition. And second, import pyttsx3. Press enter. So the incredibly extension, I repeat, the incredibly extensible speech recognition library serves as a wrapper for a number of well-known speech APIs. The speech recognition library includes default API key for one of these, the Google Web Speech API, hard-coded, that implies that you can start moving without needing to register for a service. And Python project would benefit greatly from using the speech recognition package due to its versatility and usability. And then pyttsx3, a Python text-to-speech conversion library, is called pyttsx3. It is compatible with Python 2 and Python 3 and work offline, unlike competing libraries. To obtain a reference to a pyttsx3 engine instance, an application calls the pyttsx3 init. It is very user-friendly program that turns typed text into speech. So moving forward, let's write code for actual speech recognition system. So here I will write sr equals to speech underscore recognition dot recognizer. R must be capital here. Yeah. Here I will write with speech underscore recognition dot microphone as source 2, then colon. Yeah, here I will write print will write here okay, silence please. Okay. Then I will write here sr dot adjust underscore for underscore ambient underscore noise, then source 2 comma duration equals to 2. Okay, then enter. Then I will print something like speak now please, something like that. Then I will write here audio 2 equals to sr dot listen source 2. And here I will write for text equals to sr dot recognize, okay, underscore Google audio 2. Then here I have to print in small letters in lowercase. So I will write here text equals to text dot lower. This. Then here I will write print did you say plus text. Yeah. everything look great. So a recognizer is a machine ability to listen to spoken words and identify them. You can then use a speech recognition in Python to convert the spoken words into text, make a query or give a reply. You can even program some devices to respond to these spoken words. Like every time the recognize speech from mic function is invoked, the recognizer is calibrated for changing noise condition using the adjust for ambient noise. This one for ambient noise. The backlog parameter of the listen function allow a quiz size to be specified. It will listen to what we are speaking or saying. This recognize Google, a function on the recognizer class, which you have now developed, will be used to query the Google Web Speech API and convert spoken words into text. Recognize Google needs the argument audio data in order to function properly, otherwise it will fail. Python built-in function lower is mostly used to handle strings. The lower method converts each capital character in the provided string to lowercase before returning the lowercase string. It accepts no arguments. It returns to the original text if the supplied string has no capital letters. Now let's check whether it's working or not. So I will run it. Yeah, run all. Hello, how are you doing? Yeah, you can see hello, how are you doing printed. So let me try another one. Subscribe to Simplilearn YouTube channel and press that bell icon to never miss any update from Simplilearn. So here you can see subscribe to Simplilearn YouTube channel and press that bell icon to never miss any update from Simplilearn is printed. So speech to text is working fine. So I hope you guys understand till here. If you have any questions or any queries regarding any code or you have any questions, just put as in comments. Our team will shortly provide you with the correct solution. Now moving forward, what? If we want that system will write what we are saying and speak that too. This will be printed and now moving forward, what if we want that system will write what we are saying and speak that too. So for that we will write a small line of code. So first we will create one here, like we will insert cell below. We will write a function here. So def speak now command colon then voice equals to pyttsx3 dot init. Okay, then voice dot say command, then voice dot run and wait. Yeah. So what we will do here, we will write like speak now, then so this voice is nothing, just a variable to text to speech, and init pyttx3 engine has started. Obtains a pointer to an instance of an engine that will utilize the specified driver. If another engine instance is already using the given driver, the other engine instance is returned. If not, a new engine is built. A speak now is a function in which using get function I am getting the values of the text. This one I will get. Now let's run this sort of code and let's see if it is working or not. So I will run. Hello, how are you all? Speak now is not defined. Okay. Speak now. Okay, n is small. Okay, my bad. Run this again. Hello, how are you all?
Hello, how are you all?
I hope you can hear properly. So let me run this again for another demo example. Subscribe to Simplilearn YouTube channel and press that bell icon to never miss any update from Simplilearn.
Subscribe to Simple and YouTube channel and press the bell icon to never miss any updates from Simplilearn.
Yeah, so I hope you guys understand till here. If you have any question or any queries regarding any code, or you have any question related to Python, just put as in comments. Our team will shortly provide you with the correct solution. Okay. Okay, moving forward. So at last, let's create a speech recognition system from which we can open our websites and all, like YouTube, like Facebook, like Simplilearn, anything. So we will open new file for this. I will create the separate one. Here I will write speech to websites. Okay, speech to web. So here I will import speech underscore recognition, then import pyttsx3, then one major library, import web browser. Okay, then I will run it. Yeah, I hope you already know these first two libraries. So this is third library is used for web browser is the file source code. The web browser modules offers a high level user interface that enables user to view web based content. In most cases, executing the open function from this module will result in the desired outcome. So moving forward, let me write code for it. So I will write code first, then I will explain you line wise. So I will write if underscore underscore name, then again two underscore equals to underscore main, then again underscore, then colon. Yeah. Then you have to give a path like for your browser. You can use Edge, you can use Google Chrome, anything, Firefox, anything. So here I will give path equals to, then C drive. I have my path already, program files, and x86 Microsoft, and Edge, then then application, then msh .exe. You have to write at the end this percentage %s. Don't forget to write this. Okay, so path is set. So let me create sr equals to speech recognition dot recognizer, same as previous one. And I will write with speech underscore recognition dot microphone as source, then sr dot adjust for ambient noise, then source. Yeah, everything seems good. Let me write print what we have wrote there, like speak now please. So here I will write please say something to open. Okay. I will write audio equals to sr.listen that source, and I will print like what you said. So it will hearing, and I will here write try and accept, then try. So here I will write destination equals to sr dot recognize underscore Google, then audio. Print here you asked to open right here plus destination. Okay. So then web browser dot get that path, then open that destination. Okay. So here I will write that exception exception as you can write e, then print if there will be error str e. Okay. So a recognizer is a machine ability to listen to spoken words and identify them. You can use speech recognition in Python to convert the spoken word into text. You can even program some devices to respond to these spoken words. Every time the recognize speech from mic function is invoked, the recognizer is calibrated for changing noise condition using the adjust ambient noise method. A socket is already to receive connection after calling the listen function. Prior to performing the accept method on the server socket, the listen method should be called. The backlog parameter of the listen function allow a queue size to be specified. It will listen to what we are speaking or saying. The recognize Google function on the recognizer class, which you have now developed, will be used to query the Google Web Speech API and will convert spoken words into text. Recognize Google needs the argument audio data in order to function properly, otherwise it will fail. Okay. So let's try this. It's working or not. Let me run this. Okay, invalid syntax. Perhaps you forgot a comma. Okay, let me see that print error. I think it should be here. Okay, let me check this. Let me run this again. Valid syntax. Perhaps you forgot a comma. Okay. Try to run this again. 2. Okay. Let me remove this. I guess it will work fine. Still didn't put. Okay. Okay, no issues. So here I will write again except exception E int errors tr. Okay, I forgot to write plus. Okay, okay. E. Yeah, now it will work fine. www.youtube.com. So here you can see YouTube is open. Yeah. So we will try this one more time. www.facebook.com. So here you can see Facebook is open, www.facebook.com. One more last time. www.simplilearn.com. You can check our amazing courses on different technologies here on Simplilearn website, simplilearn.com. So I hope you guys understand till here. If you have any query, any question of regarding any code, so just put as in comments. Our team will shortly provide you with the correct solution. Okay, I'm repeating again. I hope you guys understand till here. If you have any questions or any queries regarding any code or related to any Python question, so just put as in comments. Our team will shortly provide you with the correct solution. I hope you guys must understand how to create your own speech recognition system using Python. If you have any queries, you can ask in the comment section below. Our team will shortly respond you as soon as possible. And if you want this full code, so just comment for the same. Thank you so much for being here. If you enjoyed this video, please do subscribe to our YouTube channel and give a like to this video. Today, we will take you through the hands-on lab demo of how you can do the sentimental analysis of Amazon customer reviews. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. Let's wait for some more minutes to let other people join. Let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek on a continuous hunt for the latest technological trends, then consider subscribing to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great, I think we can get started. So in today's session, we will go through the what is sentimental analysis. After that, we will see types of sentimental analysis. We will see some application of sentiment analysis, and at the end, we will see hands-on lab demo like how to implement sentiment analysis using Python in detail. We already have Amazon customer dataset with us. We will perform different function and analyze data for sentiment analysis using Python. You can download dataset from the description box below. So before we move on the programming part, let's discuss what is sentiment analysis actually is and proceed further for the same. Sentiment analysis, sometimes known as opinion mining, is a technique used in natural language processing (NLP) to determine the emotional undertone of a document. This is a common method used by organizations to identify and group ideas regarding a certain good, service, or concept. Text is mined for sentiment and subjective information using data mining, machine learning, and artificial intelligence. Tools for sentiment analysis assist businesses in extracting information from unstructured, unorganized language found in online sources like emails, blog posts, support tickets, web chats, forums, and comments. Algorithms use rule based, automatic, or hybrid technology to replace manual data processing. While automatic systems use machine learning to learn from their data, rule based systems execute sentiment analysis using predetermined. Lexicon based rules combining the two methods result in hybrid sentiment analysis. Sentiment analysis or opinion mining can extract the subject, opinion holder, and polarity or the degree of positivity and negativity from the text and identify sentiment. Additionally, other scopes including document, paragraph, sentence, and sub-sentence level can be used for sentiment analysis. After seeing what is sentiment analysis, let's discuss some types of sentiment analysis. So the first one is fine-grained sentiment analysis. By segmenting sentiment, each phrase or clause in a sentence is broken down and examined in relationship to the others. Simply said, you can tell who review a product and what topics a person specifically discuss in their feedback. And the second one is emotion detection. Instead of identifying positivity and negativity, emotion detection recognizes particular emotions. Example could include shock, rage, grief, frustration, and happiness. And the third one is intent based analysis. In addition to identify opinions in a text, the intent based analysis also identifies behaviors. For instance, a frustrated online comment about changing a battery can motivate customer care to get in touch to address that particular problem. And the last one is aspect based analysis. Collects the precise component that is being mentioned either favorably or unfavorably. For instance, a client may write in a product review that the battery life is too short. The system will then respond that the battery life is the main complaint and not the product as a whole. So after seeing types of sentiment analysis, let's see some application of sentiment analysis. Organization can employ sentiment analysis technologies for a number of purposes such as determining brand popularity, reputation, and awareness at a particular period or over time. Customer service requests into categories. And the next one is monitoring consumer response to new improvements or products. And the fourth one is identifying the demographics or target market. And the fifth one is determining the effectiveness of a marketing effort. So here is one question for you guys. I will give you 1 minute for this. You can comment or you can give answers in chat section, so I can see if the answers given by you are right or wrong. So the question is text analytics also refers to as text mining? I'm repeating again. Is text analytics also refers to as text mining? The options are true or false. So let us know your answer in comment section below or in chat section. So I'm starting timer of 1 minute. Just type your answer in comment section or in chat section. Do let me know your answers. So I'm starting timer of 1 minute. I kindly ask that everyone take part in this to make this live session exciting. So the question is text analytics also refers to as text mining? 35 seconds are left. Do let me know your answers. I kindly ask that everyone take part in this to make the live session exciting. 20 seconds left. You can comment or you can give your answer in chat section so I can see if the answers given by you are right or wrong. So time up, guys. So after the allotted time has passed, those who provided the correct response will receive a response, and those who provided the incorrect response will receive one. Okay. Now let's move to a programming part to perform sentiment analysis using Amazon customer dataset. So first we will open command prompt to write command to open Jupyter notebook. So here we will write Jupyter notebook, press enter. Okay, it's Jupyter notebook. So this is the landing page of Jupyter notebook, and here you can select new Python file. It's loading. So this is how the Jupyter UI looks like. So at first we will import some bunch of major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. So first I will write NumPy, import NumPy as NP. NumPy is a Python library used for working with arrays. It also has functions for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So the next one is Pandas. I will write here import Pandas as PD. So Pandas is a software library written for a Python programming language for data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical tables and time series. After that, we will import NLTK. So the Natural Language Toolkit NLTK is a Python programming environment for creating application for statistical natural language processing NLP for parsing, classification, stemming, tagging and semantic reasoning. It includes text processing libraries. So after that we will import from NLTK dot sentiment dot Vader import sentiment density analyzer. Okay, there is no colon. Yeah. So the lexicon and rule-based sentiment analysis tool Vader. Vader means valence aware dictionary and essential reasoning. Is a customized precisely to sentiments expressed on social media. Vader makes use of variety of a sentiment lexicon is a collection of lexical elements such as words that are often classified as either positive or negative depending on their semantic orientation. Vader not only informs us of the positivity and negativity scores but also of the sentimentality of each score. So the next one is import RE. Python RE module fully supports regular expression similar to those in Perl. If a regular expression, compilation or use error occurs, the RE modules raises the expression RE. Two key functions that are used to manage regular expression will be covered. So RE means regular expressions. So the next one is from xblob import text blob. Okay. So a Python 2 or 3 package called text blob is used to process textual data. It offers a straightforward API to explore typical natural language processing (NLP) tasks like part of speech tagging, noun phrase extraction, sentiment analysis, classification, translation, and more. So the next one is import words from word cloud. A word cloud, commonly refers to as a tag cloud, is an image of words. Popular words and phrases are highlighted using cloud creators depending on their frequency and importance. They give you immediate, straightforward visual insights that can inspire more through analysis. And the next one is import Seaborn as SNS. Yeah. So, like an open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization, where data frames and the pandas library Seaborn function with ease. So the next one is import matplotlib dot pyplot as plt. Okay, yeah, seems good. For Python and its numerical expression NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for MATLAB. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. And the next one is import cufflinks cufflinks as CF. Perfect. Another Python module called cufflink links Plotly with pandas so that charts can be easily created on data frames. In essence, it functions like a plugin. So next in line, matplotlib. Matplotlib. So you can enable inline plotting by using the magic function percentage matplotlib inline, which causes the plots and graphs to appear below the cell where your plotting commands are entered. Similar to a Jupyter notebook, it offers backend interactivity in front ends. So next we will import what you can like. We can import, okay, from plotly dot offline import init underscore notebook underscore mode comma plot. Okay. Init underscore notebook mode true. Okay, it's true. Yeah. Cf dot go underscore offline. So yeah, in order to display the plot inside the notebook, you need to initiate plotly notebook mode as follows, like this. Keep rest of the script as it is like it and run the notebook cell by pressing, you can shift plus enter. Graph will be displayed offline inside the notebook. So basically it is used for the offline graphing, you can say. Okay. So next we will import from plotly dot subplots. Subplots are important. import make underscore subplot. Okay, yeah. The non-leaf nodes in this figure schema are represented by a hierarchy of Python classes that was automatically constructed and is found in the plotly.graph objects, which is normally imported as Go. These class instances are referred to as graph object, the plotly defined fundamental classes. Okay. So here we will import some like warnings, you can say, like to get not error. So we will import, let me give a line space, import warnings, yeah, warnings dot filter warning ignore warnings dot warn, and this like will not show. And let me add something, pd dot set option display dot max underscore columns. Okay, import words from word cloud. Okay, there is an error. Let me check. What's the error? Okay. Import this word cloud from word cloud. It's capital, and W is also capital. Here W will be capital. Let it put small only. From word cloud. Okay, my bad. Here word from word cloud import word cloud. Okay. Yeah, seems good. So where were we? Yeah, in warnings. Despite the notification, the software continues to execute. To display warning messages, utilize the warn found in the warning module. The Python built-in class expression is a subclass of the warning module, which is used to display warning messages, import warnings. Okay. For seeing full data, every single columns like, okay, there is error, cborn. No module has cborn. So S will be small. Got it? Okay, inline is only like something like that. Inline. Okay, any errors now? I guess no error. Okay. Yeah, for seeing full data like every single columns of PD. So here we are using this pd.set option. So we can use for it. So moving forward, let's import dataset. So for importing dataset, we will write here like df equals to pd dot read csv. Okay. Here dataset name. Yeah. So you can download dataset from the description box below. so no worries for that. So let me run this. Okay, so like here is PD is for pandas library, read is used for reading the dataset from the machine, and CSV is used for the type of file which you want to read. So let's see our data. So here I will write df dot head. Yeah. So if you want to see top 5 rows of your data set, you can use head. And if you want to see 5 rows of your data set, you can use tail instead of head, this one. Okay, so this is our data set with only 5 rows. If you want to see full data set, you can like starting from 0 and ending at 4914 rows. Okay, 49115 rows and 12 columns. Right. So let me give something like this for the better visual. Yeah. Okay. So moving ahead, let's sort this Wilson bound column to ascending order for better analysis. So I am talking about this Wilson lower bound column, this one. For it's not 000 like in all the rows. So let me show you. So here you have to write like df equals to df dot sort values Wilson, spelling should be correct, lower bound. I will make it to ascending order, descending order. So df dot drop named. Okay. Unnamed colon 0. Okay, in place equals to true, comma axis equals to 1. Okay, so let's see our data. So here you can see the data is sorted in as ascending order. Okay, so the provided row or column is eliminated via the drop function. The drop method eliminates the specified column when the column axis is specified. The drop method eliminates the designated row when the row axis is supplied. Okay, so I hope you guys understand till here. If you have any queries or any queries regarding any code, or there is something question till here, just put as in comments. Our team will shortly provide you the correct solution. Okay. So moving forward, let's make a function for missing values. So, okay. So I will write here like df missing values analysis. Okay, it's def. For function we use def. Yeah, def columns equals to col for columns for col in df dot columns if df column is null dot sum is greater than 0. underscore miss equals to df underscore columns underscore is null dot sum dot sort underscore values like in ascending ascending equals to true. Okay. Like sum be like this and this. That's fine, I guess. Yeah. So here I will write ratio underscore equals to df na underscore columns underscore dot is null. Same thing, that sum divided by f dot shape level 100 dot sort values sending equals to true. Fine. Okay. Sum is okay, and the df part that sort value is equals to sending equals to true. Fine. So here we will write missing underscore df equals to pd dot concat p dot round ratio underscore comma 2. Yeah, perfect. Where axis will be 1. Okay. Is equals to, I will give like total, where I will write missing values, okay, comma ratio thing underscore df equals to pd dot data frame score df. Okay, so let me return thing df. Let me create one more function for like check data frame. So df check underscore data frame. Okay, it equals to 5 comma tail equals to 5. So here I will write print shape. Okay, dot center 2 comma Again for rows, print rows, curly braces, okay, dot format dot format yeah, dot shape 0. So for columns, print dot shape print types like of types of data dot center, same as like that, 82 comma int df dot d types center. Just printing this is like, you will see, don't worry, just stay with me, you will see the beautiful result. Okay, print values, print missing values, analysis, analysis like df. Okay, then again duplicated values, like there are many, how many duplicated values are there, so dot same for the center 3 comma again this one print f dot duplicated don't worry, I will explain you like line by line. Just stay with me, let me write the whole code. First print tiles, like I'm printing multiple of things, so just be with me. Dot enter 82 comma ef dot one tile 0.05 comma 1. Okay, check data frame, I'm hoping like there will be no error. Yeah, So you can see now like multiple information regarding dataset is printed. So this shape is for like how many rows and columns present in the dataset. Like in types, you can say like every column type like object, int64, float64 and many more are like present. So like you can see review text is like object and day difference is int64 and Wilson lower bound is float64. Okay, so total missing values. So total missing values are like one from here and one from here. Like one in from reviewer name and other is from reviewer text. And like there is no duplicated values in our dataset. And here you can see. So like after that quantiles. A quantile defines a particular part of the dataset. That is, a quantile determines how many values in the distribution are above or below a certain limit. Special quantiles are the like quartile quarter, and you can say quintile, that the fifth one, and the percentile which is from 100th. Okay, so quantile is for like quarter, or the you can say the fifth one. So why I wrote this 83, 82 and this for this purpose, for making this something look cool. That is why. Okay, and yeah. So moving forward, let's see unique values and in each column. Okay, so I will write def check class data frame unique f equals to pd dot data frame variable data frame dot columns comma classes colon data frame I will write like n unique UUE or I in data frame dot columns like n unique q or df equals to dot sort values classes comma ascending equals to false. Okay, n unique underscore df equals to n unique ef dot reset index drop equals to true. Return n unique QUE n unique underscore df check underscore class which one df. So let me run this first. Yeah, it's running, you can see here. Okay, there is an error, classes. Okay, check class TF. It's saying that this is okay. C is capital, C is small. Let me run now. Yeah. So here you can see the every column having unique values are sorted in descending order. Like review tags have like more unique values. So it come first, and then reviewer name, reviewer time, day difference, Wilson lower bound, score average, then goes to overall. Okay. Moving forward, let's do some categorical variable analysis for overall. Yes, so this will be like amazing. Something amazing is going to be happen. So constants equals to, so I'm giving here like some color values. So B34 D22 EB00C. Okay, so you can change, you can like write whatever you want color. Hashtag, oh I didn't write hashtag here. Hashtag 3, come on, 1 F C. Hashtag 0C92 EB. EB0 C and then D, you like 5, right? Okay, so DEF, let's make function. Okay, small DEF categorical variable summary. Okay, DF comma column. Okay, categorical variable summary. Yeah, perfect. So let's make some figures. So make subplots, plots, rows equals to 1 comma calls equals to 2. Let me write from here like subplot titles equals to count plot like 1 for percentage. Okay. So specs equals to a like type colon y. Okay, comma same type colon here domain. figure dot add and then trace go dot bar, like one bar and one that pie chart. Okay, y equals to df columns, column name, value, values dot to list. For x, you can like string. Yeah, str I for I in, yeah, column name dot value dot counts index. Next equals to df column name dot value counts and then bracket dot values dot to list. Okay, so for text font, the size should be 14 is enough, I guess. To column underscore name X position. So I'm doing for like making chart. So stay with me to see that amazing chart. Okay. So show legend. To dict color equals to constants. So these are the like colors. So I'm giving here value like variable name constants comma line equals to line. Hashtag db e6ec comma to 1. Okay, small. Okay, let me just like go over through everything is correct or not for the column name value counts index. Yeah, it's fine. Text equals to df column name dot value counts dot values to list. Okay, text font equals to text size, then okay, 14 size is enough. Name equals to column name, and text position equals to auto, and show legend false, and mark dict like color equals to constant. Okay, fine, line equals to color, and this, yeah, this. Okay, cool. Row equals to 1 comma column equals to 1. Seems good. Like for pie chart, we will make figure dot add. So this is done for the line chart, not line chart, that bar chart, and this I'm doing for the pie chart. Okay, trace go dot pie f columns, column name, value, count, is values equals to df, again that column name, dot value, count, counts, and dot values text font equals to text size. I will prefer 18 is enough. Exposition equals to, like, auto is fine. So legend equals to no need of legend, false. Name equals to column name, value, column name, equals to like text, then colors equals to constants, equals to 1 column equals to 2, like in second. Okay, you will see and you will get to know, don't worry. So figure dot update layout middle equals to text column 0.9 0.5 comma x or should be on center. And Y anchor be on top. Let equals to shortly. Okay. I plot figure. Let me run this. Okay, like okay, call equals to 2. Now let's see the chart of like column overall one. So we will write here categorical. Okay, variable summary, and then data frame name df comma overall. Okay, let's run this. Okay, it's loading here. It's loading. Yeah, you can see this is our bar plot and this is our pie chart. So like this is overall from overall you can say that column. So like percentage bar and that bar plot. So this is how our like pie chart and bar chart looks like. I hope you guys understand till here. If you have any questions or any query regarding any code, okay, like any code, any sort of code, so just put as in comments. Our team will shortly provide you the correct solution. So moving forward, our goal is to rank the comments by the sentiment analysis, so we don't get hung up on the other details. I have sorted this data set according to certain rules before. So moving forward, we want to clean our data. So let's see the sample data for cleaning. So df dot review text, okay, dot head. Let me run this. So this is our sample data looks like. So let's see like data, full data for this. Okay, let me see for this, I guess. Okay. For like any particular row, you can say I can take. Okay. So I will write review underscore example equals to df dot review text. I will take a random 2031, I guess. Okay, so review underscore example. So this is like at 2031 there is one review text. Okay, so in that the whole data is here. Like so my lovely wife bought me a Samsung Galaxy Tab for father, this, like to find the exact model number. This is a long, comment. I got the this. It works like a charm. Okay. So after seeing this data, what we're gonna do is like we will clean it from punctuation and numbers using regex. Regex what? Regular expression. Okay. So here I will write review underscore example. Okay. Equals to re dot sub, and what I will do is, okay, I will explain, don't worry. Small a to capital A to Z, okay, comma, then space, comma, review underscore example, add, sorry, yeah, review example. So here we used RE for regular expression, okay, and so all the punctuation and numbers are removed from particular data. So let me check first. Okay, this A to Z, then A to Z. Okay, fine. So like all the punctuation and numbers are removed from particular data. I will now convert the text to all lowercase. Our machine learning algorithm recognize words that start with the capital letters as a different word, and we will convert them to lowercase. So thus our machine learning algorithm will not perceive words that start with a capital letter as a different word. So what I will do is, here I will write review sample equals to review again example dot lower. I will split okay, view example. So here you can see we have converted all the words in the lowercase letter by using lower function. And why they are coming in new lines? Because we are splitting them using split function. Okay, if you see only did lowercase for single row like we did for the like 20, I guess 2031. Okay, yeah. So let's make all rows same in lowercase. So I will write here rt equals to lambda x whole str dr x for df view text is capital text df view text text okay equals to df view text. Yeah, dot lower df dot head. See, all the data is in like lowercase. So I printed just top 10 rows, and like in reviews text column all the are in the lowercase now. So I hope you guys understand till here. If you have any question or any query regarding any code or question till here, like any code, just put as in comments. Our team will shortly provide you the correct solution. And if you need this full code, you can comment down below. Okay, so now the time is come to do sentiment analysis because all the data is sorted. So what will I write here? Let me do it little bit up. Yeah. So I will write from Vader sentiment dot Vader sentiment import sentiment intensity analyzer. Okay. F polarity subjectivity subjectivity equals to df review text dot apply lambda text pd dot series. Okay, here you write text blob, then again text dot like sentiment let me run for loop for index comma row in df review text dot items for you sentiment intensity analyzer dot polarity scores row negative score for neutral I will write score. Okay, for positive if this is something crazy, if negative is greater than positive, then df dot location index comma sentiment equals to negative. Negative. Okay, then else if positive is greater than negative, then in this case df dot log index comma sentiment equals to positive p capital. Else df dot loc index sentiment equals to neutral. Okay, so like this is for sentiment analysis, and text blob this thing like text blob, this blob. Okay, it's blob. A text blob will return polarity and subjectivity. Polarity indicates your mood, that is whether it is positive or negative or neutral. It returns a value between 0 and 1. The closer to 1, the more positive, and the closer to 0 is more negative. Okay, let me run this. It will take a little bit time because this sentiment. Okay, it is getting error. Like module panda has no attribute series. Okay, which one? Text box. Text. Yeah, sentiment. Okay, here. What is the thing? S is capital. Let me run now. It is executing. Like wait for a while. Wait. So it will take time to run because of this sentiment intensity analyzer. It take times. Again, sentiment intensity analyzer. Okay, spelling mistake again. Why index? Index is not defined. Okay, sorry again. Index. It will run, I guess, because everything seems good. Negative, positive, and this else. Still loading, so I have to wait like for like 2 minutes more, I guess. Still loading, guys. Yeah, it take time. Sentiment intensity analyzer. So let me tell you again, sentiment analysis, like this text blob will return polarity and subjectivity. So polarity indicates your mood, that is whether it is positive, it is negative, or it will be neutral. It returns a value between 0 and 1. The closer to 1, the more positive. The closer to 0, more negative. Okay. I guess it's still running. So it will take time. So let me write code for that. 20 interpretation. I repeat. Moving forward, let's identify the 20 interpretation. Now we can include the positive, negative, and neutral status of the comment. Okay. Then df okay, sentiment equals to positive thought lose Wilson lower sending equals to false. Okay. Dot head, it's 5. If I will run, it may give errors to me because it's still running here, it's still loading. So let let me write code for that unbalanced data problem. So like we will categorize that data into positive, negative, and neutral. Okay, so categorical variable summary df element. Yeah, it came like this because of this. Wait, I will tell you. Yeah. So here you can see the pie chart distributed in negative, positive, and neutral emotions. Okay. Or you can say ratings. And here you can see the bar chart also. So, and you can see the percentage distributed in each, like in positive, negative, and neutral one. So, I hope you guys must understood the concept of sentiment analysis, how we can implement it using Python. If you have any queries, you can ask in the comment section below. Our team will respond you as soon as possible. If you want this full code, just comment for the same. Thank you so much for being here. If you enjoyed this live session, please do subscribe to our YouTube channel and give a like to this video. Thank you and keep learning.
Hi everyone, I'm Abhisar Ahuja and welcome to the Simplilearn YouTube channel. In this session, we will create an OTP verification GUI using Python. But before we begin, if you love watching tech videos, subscribe to our channel, like the tutorial and hit the bell icon to never miss an update. And before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. And if there is any issue, do let us know in the chat section. And let us have a simple question to brush up on our knowledge. And please answer in the comment section below and we will update the correct answer in the pinned comment. And your question is, how is a code block indicated in Python? And your options are brackets, indentation, key, or none of these. You can pause the video, give it a thought, and answer in the comment section. Moving on, first we will see what's a project and how it looks like. So we will save it and run the program. You can see that the Tinker window has appeared, and this is our project, and this is what we're gonna make in this video. So using Twilio, I have received the OTP on my mobile phone, and that is 4601. And if I submit it, I can see the show info window that says that the verification is successful. And we have one more window for you guys. If you want, you can also make it. We'll also discuss this in this video. So you can see this is the first window we will create, and after we click on the generate OTP button, it will redirect to the second window, that is verify OTP, and there you could just type in the OTP you get on your mobile phone, and the OTP I got is 6709, and I will just click on the submit button. It will show that the verification is successful. There's a recent OTP button and there's a timer, as the Twilio tokens, they are default available for 10 minutes only. So I have set up a timer for 10 minutes. If you want, you can also make the timer, else you could just go with the verify OTP GUI. And the resend button, it will just make the Twilio send the OTP again to our mobile phones if there is any difficulty in reaching the OTP to us. So moving on, now we will start with our project. That is, first we will create a folder and name it as OTP verification. And inside we will open the command prompt, and now we'll open the editor. I would be using the Visual Studio Code. You could choose any editor as you like, or you have the hands on any editor. So for that, I will write the command code space period and press enter. So here we will create the name of the file as program2.py, and now we should install and import the modules. For tkinter, we don't have to install it. Like, tkinter is a Python module that is used to develop GUI, that is graphical user interface. There's no need to install any module, as tkinter module is a part of the standard Python library. And here we need to install Twilio. So for that, we will open the command prompt and write the command pip install Twilio and press enter. As it states that the requirement is already satisfied, I have already installed the Twilio module and used it in the project. So you just have to write the command and press enter in the command prompt or in the terminal of your editor, and the rest would be done for you. So moving on, we will import the modules. So from tkinter, we will import all the classes and files, and from Twilio we will import the client class. And to generate the OTP, we will use the random module and generate the OTP with the random function. So we'll import random. And we would also be using the message box, but yeah, we will see it later on. So now we'll create a class in the tkinter. So in order to initialize the class, we use the __ init function. This creates a method that runs itself when we form an object from the class. So we will make a class and name it as OTP verifier, OTP_verifier, and inside we'll pass tk colon, and as I said, we will make the init and pass self init. So we will create a root window and display it on the screen. For that, we will just run window.main loop to pop out the tkinter window. And for that, and before, we will just write the super tkinter provides many methods, and one of them is the geometry method. This method is used to set the dimensions of the tkinter window and is used to set the positions of the main window on the user's desktop. So for that, we will use the geometry function and write the command self.geometry, and inside the circle braces, we will set the y-axis as 1000, cross x-axis with 580, and we would make it shift with 200 dimensions and y-axis, and 80 dimensions in the x-axis. Now we will configure the window. So we will use the config function. So config and configure function, they both are same and they can be used on any widget to change settings that you may have applied earlier or haven't applied yet. So for that, we'll write the command self.configure, and inside we will set the background color as white only for the Tkinter window, and use the hexa code for the colors. You could use hexa code or just write white. So for white we have 6 Fs. You can search for the code, the hexa code, or you could just write the white color. Now we will use the resizable function. So this method is used to allow Tkinter root window to change its size according to the user's need, as well as we can provide the resizing of the Tkinter window. So basically, if you want to create a fixed size window, this method can be used. In resizable method, user can pass either positive integer or true to make the window resizable. Or if you want to prohibit the resizing of the window, you could just pass false or 0. So we would just prohibit it. We will write the command self.resizable So we have prohibited a window, and now before executing code, Python interpreter reads source file and defines few special variables or global variables. If the Python interpreter is running the source file as the main program, it sets the special variable that would be the __ name variable as value equal to main. That value would be equal to __ main. If this file is being imported from another module, so the name variable will be set to the module's name. Module's name is available as value to name variable, that is the global variable. So to execute it, we'll write the command if name equal to main, and that would be in the inverted commas. Here first we will class window equal to _verifier, and now we'll write a command to run the main loop, that is the main thing, to get a window popped up. So we'll save the file and run it. So we got an error here. So it is due to the spaces. We don't have to make spaces in the geometry method. And now we'll save it and run it. You can see that the Tkinter window has popped up. Now we will make its GUI, and before that we will see the Twilio. So this is the Twilio console. You have to log in into that, and that would be your account SID, your token, and the phone number from which you will get the OTP. So I will show you the demo for that. You can just visit the Twilio website. So Twilio is an American company that is based in the San Francisco, which provides programmable communication tools for making and receiving phone calls, sending and receiving text messages, and performing other communication functions using its web service APIs. So this is the website. Here you can just go sign up. As I have the account already, I will just log in it. You will just write the first name, last name, email, and password that should be 16 plus characters, and after that you will accept it and start your free trial. It doesn't need any credit card or something. You can just use it without any payment mode, and after that it will ask you to get your phone number assigned, or it will ask you like what purpose are you serving the Twilio. So you could just make it that you want to run it for your project or any code purpose, and after that you have to generate the phone number from which you will get the SMS. So I have my console already. I have logged in. So going to the code part, now we'll use Twilio to get our OTP on our mobile phones. So for that, we'll write the command in the class only, that is OTP verifier. We will use the client function. For that, we will create a variable self.client, and that is equal to, and use the client function, and inside we'll pass two parameters that would be from the console. That would be the account SID. We will copy that and we'll paste it in the inverted commas, and the next parameter we'll pass is the authorized token that would be unique for you. We will paste this, and that would also be in the inverted commas only. And next we'll write the command self.client.messages. That is, we'll use the variable above, that was the client variable, and we'll create the messages, and here we will write our phone number, that would be 2 and equal to, and inside the brackets we will write the contact number you want to receive the message. So here I am writing my contact number and not highlight it, as I can get the spam messages or spam calls, so I would not highlight it. And we will write the contact number that we have got from the Twilio, and that contact number is my Twilio phone number. We will copy that and write from, so from underscore, and here we will paste the Twilio phone number, comma, and then the body, what body we want to receive as a text message from this number. So the body, we want to receive an OTP. So for that we will use the random module and generate an OTP. So first we will create a variable, store it in a variable n, for that we should use the random module to generate the OTP. For that we will just make a function and name it as OTP only. And inside we will pass self, and in this function we will return the OTP, and that will generate with the rand range function and pass the range. So this function will choose any number from this range and return to us. So we will ask this function to generate a 4-number OTP. Yeah. So we have made the function for the OTP, and now we will assign it to the variable we have declared above. So in this variable, we want that the OTP should be passed as a string, because body would take as number as a string only. So with that, we'll write the command str self.otp in the body. We'll get the variable, and only for that we'll write the command self.m. Now we will save it and run it. So there is an issue here, and it got successfully executed. So sometimes it takes time, and we have to actually universe. Okay. And now we'll start with the GUI, and for that we'll create a function so that we can store all the widgets there, and we will name the function as labels. And first thing we will create would be the canvas widget. The canvas widget lets us display various graphics on the application. It can be used to draw simple shapes to complicated graphs. We can also display various kinds of custom widgets according to our needs. So first we will create a variable and name it as C, and inside we will make the canvas widget. And now we will set its background color, and that I will use the hexacode only. You could just see that's the gray color. You could use the hexacode, or you can just write the name of the color, or if you want you can just search on the web. You would get the hexacodes, and you would get the variations of all the colors in hexacode. And now we'll set the width for the canvas, and width would be equal to 400, as you can see that it is in the comments. We have to put the hexacode in the inverted commas. Yeah. So we've set the width, and now we will set the height. That is 280. And now we will place this canvas. For that we will use the place function, and that place function allows you explicitly set the position and size of a window, either in absolute terms or relative to another window.